Welcome back. In this step, let's set up a few entities as well as some of the data for them. So we'll try and set up the student, passport and review entities and set up some sample data for them for getting started and call this student. And let's see what are the changes that I would need to make. I'll remove the named queries which are present in here because these are not applicable for a student. I'll leave the ID in here. The name is fine and nullable is fine. I'll not worry about the update and the creation timestamp, so I'll remove them. I'll leave the constructor, get name, set name, ID, and toString. I'll change it to print student. So that's cool. That's very quick, isn't it? So we now have our student entity ready. So we have our student with a ID and a name. That's cool. We'll define relationships a little later. But as far as the student is concerned, we are good. So now let's go to the data.sql and set up the data for that as well. So insert into student ID comma name. The values I would want to insert are already defined in our spreadsheet. So ID comma name. So let's copy this 3 times so that I can populate the values a little later. Now the IDs for all the students, we'll start with 20,001, 20,002, 20,003, and Ranga, Adam, Jane. So it's Ranga, Adam, and Jane. That's cool. So we have now the student entity ready, and we have also populated the student data in. That's cool. Now I'll copy the student entity and I'll try and create the next one that we would want to do. That's basically the passport. So passport I've copied pasted in. I need an ID. Instead of the name, we would want to call this number. So I'll rename this. So it's a passport number. I can say passport underscore number, but it's already in the passport field, passport entity. So it's a passport number anyway. So I'm renaming the thing. So number, I'll go ahead and do that. Passport number cannot be null. That's cool. The only thing is I'll change the thing in here. It should be number. And I'll change the getter as well. Number, set number. I mean, I can leave the name in here, but I would rather be consistent. Number, get ID. And here, let's print the passport with the number. So we now have the passport ready. So we have the passport data ready. So let's do that quickly as well. I'll say insert into passport. We have 40,001. So we start with 40,001, 40,002, 40,003. This is kind of simple convention I use just so that we are not confused with the IDs. So all the students start with 20,000, all passport starts with 40,000 and things like that. Passport number, let's give some random numbers. It doesn't really matter what numbers these are. 1, 2, 3, 4, 5, 7 and L123890. I'll also copy this into the spreadsheet so that this will be useful when we are discussing them. That's cool. So we have a passport table with data set. This is not a name, this is going to be a number. So now we have the passport entity also defined. So we have the passport ready with an ID and a number. The last one we want to do is to set up a review table with a rating and a description. What I would do is I will copy the student and we would want to call this a review. Let's go ahead and quickly do this. This is ID. I would want to have description as a string. And let's description this, I would want to rename this to description, and this should be set description. Choose description here and here as well. What we are doing is quickly creating the entities. So let's review and %s description. That's cool. So now we have a review with a description. But the thing is, when we create a review, you might not always give a description. So I don't really want to make the nullable else false for this. So I'll leave it like this. I'll remove the at nullable thing. because I would want description to be nullable. Null is a valid value inside the description, so that's good. And I would also want to have a rating. For now, I'll define the rating as a string. At a later point in time, we'll define custom ratings. So for now, I would want to just say string rating. And whenever I create a review, I'd want to create it with both the rating and the description. So I'll say this is what rating is equal to rating. That's cool. And in the toString, I would want to add in the rating as well. So rating comma description. Now we have everything here. All that I need is the getters for the rating. Alt Shift S, generate getters and setters, right click source or right click generate source. And I would want the getters and setters for rating. That's it. So now we have the review entity setup. That's cool. We would populate the reviews in here as well. Let's copy the data for passport. So we have ID. So insert into review. We have ID, rating, and description. And rating can be, let's just say 1 for now, and create course. I'll make it 5. Let's focus on adding a few more rows quickly. So 40,001, I would want to really use 50,001 and 50,002 and 50,003. And let's say this is 4 and this is 5 again. Wonderful course. Awesome course. So we have our review, we have our passport, we have our student setup. What I'll do is I'll quickly start the application and see what would happen. Before we start the application, I'd also want to clear out the stuff which we are doing in the demo application. I've commented it out. So all the data that would be there in the table at the end of the whole thing is whatever we are creating in here. So we are now having a course table, a student table, a passport table, and a review table. Let's see if it all works out fine. Let's stop and start the application. I'm starting the application right now, and let's see what would be present in the log. The application is starting up. Oops, when I started the application, I found out that I made a mistake. Actually, the student should have been passport. So let's change that. So these two rows had the wrong table name. They should have been passport instead of the student. Let's fix that. Let's now relaunch the application and see if everything is working fine. I'll go and launch the demo application. The application is starting up. Cool. Now, if I look at the log, you would see that there is a lot more log which is being present right now. So we are creating a table called course, we are creating a table called passport, we are creating a table called review, and we are creating a table called student as well. And that's very good. And also the data.sql files are getting executed in here, and all the data is getting populated. Let's quickly look at the H2 console to see what data is present in these tables. Connect, and let's run select start from course. We have all the course details that we expected. Passport, yep, the passport details are here. Review, yep, the reviews are here as well. And last one is the student table. Let's get that working very soon. Okay, there you go. So now we have all the entities set up. But the thing is, these entities are not really related to each other yet. So there is no relationship between course and student. There is no relationship between student and passport. Over the next few steps, we will create the relationships between these tables. I'll talk to you in the next step. Welcome back. In this step, we would start with something called a one-to-one relationship. A student can have one passport, and the passport can be associated with one student. This is called a one-to-one relationship. So now I would want to connect Ranga with his passport. His passport is E123456. How do I do that? There are two ways you can actually do something of that kind. Here, I can create a field called passport ID. So in the student table, I can create a field called passport ID. Or the other option is in the passport, I can create a field called student ID. So these two options, any of them would work. So either I can create the column in the student or I can create this column in the passport. What I can do is in student, create a passport underscore ID and populate the ID. So I can say 4000, 40,001. Now, when we look at the data, we can easily now say that this particular passport belongs to Ranga. So we can say 40,001. So this is Ranga's passport number. When you have passport ID here, then student table is owning the relationship. So it said that student table is now owning the relationship. So it has the passport ID. So it's said to be owning the relationship. The other way we can do this is the passport column having student ID. So student ID and student ID is 20,001 for Ranga. So here it would be 20,001. In this kind of a situation, the passport is said to be owning the relationship. Let's shift our attention to defining this relationship between our entities. So let's go to Eclipse. I'm opening up the student and the passport entities. There is one-to-one relationship between the student and the passport. So the way we can define that is by saying private passport. So a student can have one passport. So I'll say private passport, passport. That's cool, right? And on the reverse side, a passport can be associated with one student. Let's not really get there yet. Let's just focus on the student. So a student can have one passport, and this passport relationship is 1-to-1. So I'm using the 1-to-1 annotation which is present in JPA. So JPA persistence 1-to-1. Let's see what would happen now. Let's restart the application and see what would happen. Cool, the application starts up fine. And let's go to the H2 console, refresh it, select start from student. You can see that now the student has something called a passport ID. The student table now is owning the relationship. The passport ID is present. Where is it present? It's present with the student. Don't worry about all the data which is present in here. It's still null. So that's not a problem. We'll fix that very soon. How can we fix that? We would now need to add in another column in the student. So until now we are only inserting ID and name, but we want to associate it with a passport as well. Now I would want to add a passport ID as well. Passport ID. Passport ID. And the passport ID is what is present in here. 40,001, 40,002. Other one is 40,003. Let's go ahead and put it in here. When I'm inserting the student, I'm saying passport ID is 40,001. But inside the passport table, 40,001 is not yet defined. So I would need to first insert the passport as 40,001, and then I can say this student uses the row 40,001. So I would want to insert the passport first and then the student. Let's see what would happen now. Let's start the application again and refresh our H2 console. Select start from student. Now has the passport ID populated as well. If you're familiar with using joins, then the way we can retrieve the data for both student and his passport is by saying select start from student comma passport, where student dot passport ID is equal to passport dot ID. So this would get all the details of both the student and the passport together. So I would get student ID 2001, Ranga, passport is 40,001, and the passport number is E123456. So we can use this query to get all the details of a student, including his passport. Let's quickly review what's happening in the log. So if you look at the log right now, we create the course table, we are creating the passport table, and you can see that the student table, as we saw in the H2 console, has a field called passport ID. And also you would see that constraint added in. It says the student table has a foreign key called a passport ID. What does that mean? So what we are saying is the passport ID is a foreign key. A foreign key is nothing but a ID of another table. So this passport ID is the ID in the passport table. It's the primary key in the passport table. We take the primary key in the passport table and use it to reference that passport in the student table. In these kind of situations, the passport ID is called a foreign key in the student table. In the student table, passport ID is a foreign key. 40,001 is a foreign key. Typically, the foreign keys are primary keys in one of the other tables. In this situation, this passport ID is the primary key in the passport table. So what is happening is the passport table gets created and the passport ID is used as a foreign key in the student table. We are using the passport ID to reference the passport of a student. Instead of putting all the passport details in the student table itself, what we are doing is we are creating a separate table for passport and using the ID from that table as a foreign key in the student table. In this step, what we looked at is how we can define a one-to-one relationship using JPA. In the next step, we would talk further about the one-to-one relationship. Until the next step, bye-bye. Welcome back. In the previous step, we established one-to-one relationship between the student and his passport. Let's get started now. What I would want to start with is creating a repository for the student. So right now we only created the entity for student. We don't really have the repository for it. So let's copy the course repository and call it student repository. And what I will also do is Control F at find, Control F or Command F, find, replace. So I would want to find course and replace it with student. Be careful with the case. So capital course, capital student, and I'm using a case sensitive replace. So be very careful. I don't want to replace the variable names. I only want to replace the class names. So let's go ahead and do that. Replace all. You'd see that all the classes are replaced now. Next, I'll replace the variables as well. Course with student. Now you can see small course, small student, replace all. Control Shift O to organize your imports, and now you're all set. You see how easy it was to migrate from student repository, from the course repository to the student repository. A lot of the code which we write with entity manager is the same irrespective of the entity we are trying to manage. All that would be changing would be the class name, the variable names, and things like that. We would discuss this a lot more when we talk about Spring Data JPA, but for now, let's live with the entity manager and use it to create a student. What we want to save is a student down. So we would want to save a student down. So when I get a student, what I would get along with it is a passport. So let's create a separate method. I'll call this save student with passport. So I would want to create a passport, I would want to create a student, and I would want to save the student down. So let's start with that. Passport is equal to new passport of, let's take a number. Let's start with Z, 1, 2, 3, 4, 5, 6. So I've created a passport. Now I would go ahead and create a student as well. So student, we have it here. So I'll remove all the stuff after this. I don't need the student 2 stuff. So let's remove this out. I'll call this new student of Mike, and I would persist student 1. So we are creating a passport, we are creating a student, and I'm trying to persist the student. Will this save the passport? Will this save the passport and map it to the student? It will not, because we have not established the relationship between the student and the passport. We need to say student.set passport. However, we forgot one important thing. There is no getter and setter for passport. So let's go ahead and create that in here. So I'll go here and say Alt Shift S, generate getters and setters, and I would say generate passport getters and setters. So this would enable us to get the passport details of a student and set the passport details as well. So let's try and save it right now. So passport is equal to new passport, student is equal to new student of Mike, student dot set passport, passport, and entity manager dot persist student. So will this work? Let's check it out. Let's call this from our runner. So we have the demo application. So let's go there. We'll change the course repository. Instead of course repository, I would want to use the student repository. So I'll say student repository. And because we have now two repositories, I would need to make it explicit which one is which. So course repository, student repository, and let's go further down and now start playing with our student repository. Student repository, oops, it's not recognizing the student repository. Organize imports, and student repository dot save student with passport. So for now, we are hard coding values. That's not really a problem. So what we are trying to do is save the student down with the passport details. Will this work? Think about it. I'll start the application in the meanwhile. When I started the application, what I see is an exception. It's saying transient property value exception. It's saying passport is transient. Passport has not yet been saved to the database. So you are setting a passport to the student, but the passport is not yet in the database. If the passport is not yet in the database, how do you create a relationship with it? So let's go ahead and fix that. So entity manager dot persist passport. So first we persist the passport, then we create a student, establish the relationship with the passport, and persist the student. This is the right order of steps when we talk about relationships. The student is the owning side of the relationship because it contains the passport ID. So before we are able to create a student, we should create the passport. So we create the passport, create an ID for it, then we go into creating the student. So what I'll do now is I'll put this into debug mode so that we can look at what's happening in the background. So let's start in debug mode, demo application. I would want to use the debug perspective, please. Okay, cool. So now we are in the debug perspective. We are at the place where we are creating the passport. So I'll do a function F6 and it's now trying to create the passport. So what I'll do is I'll clear out the console. Let's look at console in detail. So I'll move it a little bit up so that we can clearly see what's happening. Function F6 again. You can see that em.persist passport. So it actually created a sequence. So it called the Hibernate sequence, and you can see that the ID of the passport is now assigned. So it has an ID. What is the ID of the passport? 1. So passport has an ID. Now what would happen when I do this? Function F6 again. Student is created. I'll clear the console again. Student.set passport, passport, nothing goes to the database. Now we are trying to persist the student. So what would happen whenever I try to persist the student? Again, the next value for Hibernate sequence is called. At the end of the transaction is when Hibernate would send all the database changes down to the database. So we have the student ID, we have the passport ID. When I press function F8, you'd see that all the next steps would happen. You'd see that insert into passport number comma ID. So a row is inserted into passport with an ID 1. So a new row is created in passport with an ID 1, and a new row is created in student with name as Mike, passport ID as 1. This is the student ID, right? This student ID is 2. So we have now created a relationship between the student and the passport as well. So now I can go to the console, refresh the page, connect, and I'm running the select start from passport. Here is the new passport that we have created in 1Z123456. And if I go to the student, what would I see? I would see select start from student. I'm seeing Mike. What is the passport ID of Mike? 1. So ID is 2. So now if I join the tables, select start from student comma passport, where student.id, oops, actually student.passport ID is equal to passport.id. Let's do this. Now you'd see the entire row for Mike. Mike with a passport of Z123456 is now in the database. The student details are in the student table, the passport is created, and the relationship is created through the column passport ID within the student table. So we have successfully inserted a new student with a passport with a one-to-one relationship present. Let's end this step here, and I'll see you in the next step. In this step, let's write a simple unit test to retrieve the student details as well as his passport details. There is an important concept we'll also learn called eager fetching. I'm copying the course repository test and saying student repository test, saying OK. And now let's go ahead and play with the student repository test to get the details of a student. So we would need the logger. Instead of the course repository, we would be using the student repository. And I would get rid of all the other stuff which is present in here. What we want to do is retrieve the details of the student and his passport. Retrieve student and passport details. Over here in the student repository, we have a find by ID. So this would find the student. However, we would want to also get the passport details. In the test, what we'll do is we will start with using the entity manager. So let's say I'm auto wiring in the entity manager to understand what's happening in the background. Entity manager, EM, organize the imports, everything would be imported and fine. EM dot find, I would want to get the student dot class, and the primary key, I would want to pass in the student ID. Let's go to the data.sql and find the student ID. The student ID, let's say, is 20001. So this would retrieve the student for us. And let's assign this to a new field. Oops, I don't want to create a new field. Let's assign this to a new local variable. So student is this, and let's log the student details, logger.info, student. And we would want to get his passport details as well. Remember, the passport details are in a different table. So let's see what would happen. I'm just saying student.getPassport, and I'm doing a logger.info. Let's quickly write the code up. So student passport details are this. Let's now try to debug this and see what is happening in the background. Right click, debug as JUnit test. It would start up the entire Spring Boot application, and it would start the debug perspective again. I don't really want to worry about this, so I'll remove the breakpoint and do a function F8, because what we are really interested in is what's happening in the test. So we are now at the test. So I'm doing a em.find student.class 20001. So let's go to the console, remove everything out from here, and do function F6. Okay, let's see what is happening. em.find is triggered. So I'm trying to find a student. So I'm getting a student. You can see how it's now joining passport as well. So the query by default is also getting the passport details. One of the important things that you need to remember is the fact that any one-to-one relationship is always eager fetch. That means if you have a one-to-one relationship, the student details are retrieved and the passport details are also retrieved, because student and passport have a one-to-one relationship. You can see that we have both the student details and the passport details present. So we got the student details as well as the passport details as well, even though I have not really requested for the passport details yet. Let's clear this out and say function F6. The student details are printed out. You can see student is Ranga, and function F6, you can see that the passport details are printed out. Passport is E123456. That's cool. And now I can actually function F8 to complete the execution. One of the things which we noticed is how when we are trying to fetch the details, they are eagerly fetched. Whenever we are fetching the student details, the passport details are also fetched along with it. This is called eager fetching. We will talk about eager fetching and also talk about how to convert this to lazy fetching in the next step. Until then, bye bye. In the last step, we saw how eager fetching is done. Even though I'm just retrieving the student details, the passport details were also retrieved. So to make it very clear, I'll remove this and run this again. So I'm not trying to get the student.get passport details at all. And let's run the unit test again. What is happening here? You can see that even though I'm not trying to get the passport details, the left outer join on the passport is still done. So I'm not trying to retrieve the passport details. I'm only trying to retrieve the student details. Even then, the left outer join is being performed. The join is performed to retrieve the student and the passport details. In lot of situations, this might give you performance issues because I might want to only retrieve the student. I don't want to retrieve the passport. Then you are unnecessarily retrieving the details of the passport. How do I avoid doing that? The way you can avoid doing that is by going to the student and you can specify a fetch. You can specify fetch is equal to fetch type dot lazy. So let's go back to our test. I will uncomment this and let's see what would happen. Let's try and debug this. Right click, debug as JUnit test. Okay, let's clear this out. I'm trying to retrieve the details, function F6. Okay, that's cool. So now what would happen? So you can see the select query is only fired on the student. So the query is select star from student where student.id is equal to this. So all the mapping is happening. The student details are retrieved. Now you would see that student repository test, student details are printed. Let's clear console again. Let's do a function F6 again. Now you'd see that I'm getting a lazy initialization exception because what is happening here is by the time the entity manager.find method is run, the transaction ends right then and there. So the transaction is needed for us to be able to retrieve the details of the get passport. We need to have a session. So here it's saying there is no session. Because we are not having any transaction in here, the session gets ended as soon as this statement gets executed. What we'll do is we'll function F8 to end the test and I would put a transactional on this. So the scope of the transaction, now I'm extending it for the entire test, not for just this, but the entire test is within a transaction. Let's quickly debug this. We'll discuss a lot more about transaction management and the scope of the session a little later. Let's now function F6. Student query gets fired. Function F6 again. Student details are being printed to the console. So that's cool. So let's do this. And now I say function F6. Now, because I put a transactional, this session is still live. The session was only killed at the end of the test. So it is now going to the database and executing the select star from passport. See what is happening here? As soon as I say student.get passport, Hibernate knows that the passport details are not yet retrieved. So what it does, it goes and executes a query and populates the passport details and prints them out here. This is what is called as lazy fetching. Lazy fetching is you get the details only when they are needed. And the great thing about Hibernate is the fact that I'm not telling anything about how to get the details of the passport. Student is a different table, passport is a different table, but still Hibernate is able to get the details for you. That's because we have done the mapping. We established the mapping in here. We said student is one-to-one with passport and passport details are stored in the passport table. So just by defining a simple mapping, we are able to retrieve the details of the other related entity just by using a simple get passport. This is the magic of Hibernate. I would recommend you to play around with this example a lot more, and I will see you in the next step. Welcome back. In the previous steps, we have been using the terms session, entity manager, persistence context, and transaction. We will use this step as a primer to understand all these concepts in depth. So what we want to do is a set of database operations, right? I want to perform a database operation 1, database operation 2, database operation 3. The operations can be retrieve or updates. So here there can be another operation, let's say update of a student. So you can see that this set of operations have 2 retrieves and 2 updates. So let's say this was retrieved by using the standard way. So I'm doing something of this kind. Student dot find this particular thing. So this database operation is the number 1 operation, that is to retrieve the student. For the second operation, I'm not using the entity manager to retrieve the passport because I have the student already. I am directly saying student dot get passport. And the third operation is to update the passport. So I'll say passport is equal to student dot get passport. What I'll do is import it, Control Shift O. Here I would want to say passport dot set number. Let's make it E123457 then. So I'll make it E123457. That's cool. So we are updating the passport, and also I would want to set the name of the student to something else. So student dot set name. I'd want to set the name to Ranga updated. There are a lot of operations that I am performing in this step. Let's assume that this update failed, the name update failed. Should the whole thing succeed or should the whole thing fail? What should be the state of the database after this particular operation? Ideally, when we are talking about a transaction, everything should succeed or nothing should succeed. So if this operation fails, all the changes done to the database before this should be rolled back. That's why we use a concept called at transactional. We will talk about Spring transactional and JPA transactional when we talk about transaction management in detail. But for now, the important thing for you to understand is if this update fails, then everything, all changes before this will be rolled back. That's the importance of having the at transactional in here. This is a transaction. The thing with JPA is as soon as you define a transaction, you'd also be creating something called a persistence context. So the persistence context is a place where all the entities which you are operating upon are being stored. So student, I got it from the database. So at this point in time, what would be in this persistence context? The persistence context will have this particular instance of the student. After this, what would be the persistence context containing? Student and the passport. Both of these are in the persistence context. And over here, you are updating, making the change in the persistence context. So you're making a change to the passport. So what would be in the persistence context? Passport plus plus. And here, what would be in the persistence context? Student plus plus passport plus plus. And only after the entire transaction is completed, the database changes are sent out to the database. You would see that the exact queries will be fired at the end of the entire method, at the end of the transaction. We said at transactional, so a transaction would be started here and it would end here, and only at the end of the transaction all the changes are sent out to the database. The way we interact with the persistence context is by using an entity manager. So whenever we call a method on the entity manager, what we are really playing with is the persistence context. The persistence context is where all the changes that we are doing are kept track of, and persistence context is created at the start of the transaction and killed as soon as the transaction is ended. So let's say there is no a transactional in here. So there is no transaction that we are creating explicitly in the test. So in this sum test right now, I removed the at transactional. Let's comment this out. So there is no at transactional right now. What would happen? There is no at transactional, so there is no transaction created. Each call will act as if its own transaction. So at the start of a find, a transaction would be open and closed. So there is the persistence context is closed as soon as the find is executed. So if there is no transaction, if I'm trying to do a student.get passport, you would get an exception. So I'm running this right now, right click run as JUnit test. You'd see that this test would fail because of an exception. The test fails because it says Hibernate lazy initialization exception, could not initialize proxy, no session. So it's saying there is no session present. That's the Hibernate word, session. So it's saying I don't have a session to be able to retrieve the details of the student because the persistence context is closed by then. There is no transaction we are creating. So what happens? Each entity manager method call, it's its own transaction. And here, when we do a student.get passport, we are not using the entity manager at all. So there is no session or there is no persistence context. The other thing which we have been doing until now is we have a transactional on all the student repository methods. So let's say I was doing the same thing that I'm doing in here. So let's get this all stuff. I'll extract a method out, Alt Shift M, or right click refactor extract method, and let's call this some dummy operation. The name doesn't really matter. What matters is the fact that I'm creating a method. So I'm taking this dummy operation, and where am I putting it into? The student repository. So I'm putting the dummy operation into the student repository, and now I can go to the student repository and call the dummy operation. How can I call the dummy operation? By using the repository variable. So repository.some dummy operation. Why is it giving me a problem? Because it's a private method. Let's make this public as well. And let's give a good name to it. It's not dummy operation, some operation to understand persistence context. Let's call it that. So what would happen is we now have this operation, repository.some operation to understand persistence context, which is called from here. I'll remove the at transactional here. So we are removing the transactional from the test. What would happen? The transaction support is now being provided by the student repository. So we have a transactional here. So the entire method, around this entire method, there would be a transaction that is created. So the persistence context would be created at the start here, and it would be closed at the end in here. So what you would see now is this test would succeed. So if I do a right click, run as JUnit test here, you'd see that the test succeeds. And when you look into the log, you would see that the queries are fired in the right order. So we are doing a select, we are doing a select again, and we are doing an update here and the update again. So in the right order, update student, update passport, and we have the two selects being fired, and they are able to successfully execute because we have a transactional in the repository. So either in the test or in the repository, you should have at transaction present. So to summarize, whenever I start a transaction, whenever I put a at transactional on a method, what would happen is everything from then on to the close of the method will be part of a single transaction. So either all of them will succeed or none of them will succeed. The second important thing is at the start of the transaction, a persistence context is created and it is closed at the end of the transaction. So it starts here and ends at the end of the method. And the persistence context acts as two things. One is it acts as the store for different entities that are being managed. Here we were managing student passport plus plus. So whatever changes are there done, all of them are tracked by the persistence context. Persistence context also gives you access to the database. So student is being managed by the persistence context. If you do student.get passport, the persistence context would make sure that the query is fired on the database, you get the details back, and populated into the passport. So it also gives you access to the database. In JPA, we use Entity Manager to talk to the persistence context. Entity Manager is the interface to the persistence context. Hibernate used the terms called session and session factory. If you want to use JPA, you don't really need to worry about session and session factory. All that we need to worry about is Entity Manager, persistence context, and understand the transaction. And the Hibernate session and session factory are no longer important for you. Until the next step, bye-bye. Welcome back. In the previous steps, we discussed one-to-one relationship between the passport and the student. We have a column called passport ID in the student representing the passport ID for a specific student. In the student entity, we have added in a passport and we added in a one-to-one relationship in here. And now we can get the student and we are also able to get the passport details of the student. We were able to write a simple unit test where we got the student, and to get the passport details of the student, all that we had to do was do student.getPassport. Now, I would want to do the same thing for the reverse as well. I would want to be able to get a passport from the database using the entity manager and get the details of the student the passport is associated with. Until now, we were going from student to passport. I would also want to be able to go from passport to this student. What we have created earlier, the relationship between student and passport. So we are able to get student and get his passport, student.getPassport. That's called a unidirectional relationship. So from student I can go to passport, but from passport I don't have a way right now to go to student. I cannot get a passport details and get the student details that is associated with that particular passport as things stands right now. That's exactly what we would want to fix in this specific step. Let's get started with it. So I'm going to the passport entity. Think about it. What should I do to add a student in here? So I would want to be able to connect back to the student. How do I do that? The way I would be able to do that is by using a one-to-one relationship in here. So I would still keep the one-to-one relationship as fish type lazy. This should not be a passport. This will be a student and student as well. Let's organize the imports and let's generate the getters and setters quickly. Generate right click source, generate getters and setters. I want to generate the getters and setters for the student. That's cool. I don't want them in here. So I'll move them a little down right below the number. That's cool. There's a relationship between the passport and the student. Let's see what would happen. Is this all you'd need to do? Let's see what would happen when I restart the application. What kind of tables get created? The application has started up and I'm launching up H2 console now. So we have in the passport now a column called student ID. So student has passport ID and passport has student ID. This is the kind of data that we have right now. So we have a student and student table has a passport ID and the passport table has a student ID. So 2001 or 20001 is associated with passport ID 40001 and 40001 is associated with 20001. This is duplication of information, right? So the association between 20001 and 40001 is being stored in two different places right now, in two different rows, in two different tables, and that's not good. In database, one of the most important things to have good data quality is to ensure that you're not duplicating the same information again and again. So the option we have typically is to make one of these entities the owning side of the relationship. I should either make the passport the owning side or the student the owning side of the relationship. By the owning side of the relationship, I mean that either student should have the passport ID or passport should have the student ID. If student has the passport ID, then student is the owning side of the relationship. If passport has the student ID, then passport will be the owning side of the relationship. Let's shift our attention to declaring the owning side of the relationship in the mappings. So I don't want the current situation. I don't want student ID in passport. So now I can make either the passport or the student owning side of the relationship. For now, let's keep student as the owning side of the relationship. The way we can do that is by adding a mapped by. So you just need to say mapped by and put in what is the name of the variable. So in student, what is the name of the variable this is mapped by? This is mapped by passport. So I'm taking this and putting it in here. So that's all you would need to do to add a mapped by to make the student a owning side of the relationship. Now the most important thing is I want to make student the owning side of the relationship. I'm adding mapped by on the passport. So you don't add mapped by on the owning side of the relationship. You would add mapped by on the non-owning side of the relationship. Passport is the non-owning side of the relationship, and that's where we are adding in the mapped by. So let's see what would happen. I'll stop the application and start it again. Let's see what's happening in the H2 console. Connect the passport table and the student table. Now you can see that the student table has a passport ID, but the passport table does not have a student ID. This is good. From the table design point of view, we are clear. So we now have student and passport. We have the relationship established between the entities as well. From the student, I can navigate to the passport student.get passport. From the passport, I can navigate to the student as well, but we have not checked that out yet. What we'll do in the next step is we'll see how to get a passport and get the details of a specific student for that particular passport. Until the next step, bye-bye. Welcome back. In this step, let's see how to get the details of a student associated with a passport. I'll copy the test which is written already. So I'll copy retrieve student and passport details, and I'll rename this. So I'll say retrieve passport and associated student. And let's try and retrieve this passport. So the way we would get the passport is simple, right? So instead of student, I would say passport in here. This would be passport.class, and the ID would be little different. So let's see what the ID should be. Let's open up the data.sql and see what the ID of the passport is. So 40,001. I'll pick this up from here. So I would want 40,001L. This is the organize imports, and over here this is not student anymore. This is passport, and the associated student with the passport is this. So student is passport dot get student. So this is exactly the reverse of what we were doing with the student. Earlier we were trying to get the student and trying to get his passport. So to get the student, we were using the entity manager, and to get the passport, we are using the relationship that we have defined between the student and the passport. Here we are doing the reverse. The most important difference in here is over here student is the owning side of the relationship. So student owns the column passport underscore ID. The passport underscore ID column is present in the student table. So that's why it's called the owning side of the relationship. However, if I look at the passport, it has the one-to-one relationship defined, but we have this map by attribute. What the mapped by attribute ensures that in the passport table, the student ID column is not created. So passport is not the owning side of the relationship. The column would be stored in student, but this at one-to-one annotation gives us a way to navigate from the passport to the student. So even though there is no column associated with this, this gives us a way to navigate from the passport to the student, and this is what is called bidirectional navigation. Let's now run this test and see what would happen. So I'm running this test, right click, run as JUnit test. Test succeeds, that's very cool. However, what we are interested in is really what's happening in the background. You can see here that we are first getting the passport details, we are getting the student details, and you can see that the passport details are being printed out, passport E123456, and the student details are being printed out as well. From the passport, we are now able to navigate to the student. In the last few steps, we focused a lot on the one-to-one relationship between student and passport. We have now a bi-directional one-to-one relationship in the sense that I can navigate from student and say student.get passport and get his passport details. And also from passport, I'm able to navigate back to the student as well. All that we had to do was to define a simple relationship at one-to-one over the owning side. I'm saying just at one-to-one. On the other side of the relationship, we just put a mapped by in addition. So we say at one-to-one with a mapped by, mapping back to the variable that we have defined in here. I'll see you in the next step. We would be moving on to the other kind of relationships. Until then, bye-bye. Welcome back. In the last few steps, we looked at a lot of details related to a transaction. We saw how queries are being fired to the database in the background. This is a quick review video where we would take an in-depth look at what happens in a transaction, what happens behind the screens. When does the changes you make to your entities get saved to the database? And what are the different tips and tricks that you would need to know? Let's get started. Let's take some simple method, right? So this method is making a change to the database. So let's say it's creating a couple of users, it's trying to persist them, and then it makes changes to the user 1 and the user 2. We saw that when something of this kind happens, both the insert queries get fired, so the user 1 and user 2 are inserted, and also the update queries get fired. So the update queries to make the changes which we make. So if I'm changing the user 1 age, then those update queries are also fired. The important thing to notice is when do these queries get fired? The most important thing you would see is Hibernate waits until the last possible moment before it would start persisting the changes. So the transaction starts here because we put a at transactional in here, right? So we made this part of a transaction. The transaction starts here and it ends here. So it starts on line 17 and ends on line 27. So whatever changes you are trying to make, Hibernate will wait until the last possible moment before it saves them to the database. That is a really efficient thing to do, because if let's say some of the updates failed, what we want to do, if let's say the update we do on 24 fails, then what we want to do is, because this whole thing is part of one transaction, we would want to roll back all the changes. Hibernate says, why do I need to roll back? Hibernate says, by default, I will try and have all the changes with me. I will try and manage all the changes by myself. When I do em.persist user1, the only thing which gets fired is a sequence to assign a ID to user1. So ID is assigned to user1, but the real user1 will not be saved to the database. em.persist user2, an ID is assigned to user2, but the real user2 is not saved to the database yet. You make a change, user1.age is equal to something. Then the change, because the user1 is part of the persistence context, user1 is being tracked by the entity manager, so it's part of the persistence context. You're making a change to user1, so the persistent context recognizes the fact that, okay, this guy is changing user1, this guy is changing user2, so I have to send an update. So persistence context keeps track of the changes. By the time it comes to line 26, it will say, okay, I have to insert user 1, I have to insert user 2. There's a modification on user 1 on this line, and there's a modification on user 2 on this line. But it does not really save them down to the database. The actual inserts happen after the entire transaction is completed. So it's at this phase that all changes are saved down to the database. Always remember, Hibernate waits until the last possible moment before saving down all changes to your database. I would recommend you to try a simple example. So you can try a simple example, take one of the examples which we worked on earlier and try and revise and make sure that you understand this concept. So even though I'm making a change in here, this change does not really go to the database until the last line is executed. Last line in that transaction is executed. Is that the only way to do things? Nope. If you really want to push some of the changes to the database, you can say em.flush. So a flush would push all the changes that you made until then down to the database. So here I have inserted two users. So what would happen? These queries are fired down to the database. There are two ways you can make your changes go to the database. One is to call the flush. Then those changes are sent down to the database. The query is sent to the database. So the insert queries for user 1 and user 2 are sent to the database on line 23 right now. The important thing for you to understand is the fact that even though I'm doing a flush here, let's say there is a change user 1 and this update fails. So let's say the update Hibernate does to this user 1 fails. Even though I have flushed to the database, what Hibernate does is it will roll back every change that I have done before that. So Hibernate, even if I do a flush, Hibernate would ensure that all the changes that are made before this are rolled back. In this quick video, until now, the most important point we discussed is that Hibernate waits until the last possible moment, until the end of the transaction before it sends the update and the insert queries down to the database, except when we say entity manager dot flush. I'll see you in the next step. Welcome back. In this small video, we will discuss why do we need a transactional in some of the unit tests. If you looked at a couple of unit tests that we wrote before, we used a transactional sometimes. Why do we need it? One of the things is whenever you're making a change on the database, you would definitely need a transaction. So if I'm sending an update or a delete to the database, you have to do it within a transaction, and that is provided by at transactional. When I put at transactional on a method, then the entire logic in that method and the method it calls are within the boundaries of a transaction. If you look at all the repositories that we created until now, for example, the course repository, all of them have a transactional at the top. That means each method in the course repository runs within a transaction. So if from a unit test, let's say I'm calling a repository and the repository makes use of the entity manager, then we don't really have a problem. So if the repository is making the change, the code in the repository is already in the boundary of a transaction. That's not a problem at all, because the transaction starts and ends inside the repository method. But if I am directly making changes from a unit test, so let's say in a unit test, I'm directly using the entity manager to insert a row or update a row, then what would happen? There is no transaction that is directly created because there is no at transactional on any of the things. The unit test method does not have a transaction, so this kind of thing fails. In these kind of situations where you want to directly use an entity manager to do the updates in a unit test, you would need to add at transactional. This would ensure that the unit test runs within a transaction and the changes that you are doing to the entity manager through the entity manager are also within the scope of that transaction. The important thing for you to understand is if you want to do any change to the database using JPA, you would need a transaction. And when we are interacting through a repository like a course repository, we are providing a transaction in the repository. However, if we directly use the entity manager in a unit test, then the unit test has to provide the transaction boundary, and that's what we do using the @transactional. Until the next step, bye bye. Welcome back. Some of the times in the previous steps, you saw that even for read-only methods, we added in a transactional. Do we really need a transactional on read-only methods? Do we need to run read-only methods within a transaction? Let's try and answer that in this specific small video. Let's consider there are two entities, right? User and comment. So let's say user is posting a lot of comments on, let's say, his friend's post or whatever. So we have user and comment. So a single user can post multiple comments. However, a single comment is always associated with single user. So it's like a user, I'm trying to get the comments. So we have a simple read-only method in here, right? So I have em.find user, I'm trying to find the user, and I'm getting the list of his comments. Aha, friends, comments actually. Let's say, yeah. So we are trying to get the list of his comments. So let's say there is no transaction here. So if there is no transaction, what happens is em.find user.class. So we are trying to get the user, specific user with an ID 1. This executes successfully. So I would get the user details back. So entity manager would provide the user details. However, you'd see that this line would throw an exception. The first question in your mind might be, why does this line succeed? Why does line 8 succeed and line 10 fail? Because we don't have a transaction until now. This is not having a transactional. So this is not running within a transaction. But why does line 8 succeed and line 10 fail? The thing is, in line 8, what we are using is an entity manager. So we are using entity manager to find the class and retrieve the details back. We are using entity manager to find the entity. The thing is, in entity manager, there is a default transaction that you would make use of. But the thing is, this transaction would end as soon as the find method is executed. So transaction, if you don't provide a transaction, so over here I'm not providing a transaction. So there is a default transaction which is made use of by the entity manager, but the transaction ends as soon as the find method executes. So as soon as the user details are retrieved, the transaction ends. However, if you look at this line of code, are we making use of the entity manager? Nope. So there is nothing here to provide us a transaction. However, what we want to do here is when I do user.get comments, we would need to fire a query to the database to retrieve the comments. Let's assume that there is no eager loading in here. Let's assume that the comments are lazily loaded. I would need to really fire a query to the database to get the comments back. If I want to fire a query to the database, I need a connection to the database and I need a transaction. Without a transaction, you don't have a connection to the database, so you would see that this line would fail. The main difference between these two lines is the fact that here I'm using the entity manager to retrieve the details. Here I'm not using the entity manager. I am using the fact that user is already connected to comments. I've established a many-to-one relationship between the user and the comments, and I'm planning to use that relationship to retrieve the details. And if I'm trying to use the relationships to get the details, then it should already be within an existing transaction. And that's what we do by putting an @transactional. So the important thing for you to realize is the fact that as long as you're firing queries through the entity manager, it's fine. You are hunky and dory. Your read-only methods do not really need a transaction. But the moment you're trying to use a indirect way, a relationship, for example, to fire the query, then you definitely need a transaction. And that's what we provide through the at transactional. I would recommend you to try and play around with one of the relationship you have established already. Take a couple of entities which already have relationship between them and try and play around with it to explore this further. Until next step, bye bye. We are checking if the update is running fine and we are asserting it in here. But the side effect of this is the fact that the data in the database is getting changed. So the JPA in 50 steps, the data is no longer JPA in 50 steps. The data is JPA in 50 steps updated. Now, whenever a new developer comes in, let's say a new developer comes in and writes another test, he sees data.sql and he writes a unit test which assumes that this description is JPA in 50 steps. He does not know that you have already written a test to update the data to JPA in 50 steps updated. What would happen? When he runs his own unit test, the test would succeed because he's only running his unit test. But when you run both your unit test and his unit test, let's say he wrote the unit test in the same class and your unit test runs before your colleague's unit test. You are changing the data and your friend's test starts failing, and that's not a good situation to be in. That's why what we'll do is in each of the unit test methods, what we want to do is we should leave the data in a consistent state. We should leave the data as it was before you executed the unit test. That's why what we'll do is we'll get the course, we'll update the course, we'll check that the update is properly done, and then the add dirties context would ensure that all the changes which are done in this test are rolled back. So whatever changes you have done here will be rolled back and the database would be set back to the state it was at the start of the test. This will ensure that there are no dependencies in the order of execution of these steps. Each test is only dependent on the fact that this data is present in the database. If you are new to unit testing, then you might find some of this discussion confusing. It's not a problem at all. As you get more familiar with unit testing, you would realize the fact that add dirties context is a very, very important thing. For now, make sure that if any of your unit tests is updating data, just add dirties context on top of it. Until the next step, bye bye. Welcome back. In the previous steps, we were talking a lot about one-to-one relationships. Now, let's shift our attention to something called a one-to-many or many-to-one relationship. Let's start with a simple example. You have a course. I have course 10,001, 10,002, 10,003, JPA in 50 steps, Spring in 50 steps, and Spring Boot in 50 steps. Varied kind of courses. And these courses have reviews from the students. So you have these reviews that we have stored until now, right? So rating is 5, great course. 4, wonderful course. 5, awesome course. The thing is, there is a relationship between this course and the reviews. These reviews are for a specific course. So if you look at this review, this is for a specific course. Let's say this is the review for a course JPA in 50 steps. And this is also the review for the course JPA in 50 steps. Let's say this is the review for course Spring Boot in 100 steps. You can see that when I look at it from this perspective, the JPA in 50 steps has 2 reviews present in here. So the 2 reviews are 50,001 and 50,002. Spring Boot in 100 steps has one review present, and the other course which is present in here, which is Spring in 50 steps, does not have any reviews yet. Each course can have multiple reviews or no reviews present. So it's kind of a 0 to n relationship. So from the perspective of course, you can have 0 to n reviews. However, when I create a review, the review should be associated with a course. Without a course that is associated with the review does not really make sense. What is this review for? I have no idea what the review is for until I have something storing which course it is mapping to. In database design, we will use IDs, the keys, to map the relationship. So we will not use the names to map the relationships. The first question to answer is, how do I store the fact that this review is associated with a specific course? Should I put a course ID in here, or would it be possible for me to have a review ID in here? Which should be the option to take? That's the first question we will discuss in this specific video. For this course, right now there are two reviews, right? So which ones? These two. So if I have a review ID column, can I store the values in here? Nope, that's not possible because this review IDs will now have two values in there. So I have 50,001 and 50,002. That's not good database design, right? So that's not cool at all. So having review ID here is not possible, or it's not a good design at all. So the best possible design for many to one relationships is to go to the one side. So this is the one side of the relationship. One review is associated with one course. So I'll go here and I will add a column called course ID. So this course ID is what we will use to store the relationship between the course and the review. So this review is associated with only one course. So I can have a course ID specifying which course this review is associated with. Now which reviews? So it's 10,001, 10,001, and the last one is Spring Boot in 100 steps, and it's 10,003. That's cool. Now I don't really need this stuff anymore because now we are using an ID to link these up. So now we have two reviews for this course, no reviews for this course, and we have one review for this course. In this step, we quickly discuss the database design that we would want to use for many to one relationship. However, this database design which we have in here on paper or on the spreadsheet is not really translated to our entities. In the next step, we will look at how to map this in our entities. Until then, bye-bye. Now that we have the database design ready for the course and the review, let's now try and start mapping this to our entities. I have the course entity open, and now I'll have even the review entity open. In the course, for a single course, we will have multiple reviews present. So for a single course, we can have a list of reviews. So how should we store it? I can have n number of reviews. So what we would do is we would store it as a list. Private list review, and I'll call this reviews. So review followed by an S, reviews. And usually when we use a collection, we initialize it then and there. So I'll say is equal to new array list. Let's organize the import so that everything is imported in Java util list. And over here, from the perspective of a course, one course has many reviews. So the relationship is one to many. So it's very important to remember there are two annotations, one to many and many to one. One to many is, you should think it from the perspective of this specific thing. This course has many reviews. So one course has many reviews. So one to many. That's the way you need to think about it. And I would say at one to many. That's cool. That's basic stuff, right? So there is nothing complex in here. Let's add in a couple of getters and setters for that as well. So we have get reviews and set reviews on the course. One of the most important thing that I would want to do when I'm designing the entities is I don't want others to set a list of reviews. So for a course, I don't want others to be able to say, okay, set reviews and give a list of reviews. The best way to be able to add a review is to just have a simple add review method. So I don't want others to add a list of reviews. I would want to have the control around that. So I'll say add review, and what I would do is say this dot reviews dot add a review. The other method you might want to add in is a remove review method as well. So I would be able to say remove review and say reviews dot remove review. This is especially important because I would want to be able to add reviews one at a time. I don't want somebody to take the list of the reviews, manipulate it, and then give me the complete list. I would want others to use the specific methods which are present in here. So if they want to add a new review, they can call a review add review method. If they want to remove a review, they can call the remove review method. We have now mapped the course side of the relationship. Let's go to the review side of the relationship. This review is associated with one course. So private course, course. And what is the relationship? Many reviews are associated with one course. So it's many to one. And over here, I'll just go a little below and also have the getters and setters for the course created. Because there is just one course, this is much more easier thing to create. So let's go ahead and create a simple getters and setters. So we have the getter and setters for the course created. We discussed this earlier as well. We said the review would have the course ID. So review is the owning side of the relationship. So if review is the owning side of the relationship, where would we put the mapped by? The mapped by would be on the course. So let's go to the course entity and add a mapped by. So at one to many, mapped by is equal to, what's the name of the variable here which we are using? Course. So let's put that in over here. So that's cool. So now we have a course which is associated with multiple reviews, review associated with a course. There's one last thing that we would need to do before we would be able to run the application. That's fixing our data. We have not done that yet. A course, there's no change in the course table. In the reviews table, we have a change. We have a new column. It would be called course underscore ID. And course underscore ID, course underscore ID. We have already have the course IDs, right? So it's 10,001, 10,001, 10,003. So 10,001, 10,001, and 10,003. That's our data. I'll click this and say demo application. I would want to start the application up. Let's wait for everything to start up. There's no change in the course table as such, so this is as usual. However, you can see that in the review, there's a course ID column. So course ID is the foreign key. And you'd see that a little below, there's also a foreign key relationship. So on the review, there is a constraint added in. That's a foreign key course ID on the table course. That's cool. So we have a table with a foreign key created. Let's now go to the H2 console and see what's the data which is present in here. So we have a course ID, created date, last date, updated date. There is no change in here. Review, we have a new course ID which is present in here. So let's start from review in here. You can see that the course ID is present in here as well. So I'll join them together. So I'll say review comma course, where course dot ID, review dot course ID. Now you can see that the JPA in 50 steps course has two reviews which are present in here, and Spring Boot in 100 steps has one review which is present in here, 50,003. So that's cool. So we have now established the relationship between review and course. Our tables are ready. Our entities are also ready. In the next steps, We will look at how to insert new reviews and also how to retrieve the details of the reviews of a specific course, and also the reverse side of the relationship. Given a review, how to get the course details. Until the next step, bye bye. Welcome back. In the previous step, we set up a many-to-one relationship between the course and the review, and we were able to see the data in the database as well. So we see that right now JPA in 50 steps has 2 reviews, and Spring Boot in 100 steps has just 1 review. Let's say right now I'm getting a couple of additional reviews for Spring Boot in 100 steps, and I would want to insert them in. So I would want to insert new reviews for the course with ID 10,003. Let's see how to do that in this specific step. What we'll do is we'll start with creating something in our demo application. So demo application, as we know, is extending command line runner. So I'll start with something in here. So let's not worry about the student repository. This is not really important anymore. Let's now take the course repository, and in the course repository I would want to create a new method. So I would want to call this add reviews for course. For now, let's hard code everything. So I'll create the method add reviews for course. What we want to do is to retrieve this course. So get the course 10,003. What we want to do is add 2 reviews to it, and we would want to save it to the database. That's basically what we would want to do now, right? So let's start with one by one. So I would want to first get the course 10,003, right? How do I get the course 10,003? So we already have a find by ID method. So let's use that. So course is equal to find by ID 10,003. So now we have the course. So if we actually go ahead at this point and do a logger.info course.get reviews. So I'm printing the list of reviews that are present for this. I need to just, I'll say course.get reviews and add in a variable over here as well, and course.get reviews are these. So if I execute this right now this is not really doing the functionality that we would want to achieve, but I just wanted to check if it's printing the reviews of the course correctly. So let's see what's being printed right now. What is happening is first a select query for the course is going in. So what value is sent? 10,003. That's the exact query that we are trying to fire. So the first line of code that we wrote is to find by ID 10,003. So the course details are retrieved, and then we are trying to get the reviews. So what happens is an additional query gets fired. So it's now sending an additional query to get the reviews. So it's sending, I'd want to get the reviews for this specific course ID. And what we are getting back is the review for that specific course, right? So we already saw the review in the database which was present in for that particular course, which has 10,003, is awesome course with a rating of 5. And that's what we see in here, 5 awesome course. That's cool. So we are now able to retrieve the reviews for a course. It's very simple, right? That's what JPA is for. It makes it easy. Once you define the mapping, doing everything on it is very, very simple. Now, I would want to add a few more reviews. How do I do that? Let's create the new reviews first. So review is equal to new review of, let's import it in, and the constructor for review accepts a rating and a description. So let's provide a rating. Always, this is my course, so I always rate it at 5, and let's say great hands-on stuff, and I'll create another review. So now I would want to actually now say this is review 1 and this is review 2. Review 2 is equal to new review, and this review I'll leave it at 5 and say hats off. Okay, cool. This is my course, so I'm leaving great reviews for it. So don't really worry about what the review content is. The most important thing to focus on is the fact that we now need to add these reviews to the course. So how do I add these reviews to the course? We already created a method. So we said course.addReview, review. Which review we would want? Review 1 first. And then we would want to add in review 2 as well. That's cool. Is this sufficient? Will this save the reviews down to the database? Nope. The first thing that we would need to do is also associate the review with the course. Review is the owning side of the relationship. So the review has the course ID present. So I would need to tell which course this review is associated with. So in addition to setting the add review, I would need to say review1 dot set course. And the same thing I would need to do on the review 2 as well. So review 2 dot set course. Now we have set the review into the course, and also we have set the course on the review. That's cool. And now I can go ahead and save the reviews to the database. There is nothing that I would need to that I'm changing on the course table itself. So I don't need to really persist the course. All that I need to do is persist the review. So I'll say em.persist review 1 and em.persist review 2. We are retrieving the course in here. We are creating a couple of reviews. We are setting the relationships, and then we are saving it to the database. So this is the part where we are setting the relationship. Now let's stop this and start the server again. So this stuff which we see in here will be executed at the launch because we have it as part of the run method of the runner. This would be executed, and let's see what would be the results. Let's refresh the H2 console. I want to see the data which is present in the reviews. You can see that the new reviews that we have added in are stored down to the database. So great hands-on stuff 5, and it's associated with 10,003, which is our course 10,003. Let's see which course that is. So all that I need to do is course.id is equal to review.course_id. And now I would be able to even see the course. Oops, I missed a where, a blunder. Okay, now I can see all the data in here as well. So you can see that for the course Spring Boot in 100 steps, there are 2 new reviews present. That's cool, right? So we now have reviews stored for this specific course. So in the previous steps, we defined the relationship one-to-many or many-to-one, as you would want to call it. And in this step, we looked at how to add data, how to save data to the database for that kind of relationships. In the next step, we would make these methods generic. For now, we have a lot of hard-coded stuff in here. So let's clear that out and create a new method in the next step to remove all the hard coding. Until the next step, bye-bye. Welcome back. In this step, what we want to do is to make this add reviews method more generic. So what I'll start with is I'll copy it. I'll leave the hard-coded method in here for your reference for later. And I would start generalizing. I copied it, and let's create add reviews for course. The input I would want to take when I'm adding reviews for a course is the first one is long course ID. So I would need a course ID, and I would want a list of reviews that I would want to add. So list of review, I'll call this reviews. So the inputs that we would want are the course ID and the reviews that I would want to add in. So over here, think of it as if the course has 100 reviews and I'm adding a couple of reviews to them. So that's what we are doing in here. So these reviews will be added in addition to the existing reviews for that specific course. The first thing I would need to change is we are no longer restricted to 10,003. So I will pass in course ID. So the course ID, whichever we get in here, that's the one which we are using to retrieve the course details. And we are printing the details of the course reviews. And we would want to add a couple of reviews to it. So right now the reviews are hard coded, what we want to do is to pick the reviews from here. So let's loop around that. So for review in reviews. So what I'll do is first remove all the review to stuff so that it's not confusing anymore for us. So for review, I'll loop around all the code which is present in here. So I removed all the review 2 stuff, and all that stuff which is remaining for is the review 1. So now if I would want to add, I don't need to create a review because the review is already created and sent to us as a parameter. So this is cool. I don't need to worry about creating it. Add review, that's cool. Add review, and review.set code scores persist review. Isn't it very simple? This is one of the things we really believe at in 28 minutes. The thing is, get something working first. So write hard-coded stuff or whatever way, get something working first, and then you can easily refactor it. But make sure that you refactor it to the signature that you would want to. So think about how you want to design this, but you don't really need to code this at the first step itself. Have a view of how you would want to design something, but don't worry about taking a couple of shortcuts to get it working first. Once you have that working, then you would get back to making it really cool. This is also the basis for one of the important approaches to writing code, test-driven development. You get it working and then make it good. Get it working, keep making it good. And you do it in cycles, you will end up with really good code. Okay, enough theory. Let's get to the practical stuff. So now I would want to call this add reviews for course instead of this one. So what I'll do is I'll rename the earlier method to add hard-coded reviews, and I'll change that here as well. It's add hard-coded reviews for course. Now we would want to call the add reviews for course. Course repository dot add reviews for course. I would want to add reviews for which one? 10,003, and I would want to add a set of reviews. So we don't have the reviews yet, so I'll create a local variable reviews. Let's initialize a new array list and also add in the reviews which we have created in here. These are the review 1, review 2. So I can say reviews.add. I don't really need the variables. Reviews.add review. That's it. Now we have the reviews ready. Now I can call the method. So I'll just move this code a little bit down so that it's near to the other method call as well. Okay, so we have the reviews ready and we are trying to add them to 10,003, and let's see if everything works as expected. So let's save this down. We are not calling the add hard-coded reviews. What we are calling in is add reviews for course in the demo application in the run method. So that's cool. Let's kill this and run this again. What we see in the log is first we are trying to get the reviews for 10,003. So we are printing the reviews out. That's what we are doing in here. And before that, we get the details of the course. So we get the details of the course, we get the details of the reviews, and then we are trying to insert the review in. And when you are inserting the review in, you can see that since we have established the relationship between review and course, the course ID is going in as 10,003, and all the other stuff are being set. So we have 2 inserts here because we inserted 2 reviews for that specific course. That's cool. Let's see the data in the database. Before I refresh, I'll copy this query out and continue, please. Connect. Execute this query for me. And now you can see that nothing has really changed. So we have 2 new reviews which are inserted for Spring Boot in 100 steps. However, the change is actually in the background, right? So instead of hard coding it, what we have created is the utility method. From now on, if somebody wants to add reviews to the courses, they have an easy way of doing it. All that they need to do is pass in the course ID and say what reviews they would need to add. So in this step, we looked at generalizing the method that we have created to create the reviews. In the next step, we will be looking at a couple of more things about one-to-many relationships before wrapping it up. Welcome back. In the previous steps, we established a many-to-one relationship between the course and the review, And in this step, let's play around with them little more to understand the important concepts about different fetching strategies with many-to-one relationships. So let's get started with it. I would copy the specific test which we have in course repository test. There's nothing in here really. We'll only retrieve the data, so I would not need dirty's context. And let's say insert, or I'll call this retrieve reviews for course. So what I would want to do is get the details of reviews for a specific course. So I'll take 10,001 as the example. And for this course, what I would want to do is get its reviews. So course dot get reviews. And let's do a logger dot info. Let's put a debug point here. Debug as JUnit test. So we have a course. We are trying to get the reviews for that specific course. So if you look at the course, the get reviews method, actually I'm interested in the reviews. We just have a one-to-many in here. We don't have any fetch strategy that is defined. So we didn't say whether the fetch is eager, whether the fetch is lazy. We didn't say anything about it. So now if I go ahead and say function F6, before that let's clear out the console. So now I'm trying to retrieve the details of the course, function F6. So what is happening? You can see that a select query on the course is fired and all the details of the course are retrieved. That's cool. And let's clear this off, and again function F6, we are getting the reviews. It's saying lazy initialization exception because the session or the transaction has ended with the repository. So we are not able to retrieve the reviews for the course from the database because they are not already retrieved. So let's go ahead and make this transactional to function F8 to end this stuff. And we need a transaction so that the persistence context lives for longer. So let's do that at transactional. So now we have the persistence context through this. So when we do course.getReviews, we want to fire a new query to the database. So we would want the persistence context to live through the length of this particular method, and that's why I put at transactional around this. We discussed this in depth in one of the previous steps. So let's go ahead and now try and debug again. Okay, let's clear the console. Function F6, the course details are retrieved. Clear the console. Now we are trying to retrieve the reviews and print them to the console. Function F7. You can see now that we are trying to retrieve the reviews for that specific course. The reviews are printed out to the console. That's cool. Let's do a function F8 to end the whole thing. One of the important things that you would have noticed is it's doing a lazy fetching. So first only the course details are retrieved and then the reviews are being fetched. That's good. So if a lot of times you are only showing the courses and not really the details of the reviews, then this is good. So you would first fetch the course, and only when you say course.getReviews, the reviews for the course are fetched. So by default on the one-to-many side of the relationship, so on the one-to-many side of the relationship, fetch strategy is lazy. Now I can make this eager fetch. So I can say fetch is equal to fetch type dot eager. What would happen if I make the fetch type eager? Let's debug and find out. Clear the console. Function F6. What's the query that's being fired? You can see that the query that's being fired now is a left outer join on the course and the reviews. So it's actually doing the complete join between course and review. So it's fetching both the course and the review details as well. So even though I have not really asked for the reviews yet, so as of now, the only thing which I've asked for is the course. It's already fetched the reviews. So when I fetch the reviews, let's say function F6, it does not need to go to the database to get them. It already has the reviews, so it prints them out. That's what would happen when I say something is eager fetch. So by default, the one-to-many side of the relationship, it's always lazy fetching. I'll remove the eager fetching because I like the one-to-many side of the relationship typically to have the default. That's basically the lazy fetching, because most of the times when I retrieve the course, I only want the course details. Only sometimes I might need the reviews, but you need to evaluate this for every relationship, every many-to-one relationship in your application. You need to evaluate it and make the right choice, whether you want to go for eager fetching or whether you want to go for lazy fetching. That's part one. So this is the one-to-many side of the relationship. Let's go to the many-to-one side of the relationship on the review side. So on the review side, we have at many-to-one annotation, and let's try and fetch a review and see what would happen now. So let's go to the course repository test and do the exact. So we would want to retrieve course for a review and see what would happen. So I'm saying review is equal to repository by find by ID. I'll use the review ID 50001, and what we want to do is do review.get course. So review.get course. So we are getting the review and then trying to get the course for that specific review. So let's organize the imports. Actually, the repository dot find by ID, this one is using the course repository. So this is no good for us. So we'll say entity manager dot find. Do we have an entity manager here? Nope. Let's auto-wire an entity manager in here. Entity manager em organize imports, and now I can do a find entity manager dot find. I would want to find a review, and I would want to use 50001 as the key. So we are trying to get the review. We are not using the repository. I could have taken the long way of actually creating a repository for the review and trying to get the review. But let's take the shortcut. Let's use the entity manager to quickly retrieve the review and see what would happen. So now let's put a debug point in here and debug this one. So this is the one which I would want to debug. So right click, debug as JUnit test. Cool. We are now ready to look at it. So function F6, before that I would want to clear out the console. Function F6, what's in the log? Let's look at it. So you can see here that we are actually retrieving the course and the review. So we are getting the review because that's what we are asking for, but also our join is done on the course. So we are getting both the review and the course details. At the start, we are only printing. We are actually not printing anything yet. So nothing is printed yet from our log statement directly. So now when I kill the console and function F6, you would see that the course details are being printed. So the important thing to realize is the fact that on the one-to-many side of the relationship, by default, it's lazy fetching. However, on the many-to-one side of the relationship, the fetching is always eager fetching. The way I would like to remember is anything ending with 2-1, whether it's one-to-one or many-to-one, it's always eager fetching. When we talk about many-to-many, you would also see that many-to-many is also lazy fetching. So this is one concept you need to understand very clearly. I would recommend you to play around with it a little bit to understand it much more. I'll press function F8 to complete the execution and end the unit test. And in the last few steps, we focused on the one-to-many or the many-to-one relationship. We established a many-to-one relationship between the course and review. We used course to get the reviews, we used review to get the course it is associated with, and we inserted a few reviews for the course. We also saw that on the one-to-many side of the relationship, the fetching strategy by default is lazy, and on the many-to-one side of the relationship, it's eager fetching. In this next step, we would move into the next type of relationship, many-to-many. Until then, bye. In this step, let's talk about the many-to-many relationship between entities. So we have an entity called course. We have an entity called student. When we talk about courses and students, this course can have multiple students, right? This course can have 3, 4, 10 or 0 students. And each of these courses can have multiple students. And when I talk about it from the student side of things, this student can be associated with multiple courses. So Ranga can be doing 2 of these courses, Adam can be doing all 3 of these courses, and Jane might be doing none of these courses. That's the many-to-many relationship. Each row here can be associated with many students, and each student here can be associated with many courses. Let's think about how to store this information. So now in this course, if I let's say add in student ID, I cannot store multiple student details in here. So that's not good design. And if I go to the student and put a course ID in here, what would happen? Is that good design? This student can be associated with multiple courses. So he can be associated with courses 10,001 and 10,002. So that also is not really good design. So that's where the concept of join tables comes into picture. So we would create a join table, something like course underscore student or student underscore course or one of those names, and we would have the student underscore ID and the course underscore ID stored in there. So what we'll do is we'll say this course 10,001 has this student whose ID is 20,001. So both these things are foreign keys. So this refers to the student, this refers to the course. And you would have, let's say, even 20,002 and 10,001. So this course JPA in 50 steps now has 2 students, Ranga and Adam. So that's how we would design the table. So the table would be a join table. So this join table would contain the IDs of both the tables, so both the student table and the course table, and this would help us establish a many-to-many relationship between these tables. So that's basically what you need to understand. Many-to-many should always be established by using a join table. In the next step, we'll try and take this concept and represent it in our entities. Welcome back. In the previous step, we talked about the need to have a join table to represent the many-to-many relationship. In this step, let's get to our entities and focus on adding the many-to-many relationship to them. So the entities which we are interested in are course, and we are also interested in the student. Let's also change the perspective. This is still in debug perspective, and I would want to go back to the Java perspective. So perspective, open perspective, Java. That's cool. And now we have the course. Oops, I opened up the student repository test. I don't want student repository test. I would want the student for now. So student. Cool. Now I would want to establish a relationship between the course and the student. So let's start with the course. What we would want to have is a course can have multiple students. So it's very similar to the thing which is present in here, right? So a course can have multiple students. So I would need to have a list. So list of students is equal to new array list. Simple, isn't it? And the relationship is many to many. Organize imports and we should be good. Okay, there you go. So that's the course side of stuff. I can use the same thing on the reverse side, on the student side as well. So I'll go to the student entity, and each student can have many courses. So I'll say courses, organize imports please, and that's it. That's cool. Now let's generate the getters and setters for these and the utility methods. I would want to add it just below here. So I'll say Alt Shift S, generate getters and setters for courses, and press enter. As usual with any thing which is associated with many other stuff, so student can be associated with many courses. I don't want set courses in here, so I would say add course. I don't want others to, the other users of this API to be adding a list of courses at a time. I would want to control, and I would allow them to add one course at a time. So I'll say add course. So you can also add in a remove course method in the same way. Let's go to the course and add the similar methods in here. So just below the remove review, I'll add in setters. I would want to add getters and setters for students, and get students is fine. I would want to allow them to retrieve the list of students, but set students, I would want to be careful with it. So I would want to say add student and use a list single student and do a add this dot students dot add student. Now we have established a many-to-many relationship between the course and the student. Let's see what would happen. I'm going to stop this and start the demo application again. I'll launch up the H2 console, refresh it, and connect. The interesting thing right now is course student, and there are two tables, course underscore students and student underscore courses. Since we have many to many on both sides of the relationship on the course and the student, what is happening is a separate relationship table is created for course. So this is called course students. So there is a table called course underscore students being created, and the reverse. Student has a relationship with a course, multiple, I mean, it's a many to many relationship. So it's creating a student underscore courses as well. So there are two tables that are being created for establishing single relationship. And if you look at the columns which are present in here, those are student ID and course ID. Here also it's the same. I mean, here it's called students ID and here it's called courses ID. But effectively, the design is the same. So we have two columns representing a course and a student, and the same in here. We have joint tables, but we have two joint tables, and that's not good. In the next step, we will look at how to fix this. Until then, bye-bye. Welcome back. In the previous step, we saw that when we added many to many relationship on both sides, on course and student, we had two relationship entities which are being created. We have two joint tables which are being created. And that's not what we want. We would want one joint table to be present. And how can we do that? That's what we would discuss in this specific step. Now we have a many to many in student as well as many to many in the course, and this is not really good as we discussed earlier. What should we do to fix this? What we should do to fix this is make one of the entities the owning side of the relationship. What we would need to do is we would need to say either the student or the course is the owning side of the relationship. In the case of one-to-one or many-to-one, the owning side was important because the owning side would have the column associated with it. For example, when we said student is the owning side for the relationship with the passport, the student table would get the passport ID column. We saw that the student table will have the passport ID column. So it was important in that kind of a situation. But in the case of a many-to-many relationship, we would use a joint table anyway. So it does not really matter which side of the relationship is the owning side of the relationship. So think of one of these two and make the other one the owning side of the relationship. It doesn't really matter. So what I'll do is I'll say mapped by is equal to courses. So mapped by courses. So what would happen? The mapped by is in the course. So which is the owning side? Student is the owning side of the relationship. You can also do the other thing, remove the mapped by here and add the mapped by on the student for the courses. That's fine too. But for now, let's focus on adding a mapped by in the course. So student is the owning side of this many to many relationship. Let's kill this stuff. Let's run. I'll refresh the H2 console, and you'd see that now there is only one table, student underscore courses. When I do a run, I don't have anything in there. That's cool because we have not inserted any data in there. Students ID, course ID, and we have the student and the course table as they were earlier. So there are no new columns in the course or the student tables. And now the student courses table has two columns, student's ID and the courses ID. The student courses table would become the join table between the student and the course. One of the things I don't really like is it's student underscore courses, and this is called student's ID and the courses ID. I would really want this to be just called student underscore course and have a student ID and a course ID. Let's see how to do that in the next step. Welcome back. In the previous step, we made student the owner of the many-to-many relationship between the course and the student. And we saw that there was a table created with student underscore courses and with column students ID and courses ID. Actually, I would really want to have a singular representation. So I would want to call this student underscore course, and the columns I would want to call them student underscore ID and course underscore ID. Let's see how to do that in this step. We are on the owning side of the relationship, student, right? Student is owning this relationship because there is no mapped by in here. Course has a mapped by, so it's not owning the relationship with the student. So on the owning side of the relationship, I can add in an annotation called at join table. So at join table is an annotation I can use to create a join table. And over here, I can specify an attribute. Let's start with the simple attribute name. So I can say name of the join table is equal to student underscore course. Actually, I can call this course underscore student or student underscore course. It doesn't really matter. The reason I'm calling it student underscore course for now is because I'm making student the owning side of the relationship. I am putting student first. So if you save this and now if you run the application and refresh the H2 console, you would see that the join table name is now student underscore course. Now let's fix the columns as well. How do we fix the columns? The join table annotation has a few other attributes that you can add in. The attributes we would want to define are: one, we would want to define the name of the join column. So the join column for this table, for this relationship, is student underscore ID. That's the join column name. And the other attribute we want to define is what is the inverse join column. So the inverse of the relationship is from course to the student. So what is the join column on the course side? So the course underscore ID. That's the inverse join column. So inverse join column and the join column. Inverse join column we want to use is course underscore ID. So let's try and define that on the join table. So we have defined the name of the join table. Now we would want to define the join column. So join column is equal to, there's an annotation called join column. So join column, and even in the join column there is another attribute called name. So let's set that name to student underscore ID. So the join column from this table, call it student underscore ID. Don't call it students underscore ID. Call it student underscore ID. And then I'll copy this, and the other one is inverse join column. Inverse join column, call it, inverse join column is the reverse side of the relationship. It's what is the column on the course side of the thing called. Don't call it courses ID, call it course ID. It's join columns. So let's call this join columns and inverse join columns as well. So now I don't like the way it's formatted, so let's make it much more simpler, and I'll remove the comments I've added in. So we have defined the join columns and the inverse join columns, and let's stop and start the application again. Let's refresh the H2 console, connect, and you'd see now that there's a table called student underscore course, student ID, course ID. That's perfect. That's exactly how we want it. And the other thing you would also observe is in the log, you would see a few foreign key constraints created on that particular table. So student underscore course table is created with 2 columns, student ID, course ID. That's good. And you can see that there are 2 foreign key constraints added in as well. So in student underscore course, the foreign key course underscore ID refers to the table course. And student underscore course, foreign key student underscore ID refers student. That's cool. So we have perfect table design for now for the many-to-many relationship between the student and the course. We can now have a single student associated with multiple courses and a course having multiple students present. In the next step, we'll focus on inserting some data and retrieving that data back. Until then, bye-bye. Welcome back. In the previous step, we created a join table exactly as we wanted it. So we have a table called student underscore course with student ID, course ID. And now we are ready to insert data in it. So we'll insert some data and try and retrieve those data back. So student underscore course, we have a student ID and a course ID, and I would want this data to be inserted. How do I do that? Let's go to data.sql. So let's initialize some data in. So I have inserted the student here. I have inserted the course at the start. So I can insert this anytime after I inserted both the student and the course. So I'll go to the end. Let's say insert into the table name we gave is student underscore course. So where did we specify that? This is where it's coming from. Actually, it's all caps here. It doesn't really matter. So student underscore course. The columns for which I would want to insert values are student underscore ID and course underscore ID. And the values we would want to insert are as we had earlier. So I'll just have the template ready and copy it out 4 times because we wanted to insert 4 rows. If you look at the data we are trying to insert, what we are trying to do is for course ID 10,001, that's JPA in 50 steps, we are adding 3 students. So we are saying JPA in 50 steps will have 3 students, Ranga, Adam and Jane. And the other course 10,003, which is Spring Boot in 100 steps, will have 1 student. So who is that student? That's Ranga. This course will have 3 students, this course will have 1 student, and this one will have no students at all at the start. So let's set that up in that way. So 20,001, 10,001. So it's 20,001 is the student ID and 10,001 is the course. And this is 20,002, 10,002. So 10,001, 20,003 and 10,001. And the last one is 20,001 and 10,003. 20,001 and 10,003. That's cool, isn't it? So now we have the relationship ready as well. So let's stop and start the application again to see if we have the data inserted properly. So the application has started up. I'll go to the H2 console as usual and look at the data which is present in the student course relationship. That's good. So we have the student ID and the course IDs inserted as per our need. Now let's try and join these tables to get the data. So student underscore course, I'd want to join with student table and the course table. So that's the first time we are doing a join between 3 tables. And what we want to do is student underscore course dot student ID is equal to student dot ID. And the other one which we would want to add in is an AND condition. We want 2 conditions in here. So student underscore course dot course underscore ID is equal to course dot ID. Now let's run this. You'd see that there are a lot of rows that are being returned back. Let me zoom out a little bit. Now you can see all the data that is present in here. You can see that Ranga is now part of 2 courses, JPA in 50 steps and Spring Boot in 100 steps. Adam and Jane are part of 1 course each. When I look at it from the perspective of the courses, JPA in 50 steps has 3 students and Spring Boot in 100 steps has only one student, that's Ranga. Until now, we saw how to put some data in and also how to get the data out using a query. So we wrote a query to get that data out. But if we are using JPA, will we write queries? Nope, we don't really write queries. What we want to do is to retrieve these details using the relationships that we have already defined on the entities. Let's do that in the next step. Until then, bye-bye. Welcome back. In the previous step, we populated some data for our student course many-to-many relationship, and also we were able to write a query and get all the details of the students and the associated courses. In this step, let's focus on how to do that using JPA. As usual, let's go to our unit test. I'll go to the student repository test. Actually, I can use either the student repository test or the course repository test for doing this. Let's go and use the student repository test because that's the owning side. And I'll copy the previous test that we wrote. Let's start with calling this retrieve student and courses. Let's start with the student first and try to retrieve his courses. So what we want to do is to retrieve the student first. Student is equal to em dot find. I'll use the entity manager as a shortcut, and the primary key of the student I would want to retrieve. Let's pick a student. I would try and get the courses that Ranga is doing. So let's use 20,001, 20,000L, and what I would want to first print is the student. So student and student, and after that I would want to print his courses. Student dot get courses, and let's remove this out, and as usual let's start with a debug point and do a debug. Right click, debug as JUnit test. Cool, I'm ready to debug it right now, and I'll go to the console. I'll remove all that which is present in here. Now I'm trying to find the student. I'll remove this line which is present in here because I have to change a lot of stuff in there. So I would want to get the student first. Student is equal to, I can use the student repository to get it. I'll take the shortcut and I'll use the entity manager directly. So I'll say student.class, and the primary key, which student do we want to retrieve? Let's get Ranga. Ranga has 2 courses, so I would want to get Ranga details and the details of his courses. ID of Ranga is 20,001. So let's take that up and say 20,000 L. Now first what we'll do is we'll print the details of the student. That's done. And next we'll print the details of his courses. So student.get courses, and this is courses. What we'll do is we'll put a debug point in here and see what would happen when I run this. So I'll launch this test up, retrieve student and courses, or you could have launched it by doing a right click, run as JUnit in here. Clear out the console and do a function F6 to execute the find on the student. So you can see that the find on the student executes only the student query. So it's doing a select star from student where a specific ID is this. So for 20,000, it's trying to get the student details. Actually, I got the ID wrong. It should have been 20,001. So this would return null back and it will throw an exception. So let's do a function F8, kill this very quickly. And let's change this to 20,001 and do a debug of it again. I'll go to the console. I'll remove everything. Function F6. This will execute this student query. Now you can see that a few student details are being retrieved. Ranga and his details are being retrieved. Let's print that to the log. Now you can see Ranga's details are printed in the log as well. Let's clear the console out and execute the next statement, function F6. So I'm trying to get the courses for Ranga. What query is being fired? You can see that the query that is being fired is a join of the student with the course. So we are joining the student with the course and we are trying to get the details of the courses that are associated with Ranga. So these are the two courses that are being printed out. That's cool. And I do a function F8 to complete execution and terminate the whole thing. That's cool. So we are now able to retrieve a student and get his courses. One of the important things that you have already observed is the fact that by default, this relationship is using a lazy fetch. So when I am fetching the details of the student, the details of the course are not being fetched, because many-to-many relationships are by default using a lazy fetch. If you would want, actually you can make this a eager fetch relationship as well. So I'm saying many-to-many fetch type is equal to eager. So what would happen when I fetch a student? His courses would also be retrieved along with it. Let's see what would happen. I'll directly run this. So right click, run, and in the log you'll be able to see that this is actually doing not just retrieve from the student. So the first query itself, when we are trying to retrieve the student details, so is actually doing a left outer join. So it's doing a it's trying to retrieve the student and all his courses. So when I'm trying to do a retrieve on the student, directly it's retrieving all the courses as well. So this is an eager fetch. I would not really recommend you to do this on a many-to-many relationship. So I will immediately remove the fetch which is present in here. I just wanted to illustrate the fact that if you want to get student and all his courses at one time, then you can directly add a eager fetch on the many-to-many. Those are a couple of important things that you need to note when we are retrieving the student and the courses. I would leave it as an exercise for you to be able to create a corresponding test to retrieve a course and also the students associated with a course. So all that you need to do is to do entity manager.find course.class and give the course ID, and you need to print the students that are associated with that specific course. One of the things you can also try and play around is the definition of eager fetch on the course side as well. In this step, we were focused on retrieving the details of a student and the course. In the next step, we will shift our attention to inserting a student, inserting a course, and inserting a relationship between the student and the course. Until then, bye-bye. Welcome back. In the previous steps, we were focused on retrieving the details of the student and his courses. So we were using the many-to-many relationship which was defined between the student and the course to retrieve the details back. In this step, let's shift our attention to creating a new course and a student and defining the relationship between them using JPA. So what I'm doing is I'm going to the student repository. Let's create a hard-coded method for now. So what I'll do is I'll say public void insert student and course. We'll also insert the relationship between the student and the course. So first let's create the student. So student is equal to new student of, let's say, Jack. So we have created a new student. After the student, what we need to do? We need to create a course. Course is equal to new course. I'll give the name to this course, microservices in 100 steps. Now we have a student, we have a course, so we can go ahead and persist them using the entity manager. So how do we do that? Entity manager dot persist student and entity manager dot persist course. So this would persist the student and this would also persist the course. Now how do I persist the relationship between the student and the course? How do we do that? That's done by adding the course to the student, student.add course, and the reverse as well, course.add student. So we are establishing the relationship between student and course on both these sides. And then I can persist the owning side. The owning side we have defined is student. Let's see what would happen when I fire this off. I'm calling the insert student on course. Where do we call it from? Let's call it from the command line runner, the demo application. The run method is the best place for us. So do we have a student repository here? Yep, we do have a student repository. So let's comment the stuff which is already in here. I don't want to do all this stuff right now. So all that I'm interested in is student repository dot insert student and course. For now, we are hard coding the values. So we can also say insert hard coded student and course. Right click, refactor, rename. Let's stop and start the application again and see what would happen. The application has started fine. I'll copy the query and keep it and refresh the H2 console, connect and do a run. Now, what do we see? We see a new student, Jack, who's created associated with the course microservices in 100 steps. That's cool, right? So we have a student, his ID is 1, the course ID is 2, and we have an relationship established between the student and the course. So if you query the student course table, so if I do select star from student course, you'd see a entry for this relationship as well. So run selected, and you'd see that student ID 1 is associated with course ID 2. That's good. Let's now see what's happening step by step in here. Let's execute this in debug mode. I'll kill this and I would put a breakpoint inside our method. So let's put a breakpoint here and let's debug demo application. Let's see what's happening step by step, what queries are getting fired and what's happening behind the doors. Okay, we are ready. So I'll go to the console, clear it out. I'll say function F6 to execute this new student. Nothing will happen in the background. New course, nothing will happen. In em.persist student. So when we try to persist the student, what would happen is a ID will be assigned to this student. So what happened is ID is got and the student gets an ID. So ID, what ID does student get? Student gets an ID of 1. So all the details of student are now set. Again, course gets an ID, course gets an ID of what? Course gets an ID of 2. Now I'm saying student.add course, so student gets added to the course. Let's function F6, and now we are trying to persist this student. Nothing would happen, and when I actually fire the whole thing out, so when I complete the execution now, so let's say function F6 here and press function F7 to get out of the whole thing and complete the execution, you'd see that's when the actual inserts get fired. So at the end of the transaction, the student is inserted, the course is inserted, and the relationship between the student and course is being inserted. Hibernate waits until you are ready to close the transaction, until the last point in a transaction before executing all the updates on the database. So it waits until the last point and then it's inserting the student, inserting the course, and also inserting the relationship between the student and the course. And that's how we establish the relationship between student and course in JPA. What we'll do is now we'll try and remove the hard-coded stuff. I'll copy this method. I'll leave the hard-coded method in here. I'll just say insert student and course. And I would get the student details as the input because we would need the details of the student for as an input, and course details also. So student comma course, and over here I don't need the student details because the student details will come from the calling method, course details as well. So all that we need to do is persist them and add the course, add the student. One of the things which we can also do is something of this kind. So this would help us just call the persist twice. So I'm saying student.add course, course.add student. I'm persisting the student and then the course. Instead of the other method, let's try calling this. I'll go to the demo application and I'll comment this out. and I'll say student repository dot insert student and course, and I'll say new student. Let's give the name a little later, and new course. What's the name of the student that we would want? It's Jack, and the course we would want to insert him into is microservices in 100 steps. You can start the application now, and you'd see that at the end of the startup of the application, the student and the course would be created. Application is started up. I'll go to the H2 console. I'll grab the query, refresh it, connect, and run the same query again. And you can see that Jack is now being inserted in. So Jack is associated with the course microservices in 100 steps. In the student repository, we have created a method to insert both student and course. But there are scenarios where you would want to add a course to a student or add a student to a course. I would recommend you to try those methods as an exercise. So try creating methods to be able to do that and see what you can do with them. Until the next step, bye-bye. In the last 20 odd steps, we played around a lot with relationships. We started with a one-to-one relationship between a student and a passport, and then we looked at a one-to-many relationship between the course and the reviews, and we looked at a many-to-many relationship between the course and the student. There are few relationships which we have not established as well. When there is a review, the review is also associated with a student. So I have not really added in a relationship between the review and the student. It would be great if you can spend some time and think about the other relationships which can exist between these entities and try and play around with establishing those relationships. Key part of using relationships with JPA is the fact that once you define the mapping, everything else becomes easy. It becomes easy to retrieve the data, it becomes easy to insert the data, but you should always be careful about the fetch type. You should always be remembering the fact that if you're using a many to one or a one to one, the fetch type is always eager. So if you're getting an entity and fetch type is default and the relationship with other entities is either many to one or one to one, then it would do a join and get those entities as well. This is something which you need to remember. Whenever you are establishing relationships, you should also think about how they will be used. So if I'm trying to get a course, will I always need the reviews? If I'm getting a student, will I always need the passport details? You need to take that into consideration when you are defining the fetch type. So always keep thinking about the fetch type when you are thinking about relationships. The other thing you need to remember is how we have designed the tables in the case of different relationships. In the case of one-to-one relationship between student and passport, I can have the passport ID in the student, or I could have had the student ID in the passport. Either of them would be fine. But I decided that student would be the owning side of the relationship, and we had the passport ID present in here. However, when we talked about the many to one side of the relationship, what we did is we created the course ID in the review, because each review will be associated with a course, but a single course can be associated with multiple reviews. So it's best that we put it on the side of a review. So we put a course ID on the review. And when it came to the many relationship between the course and the student, we created a join table. We said, okay, a course is associated with multiple students, a student is associated with multiple courses, so we cannot have a column here with multiple values. That's not good design. So what we did is we created a join table. We created a join table called student underscore course with two columns, and we inserted the data in. Over the course of last few steps, we looked at the different relationships, how to get the data, and how to insert data for them. The best way to get at improving your skills with the relationships is playing with them. Do not take this to real life. I mean, you don't want to play with your relationships in real life. But with JPA, you can definitely play with them. Try and play with the relationships related to JPA and get better at them. Until the next step, bye bye. Welcome back. From this step, we will start shifting our attention towards defining inheritance relationships. So, when we talk about object-oriented programming, inheritance is one of the most important concepts. So, you can have an employee and full-time employees inheriting from employee as well as the part-time employees inheriting from the employee. So, you have two kinds of employees, full-time employee and part-time employees. The employee class has all the common attributes, maybe name, maybe address, and all that kind of stuff. And the attributes which are specific to full-time employee are, for example, salary. And for a part-time employee, he would have an hourly wage. So how do we model this kind of things? How do we represent this in tables? And how do we map the class to the table? How do you map your entity to a relationship which is having a inheritance relationship? That's basically what we would be discussing in this step and the subsequent steps. What we'll do is there are four different options: single table, table per class, joined, and something called mapped superclass. What we'll do is in the next few steps, we will create an example scenario and look at how it looks in the case of all these four options. We would use two example employees. Jack is a full-time employee. His salary is $10,000, and Jill is a part-time employee and he receives $50 per hour. So we look at how the table structure would look at in each of these different inheritance options, and also what would happen when we retrieve the details from the database. Whenever we talk about how we define our tables, we would be concerned about two different things, right? How easy it is to insert data and how efficient it is to retrieve the data back. So we will look at that between all these four options. In the next step, we will start defining the entities. In this step, let's focus on defining the entities that are needed for the inheritance relationships. We'll define an entity with a name and a full-time employee with a salary and a part-time employee with a wage. Let's get started with that. I'll copy the course entity and I will rename it as employee. One of the things which we want to do is we would want the employee to be an abstract class. I don't really want anybody to be able to create an instance of the employee, so I'll make it abstract, and I don't care about the named queries which are present in here. I'd want it to have an ID, I would want it to have a name, and I would want it not to be nullable. So those are all cool, and I'll remove all the other stuff which is present in here. So I'll leave the constructors in. So I would want to be able to create an employee by using the name. That's cool. And also I'll be able to use the get name and the set name method. That's cool too. And I'll remove the other stuff which is present in here. So I don't need all the other methods which are present in here. I'll leave the get ID, and toString I'll use employee and give a name back. That's cool, right? So now we have a simple employee with a name defined. This is we have an at entity on it right now, so let's leave it in there. Now let's go ahead and define a part-time employee as well. So what I'll do is I'll create a new class, Control N, class, and I'll call this part-time employee. I'd want the part-time employee to extend the employee class. So extends employee, and this is also an entity. So let's define that. organize imports, and the most important attribute that I would want the part-time employee to have is his salary. So I'll say private big decimal and his actually hourly wage. It's not salary for him, it's hourly wage for him. So I'll say hourly wage. I will have a constructor for the part-time employee. Let's have the no argument constructor to make JPA happy. Also, let's create a constructor that we would be using a little later. So I would want to be able to create a part-time employee. And whenever we want to create a part-time employee, what are the details we would need to pass in? We need to pass in all the details that an employee needs, right? So I would need to pass in a name and also the details of a part-time employee. So I would need to pass in a hourly wage. Now I can go ahead and define this constructor. All that I can do is I'll call super of name because I would call the employee constructor with the name, and I would set this dot hourly wage is equal to hourly wage. That's cool. We have the part-time employee entity ready. Let's move on to the full-time entity. Control V, I'll call him full-time employee. Let's open up the full-time employee, and I would now, this is no longer the hourly wage, this is salary. So let's rename it salary, and even here I'll rename this to salary. That's it. We have three simple entities which are defined. We have a employee, we have a full-time employee, and we have a part-time employee. We have employee with a name and the ID. The full-time employee extends employee, and we have a constructor that would allow us to create full-time employee very easily. And the same is the case of a part-time employee who has a hourly wage. Now that we have defined the entities, in the next step, we will create a simple repository to be able to access the details of the employee and also insert a couple of employees in. In this step, let's focus on creating an employee repository. So I'll go to the course repository. I'll say employee repository. And let's open up the employee repository. I'll leave the other stuff. I need the logger, entity manager. That's cool. All the other stuff I can get rid of. There are two methods I would want to define in the employee repository. One is I'd want to be able to insert an employee in, and also I would want to retrieve all employees. So these are the two methods I would want to create in here. Let's start with inserting an employee. So I'll create a simple method. So it says public void insert, and over here I can accept an employee. And what should I do to insert an employee? Very simple, right? So all that you need to say is entity manager dot persist employee. That's it. Very simple. So as soon as we call this, the employee would be persisted. The next thing I would want to do is to retrieve all the employees back. So how do we retrieve all the employees back? I'll change the method which we have in here. So this would return a list of employee. I'll call this retrieve all employees because I would want to retrieve all employees. I don't really need to care about the long ID. And over here, what I'll do is entity manager dot, we would need to use a named query. I'll use a normal query. So let's say create query, and I can write over here a simple query, right? How do I get all the employees? So I would want to get all the employees. So select E from employee E. That's the query. Very simple. What is the type of results that it would get me? It's employee.class. Now I would want to execute it. So get result list. Very simple, right? So this is exactly what we have been doing in the previous steps as well. So we created a query and we are getting the results and returning it back. Let's remove the comments which are present in here, and now we have our simple employee repository ready. So we can use this employee repository if we want to insert details of an employee or retrieve details of employees. What I'll do is I'll go to the demo application and start invoking these. So I would want to create the sample employees that we wanted to create. Let's do that. So I'll comment these stuff out, and over here now I would want to be able to insert an employee. What employees do we want to insert? Let's take the details from here. These are the employees we would want to insert. Let's create them right now. Before that, I would want to have an employee repository auto-wired in here. So let's do that quickly. It should be employee repository, organize imports. We have the employee repository in here. So I can go ahead and query it. So employee repository dot insert. I'd want to insert a full-time employee. So new full-time employee. What's his name? His name is Jack. And I would want his salary to be how much? 10,000. So I'll say new big decimal of 10,000. I'll import the big decimal in as well. That's cool. We have inserted the full-time employee. Before inserting a full-time employee, I'll also insert a part-time employee. The part-time employee, Jill, and his thing is 50. So it should not be full-time, it should be part-time. So the part-time employee constructor, the second parameter is hourly wage. We are setting hourly wage for Jill to 50. That's exactly what we wanted to do earlier as well. So we have now inserted 2 employees in, and also we have the logger. You can use that to log the list of employees. So I'll say log.info employees, or I can say all employees, and say comma employee repository dot retrieve all employees. What we have done in this step is we created an employee repository, we created an insert method which allows me to insert an employee, and we have a retrieve method to retrieve all the employees. And over here we are inserting 1 part-time employee and 1 full-time employee, and we are retrieving the details from the database and printing them out. In the next step, we will start evaluating all the options that we have to map the employee and the employee inheritance hierarchy to the tables in the database. Until next step, bye-bye. Welcome back. In this step, we would look at the first option that is available to map inheritance relationships to tables. The option we would be looking at is called the single table option. So what we would want to do in this option is both part-time employee and the full-time employees we would want to store in a single table. So in that kind of a scenario, what would we do? We would just need to say at inheritance. That's the annotation to define inheritance relationships. So I'll say at inheritance, and over here I can specify the strategy. The strategy we would want to use is inheritance type dot single table. The thing about single table is that's the default strategy which is used. So if I don't even specify anything in here, the default strategy which is used is single table. So let's now start the application and see what happens. So I'll kick this off. In the previous step, what we had done is in the demo application, we are actually trying to insert a couple of employees, and we are also retrieving the details back. The application has started up. I'm going to the H2 console and refreshing the page and saying connect. So you'd see that there is just one employee table. So there's one employee table, and when I do a select on the employee, the 2 employee rows are being printed. So we created 2 employees, Jill part-time with an hourly wage of 50, Jack full-time with a salary of 10,000. So you can see that there are 2 rows in this table. So both the part-time employees and the full-time employees are stored in single table. For a part-time employee, the salary is null. For a full-time employee, the hourly wage is null. And what is happening when we try to retrieve the data? So you remember, if you remember it right, then in the demo application, what we are doing in here, we are trying to retrieve all the employees in here. So what query was triggered for that? Let's look at it as well. You can see that the query which was triggered is very simple. So select star from employee. That's basically as simple as that. So this is a very efficient query because it just needs to do a select star. So if you look at this specific option, from the performance perspective, it's really good because I'm just getting the details from one table and also inserting it into the same table. So it's very good from the performance perspective. But when you look at it from the perspective of data integrity, I have to define both these columns as nullable because hourly wage will be null for full-time employees. Salary will be null for part-time employees. So if there are defects in code, there's a chance that there is invalid data that can come in. So if somebody inserts in a part-time employee with no hourly wage, that's bad data, and my database will allow bad data. So the problem with the single table hierarchy is that you will have a lot of nullable columns. The advantage is obviously the performance. Because you are getting the details from single table, you don't need to do any joins or any things like that. So to quickly summarize, what we are trying is this single table option for inheritance. And when we use the single table option, we had just one table which was present, and we had two employees who are being inserted in. And when we try to retrieve all of them, then this is what would happen. It would fire a simple select query. One of the important things that you need to remember is in the employee table, there is an additional column which is added in. It is called D type, distinguisher type, and that would say what kind of employee is being stored. So part-time employee or full-time employee. For if you are inserting a part-time employee, the value for that column will be part-time employee. If you are inserting a full-time employee, the value for that will be full-time employee. If you are really specific about the D type column, then you can even give a name to that. So I can say at discriminatory column, so discriminator column, and you can say what name you would want to give it. So I can say name is equal to employee type. If I kill and restart the application, you can see that when I do a query select star from employee, the discriminatory column is now called employee type. It's no longer D type, it's called employee underscore type. In this step, we took a quick look at the single table inheritance option. With a single table inheritance, all the subclasses are mapped to one table. All the data related to all the other entities, all the subclass entities will be stored in one table. I'll see you in the next step where we'll discuss a few other options. In this step, we would look at another option. We'll look at an option called table per class. Inheritance type dot table per class. So if I look at the documentation of table per class, what does it say? It says a table per concrete entity class. So is employee a concrete entity class? Nope, it's an abstract class. And the subclasses of employee, the full-time employee and the part-time employee are the concrete classes. So you would see that individual tables will be created for them when we insert the data in. The important thing that is very good about JPA is the fact that how I insert an employee or how I retrieve the employee back will not change based on what type of inheritance I am using. So that will not change at all. I'll remove the discriminatory column in here because it's not needed, because there is a table per class inheritance strategy that we are using now. And let's restart the application. When you restart the application and go into the H2 console, you'd see that now there are two tables, full-time employee and part-time employee. Common columns are stored in both the tables. So we have an ID and a name in both the tables. So ID and name are present in both the tables, and the unique columns for that are also in that specific thing. So salary is unique for full-time and hourly wage is unique for part-time employee. And when I run the query, you can see that in the full-time employee, Jack is inserted with an ID 2 with salary 10,000. And when I look at the part-time employee, you'd see that Jill is inserted with an ID 1 and an hourly wage of 50. In this kind of mapping, what would happen is each concrete subclass is provided with an individual table. So all full-time employees will be stored here. All part-time employees will be stored here. And when I'm trying to retrieve the details of all the employees, you can see how they are being retrieved. They are being retrieved by using a union. So what's happening here? Select star from part-time employee, union, select star from full-time employee. And a union of those is used to retrieve the details. To summarize, table per class, each concrete class has its own table. This is good both from the performance perspective and also it's easy to insert stuff in as well. But the problem is that the common columns are repeated in both the tables. Here we just have name as the common column, but there might be 10 other common columns and all of them will be repeated in both the full-time employee and the part-time employees. And if I have, let's say, 10 subclasses, then I would have 10 different tables. That also can cause a problem. The retrieval was done using a union, which is not really such a big problem. It's okay to use union because it's easy to get the data for this table and union it with data from another table. That's not really a problem at all. In the next step, we would look at the third option. Welcome back. In the last step, we used inheritance type table per class. In this step, we would use inheritance type joined. So let's look at what the joined says. It says a strategy in which fields specific to subclass are mapped to a separate table compared to fields that are common to the parent class. A join is performed to instantiate the subclass. What does that mean? That means there will be a separate table created for the superclass and subclasses. So employee will have its own table, full-time employee will have its own table, part-time employee will have its own table. And whenever we are trying to get the details of the subclass, there would be a join that would be performed and the details would be retrieved. Does all this theory sound boring? Don't worry. Let's run the application and see what's happening behind the screens. That's cool. It's completed execution. And I'm refreshing the H2 console. I'm saying connect. Now you'd see three tables in here: employee, full-time employee, part-time employee. And if I do a select start from employee, I see ID and the name. So if employee had other columns like address and other stuff, you would have seen all the columns come in here. Right now we have just two columns, ID and name, and those are the ones which are present in here. You can note that this is the ID 1, this is ID 2, and let's see what's inside the other tables. Full-time employee, it has ID 2 and a salary of 10,000. It's reusing the ID which it had. So the ID from employee column is being used in here. So it's kind of a foreign key. This ID in here is a primary key for full-time employee as well as a foreign key because it's referring to the employee table. So the employee table has the actual employee details for this ID too. So it's kind of a foreign key as well. And when I do the part-time employee, I see hourly wage 50 and ID. So if I want to get the details, I would need to do a join. So part-time employee dot ID is equal to employee dot ID. I messed up where? It's weird error. Okay, cool. Now you can see hourly wage 50, ID is 1 and name is Jill. So Jill is inserted into part-time employee with a wage of 50, and you can do a similar query to retrieve the details of the full-time employee. You would get the details of the Jack back. Let's see what query was executed to retrieve all the details. You can see that a very complex query has been performed. Employee outer join with part-time employee and an outer join with the full-time employee. all these joins had to be performed to retrieve all the details back. So 3 tables had to be joined to retrieve the employee details back. The employee details are printed in here. In this step, we looked at the joined option. We saw that the joined option is really good in terms of the database design. There is no duplication of columns. Everything is present only once, and that's really cool. However, from the performance perspective, it might not be the best thing because it has to join 3 tables to get all these details. And imagine if I had 4 or 5 classes of employees or 4 or 5 types of employees, I need to join all these tables to get these details. In the next step, we would look at the last option. In this step, we would look at the last option related to inheritance. The last option is not to use inheritance at all. So not to use inheritance at all and use something called mapped superclass. Stop and start the application again. You'd see that now there would be an error. What I'm saying in here is that the employee is a mapped superclass. So it's just a superclass which is present for the sake of mapping. And when something is a mapped superclass, it cannot be an entity. So if you look at the error log, it would tell you that an entity cannot be entity and mapped superclass. So I'll remove the entity. If I look at the documentation of mapped superclass, it says a mapped superclass is a class which is designated with an annotation. It can be mapped in the same way as an entity, except that mappings will only apply to its subclasses. Why? Because no table exists for the mapped superclass. So the mapped superclass is not an entity at all. Let's stop the application, start it again and see what would happen. Now when I start the application again, I'm getting an error. It says employee is not mapped. What does that mean? What is happening here is in the demo application, what we are trying to do is retrieve all the employees. What does retrieve all employee do? It tries to use the entity definition. It tries to find all employees. But now employee is no longer an entity. We are using a Java persistence query language in here, and employee is no longer an entity. So it's saying, how can you query from something which is not an entity? So the only way now for us to do this kind of stuff is say retrieve all part-time employees. So I would need to do both of these separately, and I would need to do the join myself. So part-time employee dot class, this would return a part-time employee. That's one. And then I would need to create another method, let's say for retrieving all full-time employees. Full-time employee over here as well. Compilation errors are gone. I need to go to the demo application now, and I would need to have separate calls. So this is retrieve all full-time employees, and this is retrieve all part-time employees, and this is not all employees anymore. This is full-time employees, and this is part-time employees. The thing is, with a mapped subclass, it's almost as if this is like a common place where some definition is present. But other than that, there is no relationship between the subclasses. So a separate table is created for part-time employee, and a separate table is created for your full-time employee. And it's almost as if there is no employee relationship. There is no inheritance hierarchy at all. So mapped subclass completely eliminates the inheritance relationship between them. It's just that you are defining some common stuff in here. That's the only thing which is present that is common for those two classes. Other than that, there is no relationship between them. Now let's start this again. Let's fire up the console. Now you can see there are two tables, full-time employee, part-time employee. This will have ID, name and salary, and part-time employee will also have ID, name and hourly wage. And if we look at the queries, obviously there will be two different queries which are being fired, right? So there is a select star from full-time employee and there is a select star from part-time employee. In terms of how the tables are created, map subclass is very similar to table per class. So even in the table per class scenario, we would have two different tables created. However, at least while we were retrieving the details, we had the employee entity present. But when you are doing mapped superclass, the details are stored in separate tables, and when we try to use employee, we would get an error saying employee is not mapped. We have to retrieve the full-time employee and the part-time employees individually. In the last few steps, we looked at the four different options that are present to map an inheritance hierarchy between your classes to tables in your database. In the next step, we would try and compare these options and look at what you can use in which kind of scenario. Until the next step, bye-bye. In the last few steps, we looked at a few ways of mapping our inheritance class relationships to the tables. We started with looking at the single table relationship where we had just one table which was created irrespective of how many subclasses are present. So one table is present and all the data is stored as part of this table. And we also saw that there is a distinguisher column to differentiate between the different types. Here part-time employee and full-time employee. The problem with the single table stuff is the fact that data integrity is not really good. You have to make your columns nullable, and that's not good. The next option we looked at was table per class. In table per class, for each of the concrete classes, a separate table is created. And when we wanted to retrieve, then a union is performed between these two tables. The problem with table per class is the design of the table. If you have a lot of common columns, then they are repeated in both these tables. The third option which we looked at is joined. In this option, a separate table was created for employee, full-time employee and part-time employee. All the common details are stored in the employee table and the specific details are stored in full-time employee and the part-time employee tables. Both the full-time employee and part-time employee have a foreign key which refers back to the employee table. So this 2 here refers to this 2 and Jack. And this 1 here refers to Jill in here. However, the disadvantage was joins. So whenever I would want to retrieve data, I would need to join these tables and get the data back. The last option which we looked at was the mapped superclass option. Mapped superclass is almost like saying there is no relationship, there is no inheritance relationship between these classes. Employee has all the common configuration and full-time employee is a different class and a part-time employee is a different class. So for each of these things, for each of these entities, there is a separate table which is created, and we saw that we cannot even use employee as an entity to retrieve the details back. We had to write separate queries for full-time employee and part-time employees to get all the details. As we have discussed until now, all these 4 options have their own disadvantages and advantages. You have to really evaluate what you need for your scenario and choose the right option based on it. There are 2 kinds of scenarios we will be talking about. One is you are really concerned about data integrity. So if you are concerned about data integrity and data quality matters a lot for you, then I would recommend to choose the joined option. Because in here, each column is present only once and we are linking everything by using a foreign key. So all values are present only once and we have individual tables for each one of them. And from the data integrity perspective, this is really good. Data integrity and data quality, this is really good because I can make all columns non-nullable and there is no chance that a bad data would creep in. However, if you are really worried about performance, then obviously the single table will be the best option. So if you are really worried about performance, storing everything in one table is really good, but that would affect the data integrity. For me, I won't even worry about the table per class and the mapped superclass options, because in these options we have repeating columns and that does not meet the third normal form, and that's not really good table design to have. So the options I would really consider are single table when performance is a concern and joined when data integrity is of highest concern for you. With this, we end our discussion on inheritance relationships and how do you map them to the database tables. Until the next step, bye-bye. Welcome back. Earlier, we talked a little bit about JPQL, Java Persistence Query Language. We created simple queries using JPQL and saw the results for them. In the last few steps, we discussed a lot about relationships, inheritance, and things like that. What we'll do now is write JPQL queries using the relationships we have defined. So we have defined a lot of relationships, and all those relationships make writing queries using JPQL very easy. So starting this step, we will start looking at how you can use those relationships that we defined earlier in the JPQL. One of the first things I will do is I'll remove all the stuff which we are doing as part of the demo application. So I'll go to the demo application and comment out all the stuff we are doing in here. Let's do that quickly. Thing is, all the data which is present in here is something which we are inserting for the sake of doing quick testing. The actual data that we would want to use for the unit test is what is present in the data SQL. So in all the queries that we would write from now on, the data is as it is in this particular data.sql files. This gives us easy way to check, to refer back to whatever data is present in here. In this step, let's write a very simple query to find courses which do not have students. So what I want to find out is which of the courses which are present in here do not have any students. What I'll do is I'll stop the application and start it again so that I can write the queries on the database and check them directly. And after that, we would write the JPQL for it. The only data that would be present in the database right now is whatever is inserted in this data.sql file. I'll go to the H2 console, refresh, launch it up again. What we want to find is all courses without students. Let's first list down all the courses which are present. Select star from course. So this would list down all the courses which are present. Now, all the courses for which students are mapped, how do I get them? Select course ID from, which is the table? Student underscore course. So the student underscore course is the join table. So I'll use that. I would need to now do run selected. Run will run everything which is present in here. Run selected will only run the selected thing. So it will run the queries. So all these courses, I mean here 1001, 10,001 is actually repeating thrice, but these are all the courses which have students. So I would want to eliminate those courses. So how do I do that? So select star from course where course ID. So course dot ID not in this list. So if a course.id is not in this list, then I would want to see that. So then it retrieves me Spring in 50 steps. This is the only course which does not have students. So to do this kind of stuff usually with JDBC or Spring JDBC, we used to write a query like this. However, the thing is with JPA, you don't really need to write such a complex query. We already have a course entity defined, and also we have mapped the relationship with the students as well. We said it's many to many to the student table. Now we'll use that relationship to write a JPQL. I'll copy the JPQL where query which we wrote earlier. I'll call this JPQL courses without students. And I don't want to do a named query. So I would want to use a normal query. Let's do select C from course. See, this is normal JPQL, right? This is what we have done earlier as well. Now we would want to add another condition. So where I would want to find those courses which have empty students. So how do I do that? C dot the name of the variable here, students. C dot students is empty. I would want those courses where C dot students is empty. I would get the result list, and let's just say results is this, and I'll remove this line out. I would want to find out those courses without students. Here we are referring to the entities and their relationships. We are not really worried about the tables behind them. With JPA and JPQL, we are concerned about entities. We don't worry about tables. So let's run this and see what would be the output. Run as JUnit test. JUnit succeeded, but when I go to the log, I see just one course being printed, Spring in 50 steps. This is the only course which does not have any students as such. That's pretty cool, right? The query which is generated is using much more complex join than what I have written it with, but this query also would return you the same results back. This query is also checking the student table in addition to just the student course table. In this step, we wrote a simple JPQL making use of the relationship between course and students that we have defined earlier. Let's write a couple of more such queries in the next step. Until then, bye-bye. Welcome back. In this step, let's write a couple more JPQL queries. So in the previous step, we started with writing courses without students. So let's say I want to find those courses with more than 2 students. So I'll say I want to find courses with at least 2 students. So how do I do that? So where C.students, I can use a greater than equal to symbol. So C.students greater than or equal to 2 and course.class. Let's see what would be the result that would be printed here. Right click, run as JUnit test. I got an exception. Aha, the reason is because it's not C.student, but we want to find out size of C.students. That's what we would want to compare. So size of C.students is greater than or equal to 2. Let's now run this. Okay, by mistake I've actually run all the unit tests. Let's run just this one. Right click, run as JUnit test. Let's look at the log, what's being printed. So the JPQL test prints one course, JPA in 50 steps. So that's the only course which has more than 2 students, right? That's what we have defined earlier. So Spring in 50 steps has no students. JPA in 50 steps has how many students? If I look at the JPA in 50 steps in here, the course ID is 10,001 and 10,001 has 3 courses. So this is greater than 2 courses. So that's the reason why that particular query is successfully executed. And also when we looked at the query would look something like this. It's taking the course, joining it with students under course and finding those which have count greater than or equal to 2. That's cool, right? So with JPL, I'm not writing the complex query which is needed. Hibernate is generating it for me. I just define the relationship and Hibernate generates it for me. That's cool, right? So now let's move on. Let's write one more query in this step. What we want to do is do an order by. So I would want to order the courses by number of students. By number of students. I would want to retrieve the courses in the order of how many students they have. So how do I do that? So select C from course, order by size of C.students. Let's see what would be printed. Let's run this. Right click, run as JUnit test. Unit test has successfully completed. And if I look at the courses which are printed in, it's printed in this order. Spring in 50 steps, Spring Boot in 100 steps, and JPA in 50 steps. The default order which is taken is ascending. Spring in 50 steps has 0 students. Spring Boot in 50 steps has 1 student, and JPA in 50 steps has 3 students. So that's the order in which they are being printed right now. However, if I want to reverse the order, let's say I want to print them in descending order of number of students, then I can say size of students space descending, and I can go ahead and run that particular query. When I search for the results, I see this. So now it's in the descending order of number of students. This has the highest number of students, and Spring in 50 steps has no students at all. So JPKL can also be used to order different stuff. So you are ordering by number of students here. You can order by course name or anything that you would want to order it by. In the next step, we will write a few more JPQL queries. Until then, bye-bye. Welcome back. In this step, let's write a JPQL query using like. Earlier, we wrote a query to find courses which look something like percentage 100 steps. So we looked for something like percentage 100 steps and found those courses. What we'll do now is we'll write a little more complex like query. So we have student, and students have passport. So we want to find those students whose passport numbers are like in a certain pattern. So what pattern do we want to use? I would want to find those passports which contain 1, 2, 3, 4. If that pattern is present, then I would want to get that student. So I would want to find the student whose passport is of the pattern or it contains 1, 2, 3, 4. How do I do that? Let's look at that right now. So what we want to do is JPQL for students with passports in a certain pattern. Thing is, with JUnit test, nobody is going to call this method. So the fact that we are using underscore doesn't really make it a problem. So it's okay to use underscores in a unit test. It's not okay to use underscore in, let's say, in your production code. That disclaimer aside, let's go back. So we want to retrieve students. So I would want to create a type query of student, and I would want to select S from student. S. What we want to find out is we want to restrict only those students where S dot student. Where is the student? S dot passport. Yeah. What do we want to look for in the passport? In the passport, we are looking for his number. So we want to find students' passports number like the pattern we wanted to use was 1, 2, 3, 4. So I can say 1, 2, 3, 4. So percentage 1, 2, 3, 4. That's basically what we are looking for. And this would not be a list of course. The result list will contain a list of students. And let's organize the imports. And now let's run this query. Run as JUnit test. Let's look at the results. The results have student Ranga and student Adam. So Ranga and Adam. Let's see our data, whether that matches Ranga and Adam. This is 40,001, which is Ranga, and this is 40,002, which is Adam. That's cool. Jane does not have 1, 2, 3 for it. She only has 1, 2, 3 in her passport. So Jane will miss out. So the only results which will come back are Ranga and Adam, and that's very cool. In the last few steps, we were using a lot of things like order by, like, where condition, and we were using the relationships which were defined on the entities to write a lot of JPQL queries. JPQL supports a few other things as well. We use like. There is something called between. So if you want to find those rows between a certain numbers, so I would want to find all people whose height is between 5.5 feet and 6 feet. You can do something of that kind using between. You can use is null. You can check if something is null and only then get it. And you can use other functions like upper, lower. So this is specifically on strings. You can find the upper and the lower. And also you can trim a string as well as find the length of a string and things like that. So there are a lot of utility methods which are present with JPQL, just like we have a lot of utility methods with all the SQL queries. In the next step, we will move on to joins with JPQL. Until then, bye-bye. Welcome back. In this step, we will look at some of the joins you can do with JPQL. Normal join, left join, and cross join. We'll see what is the difference between them, and we'll try and see an example for each of these joins. I'll create a simple test, public void. I'll just call it join. Let's put our at test annotation on top of it to say this is a unit test. Now I would want to do a join here. Query for a join will look something like this. So select, let's say I want to join student and course. So let's select, typically when I just want one table, I would do this. Select S from student S, or select C from course C. So this is a normal query. Now if I want to join this with students, how do I do that? So if I want to join the course with students, how do I do that? Join. I need to find out where students is inside the course. The most important thing again is in JPQL, we are only concerned with how our entities are defined. We are not worried about how our tables are. So C.students. So join C.students. I would want to join course with students. And let's give an alias to this as well, S. So I would want to select course, comma students from course C, join C.students S. Let's look at the other ones. So if I want to do a left join, how do I do that? Select C from course C and left join C.students S. You might be asking, what is the difference between join and left join? Why should I worry about left join? The thing is, there might be courses without students. If there are courses without students, then this join will not return that course back. However, if I do a left join, it will return even those courses which do not have students at all. The last type of join is cross join. It will take all courses and all students and just cross them. It's not really a join kind of a stuff where it is matching who is registered for this course. Nope, it does not do that. It just takes every course and mixes them with every student which is present in there. Cross join, how do you do that? The way we do cross join is by this. Select C comma from course comma student S. The thing is, over here we are not really making use of the relationship that exists between course and student. We are just writing comma student comma S. So this is like some entity and this is like some other entity. If there are 3 courses and if there are 4 students, then this will return 3 into 4. So it will match every row with the other row in the student table and it will return 12 rows back. So these are the different kinds of joins that are present. Let's now execute each of these and see them practically. So I would want to write a query. So let's do this. So it's not a typed query anymore because the result contains C and S. The result contains course and student. So I cannot say result contains student alone. So I can use only a normal query. I cannot use a typed query. So query is equal to em.create query this. And it's not a typed query, so I cannot say this is student.class. The result contains both course and students. So even here, it's not a list of student. It can be any list. From the result list, I would want to get the course details and the student details. Before that, let's print the size of the results list. So result list dot size. So this would print how many results are there. And then what we'll do is we'll print all the rows which are present in the result list. What we'll do is we'll loop around it. Let's call this object result from result list. And after that, we can loop around it. So this result object contains both the course details and the student details. So result contains course as well as result contains student details as well. Course is first and student is next. The thing is, each element in this result is something called an array. So what JPQL does, what Hibernate does, is it puts these results into an array. It puts course as the first element of the array and student as the second element of an array, and returns an array of array. So what I would need to do here is I would need to declare an array of objects. And if I have to declare an array of objects in here, I would need to say this is a list of array of objects in here. So now I get the result. The first object is the course details and the second object are the details of the student. So result of 0 is the course details and result of 1 is the corresponding student. So let's print this out. So I'll do this logger.info. So this is the course and this is the student, comma, the parameters. Let's do it in order. Result 0, comma, result 1. So we are looping around the result. So this, if this returns 10 rows, each of the rows contains course and the student details. So what we are doing is we are looping around it and printing the course details as well as the student details. Let's run this and see what would be the results. We don't really have an assert unit test succeeds. What I'm really interested is in the results. You can see that the result size is 4. The course is JPA in 50 steps. It has a student called Ranga. JPA in 50 steps has a student called Adam. 50 steps Jane, and Spring Boot in 100 steps Ranga. So this is doing a perfect join. So this is matching the course with the correct student. That's really good. That's basically your normal join. However, you would see that in the normal join, we don't get the course which does not have a student. Which course does not have a student? When we look at the data that we have in here, the Spring in 50 steps course does not have a student at all. 10,002 does not have a student. 10,002, there is no student with that particular thing. So what would happen is 10,002 will not be part of the results at all. So the result size is 4, and you can see that Spring in 50 steps is not part of this result set. Now let's change this. Let's, instead of the join, let's try and do a left join. So I'll copy and paste the same thing. I'll call this left join and I'll do a left join and run this unit test now. In the case of a left join, you would see that even those courses which do not have students appear in the results. You can see here that the result size is 5. So I have this course with 3 students, it comes up. I have this course with no students. Here it's coming with student as null. So Spring in 50 steps, even though it does not have a student, it appears in the result. That's the magic of left join. So if you want even those courses which do not have students appear in your results, then you need to use a left join. The last join is not really a join at all. It's a cross join. So let's do that very quickly. Cross join. It just matches all courses with all students and returns the results back. So the way you do that is by just saying course C, comma, student S. So we are just taking a couple of entities and putting a comma between them and trying to get all the results between them. And let's run this. Run as JUnit test. If we look at the result size, it's 9. So there are 9 results coming up because there are 3 courses and there are 3 students. So it matches each one of them with the other. So even though Spring in 50 steps does not have a student, a row appears here with Ranga, Adam and Jane. So it just is a cross product. So what would happen in a cross join is something like this. Let's say I have 3 things, 1, 2 and 3. And the other table has 6 and 7. So let's say these are, here there are 3 rows and here there are 2 rows. The result set which comes from a cross join will be 1 matched with 6, 1, 7, and then it would go to the next row, 2, 6, 2, 7, and then it goes to the next row, 3, 6, 3, 7. So it just combines each row in the first table with each row in the second table. It does not look at whether it's really the matching course or whether it's really the matching student or anything like that. In this step, we looked at the different types of joins that you can do in your JPQL. We started with normal join where a perfect match is done. But what we saw in the normal join is the fact that those courses without students will not appear. Then we went to left join to make sure that even the courses that do not have students appear in the list. And then we looked at the last one, cross join, where each row from one table is just combined with another row from the other table. These are the different types of joins that are important in JPQL. Until the next step, bye-bye. Welcome back. From this step, we'll shift our attention to something called criteria queries. In previous steps, we looked at JPQL. The thing about JPQL is the queries are very similar to your SQL queries. While these queries are not really exactly SQL queries and not really as complex as them, but some of the Java developers feel that these are complex to write. Instead of writing a query, the question is, why not write a Java API for doing this stuff also? And there came something called a criteria API. The criteria API will really be a complex thing. If you're used to writing queries, you might even think, why the hell do I need to do something as complex as this? In this and the subsequent steps, we will write a lot of criteria queries. To write a very simple query like this with a criteria query, you need to write a lot of code. And we will see what is involved in writing that. Let's start with a very simple criteria query in this specific example. What we want to do is to get all the courses. We would want to define select C from course C using a criteria query. That's basically what we want to do. Let's get started now. I'll copy the JPQL test, Control C, Control V, and I would say criteria query test. Over here, what we want to do is I would remove all the other stuff other than the first one, which is exactly doing that stuff. So here we are right now using a named query from the course. So name query which we are using is this one. So I'll just copy that in here. So instead of named query, I'll say create query, and this is the query which is being executed, and I'll want to make it a typed query, so I'll say course dot class, and this would return us a typed query back. This is exactly what we did during our JPQL stuff, right? So we had a typed query example as well. So the typed query thing helps us to retrieve the results after typecasting it to course. So we know that we want to return, we know that the result is of the type course. So I would rather use a typed query to get that specific result back. This is cool. This is basically what we have done as part of our JPQL stuff. Now, the thing with criteria query is this definition of the query. So we would want to be able to do this query definition also in Java. In the info, let's not really write select C. Let's say typed query and print the results out. So now the thing is, now we would want to define this query using Java. How do we do that? The thing about the criteria query is it's a little tricky for the first time writers to write a criteria query. So what I've done is I have written down a few sequence of simple steps. I'm copying down the sequence of simple steps. The last step in here, building the typed query using the entity manager and criteria query, that's where this comes in. So we'll create a typed query using the entity manager and the criteria query and execute it. So the last query is very similar to what we did with JPQL. However, the first four steps are the complex ones where we really build this query. So we want to build this query using Java. And that's what we are trying to do in this first four steps. So let's get started. Let's look at each one of these steps one by one. The first step is to use something called a criteria builder. A criteria builder, you can think of it like if I want to build a where condition, if I want to build a from, whatever you would want to build, I would want to use a criteria builder. So I will create a query using the criteria builder. And to create a criteria query, we also define what is the expected result. The result type for this query is course.class, right? So we'll define that also for the criteria query. So let's do that right now. Where do we get the criteria builder from? Think about it. Only one source. Entity manager dot get criteria builder. I'll put a semicolon here, command 1 or control 1, and assign it to a new local variable. Typically, the criteria builder is named as CB. I will use the criteria builder to create a criteria query. So I would want to create a criteria query. So I would say cb.create criteria query. Create query. What is the expected result type? I'm expecting a list of courses. So the expected result type is course.class. Assign this to a new local variable. Criteria query, you typically use CQ. So now what we have done is completed the first step. We have created a criteria query. We are saying, okay, this criteria query, this will return a course.class. Which are all the tables that are involved in the criteria query? The tables which are involved are select star from course, right? So I would want to define this from course now. So I would need to define course first. So I would need to say this thing is from course. So I would need to define the root here. The root defines which tables I am getting the data from. We'll say criteria query dot from which table? From course. So course dot class. So this is the thing which we are defining in here. This is called the root of the query. So I'll say control 1 and I'll assign it to a local variable, and this is called course root. So this is basically representing this part of the query from course C. That's cool, right? In this specific query, we are not having any conditions, so we will not have any predicates or order by or any of that kind of stuff. So I can easily skip out steps 3 and 4 and directly jump into step 5, where we can now execute the query. So instead of the course.class is already specified. So when we were creating the query itself, we said this is a course.class, so I don't need to specify it in here. So over here, for the create query, I can say the query which I want to execute is cq.select and select from the course root. So what we are defining is the query is select from course. That's basically what we are defining in here. So select from course, and we would want to return the result set back. I understand it's a complex thing. So defining this simple stuff took us these 3 lines plus this select in here. So that compares against this when you are writing a JPQL. Okay, don't ask me why somebody has created this criteria query, but if you are interested, then let's go ahead and learn that. So if you run the JPQL basic test, actually I should rename the JPQL basic test. It's no longer JPQL stuff. It's successful, and you would see that all the details of the courses are printed in here. So this is printing all the courses. So this is the result which is coming out of the query. In this step, we looked at how you can build a criteria query. We looked at the different steps which are involved in it. We started with using a criteria builder to create a query. We defined a query saying, this is the result I would want to return back. And then we started creating a from clause. So we defined the from course. So we defined a course root, and we said execute the select on the course root. So select from course, that's the query which is executed, and we printed the result sets out. In the next steps, we'll look at more stuff regarding the criteria query. Until then, bye-bye. Welcome back. In the last step, we built a simple criteria query, select C from course C. In this step, we would want to add a where condition to this specific query. So first thing, I'll rename the thing. It's not, this is all underscore courses. Now I'll copy this test. What we want to be able to do here is now all courses having 100 steps in them. So I would want to find out all courses which have 100 steps in that particular course. Actually, I would be looking at the name of the course and see even if it has 100 steps. So the query, the criteria query which we would want to run is this. So this is the query we would want to execute. So where name like 100 steps. This is the condition we would want to add in. So the first steps do not change at all. So these remain the same. The place where there would be a change would be while we define the predicates. We would want to define a like first. So we would want to execute where name like this. So we need to first define a like condition. So I would use a criteria builder to define a like. So like what? For a like, I would need to pass in two things. What is the first one? What is the second one? What is the column? And what is the condition that we would need to check for? Column is, we know it is name. And the pattern we are looking for is percentage 100 steps. That is the like condition. The other thing we need to specify is which table this name column is present in. This is in the course root. So I'll say course root dot get name. So now we have the like condition defined. Let's have the like assigned to a local variable. I'll say assign statement to a new local variable. I'll just call this like. And now the like is ready. We need to add the where condition. So we need to add this to the where condition of the query. How do we do that? We now take the criteria query and say where add the predicate like. I'll can give a better name to the predicate. I'll say like 100 steps. So this is much more readable. Now cq.where like 100 steps. So you can almost read like where name like 100 steps. This is actually what I have put in as a fourth step below. So I'm adding the predicate to the criteria query. And now I can go ahead and run this query because now the entire thing is ready. You can see that the query which is executed is select from course where course name like something. And let's see what is the results that are printed out. The result that are printed out is having one course, Spring Boot in 100 steps. That's cool. Spring Boot in 100 steps is the only course which matches because the other two courses have 50 steps and 50 steps each. So in this step, we looked at how to add a where condition having a like to our query. In the next step, we will look at another criteria query. Welcome back. In this step, we'll write another simple criteria query. The thing about criteria query is the initial syntax for all this stuff is really complex. But once you start writing a lot of criteria queries, you would start feeling they are much more easier to write. What we want to do in this step is we would want to find all courses without students. So all courses without students. That's what we would want to find in this specific step. We would want to write a criteria query for that. The JPQL for that is select star from course C where we looked at it earlier. C.students is empty. That's what we wrote earlier. So we use this JPQL earlier, select from course where C.students is empty. Now we'll write the criteria query for that. So the basic structure of the course is the same. The only thing which would be different, think about it, what would be different? The predicates. So here the predicate is not like. What we want to use in the query is we would want to check whether it's empty. So the predicate is empty. So I'll say cb.empty is empty. What is empty? Course root.get students. So this is no longer like 100 steps, it's actually the predicate is students is empty. So you can see, you can almost read the query in here. The query is where students is empty. And then we execute the query. All the other stuff remains the same. And let's see what results come out now. Test succeeds. That's as expected. And what are the results that are being printed in here? Spring in 50 steps. That's the only course that we have created which does not have students, and that's very good. So in this step, we quickly created a simple criteria query returning those courses which do not have students. Until the next step, bye-bye. In this last video on the criteria queries, we will look at two kinds of join. Normal join as well as outer join. What we want to start doing is to join the course with the students. So what I'll do is I'll copy the query that we have created earlier, all courses without students. Let's modify that for our needs for this specific thing. So let's start with join. So I would want to use a join. So what I would want to do here is something of this kind, not course C join C dot students S. So this part of the query does not change. The predicate will be different, so I'll remove the predicates out. What we want to do is we would want to do a join. How do we define a join? Which table do we want to join with? We would want to join course root. Which one do you want to join with? We want to join course root with another collection. We want to join course root with students. That's what we would want to join with, right? So we want to join course root with students. Let's take this into a variable. I'll just leave it at join. The rest of the stuff remains as it is right now. Let's execute the join again. Right click, run as JUnit test. You can see that now there's a join that is being performed. So course is joined with students and all the results would be returned back. So when I look at the criteria query, you can see that there are 4 rows returning back, because when I joined course with students earlier, we got 4 rows as well. So here we are not printing the student details as such. That's the reason why you'd see the same course repeating twice. So you can see JPA in 50 steps, JPA in 50 steps repeating thrice because it has 3 students. When we join it with student, you'd get course and student, so there'll be 3 courses for JPA in 50 steps, and we have Spring Boot in 100 steps also coming back. This course has 3 students and this course has just 1 student. Now, one of the things which we want to do further is we would want to use a left join as well. So how do we define a left join using criteria query? Let's look at it right now. So instead of a join, what I want to do is do a left join. So we want to do left join c.students. How do we do that? It's a very easy thing. All that you need to do is say join students, comma, you can specify the join type. So I can say join type dot left. So even if the left side of the join contains a row and the right side does not contain a row, so if there is a course without a student, even that would be returned back. So if I run this query right now, right click, run as JUnit test, you would see that it's doing a left outer join on the course and the student right now. And if I go further down and collect the results, you would see that there are 5 results returning back. So the 4 results that we had earlier plus Spring in 50 steps. Spring in 50 steps does not have any students at all. So even that course is being returned back. In the last few steps, we looked at writing criteria queries. We looked at how to write a simple criteria query, how to add where conditions, how to add joins, and how to add left joins to your criteria query. Until the next step, bye-bye. Welcome back. Transaction management is one of the most important concepts whenever you're making changes to your data. A typical transaction involves multiple changes to data, and you'd want to ensure that either all of them are successful or none of the updates are saved to the database. And that is achieved through transaction management. In this and the next set of videos, we would talk about transaction management in depth. You would see that actually we take a step away from our usual practices when we talk about transaction management. When you look at all the in 28 minutes courses, they would be really hands-on. And you'd see that this specific section, at least the next few videos, we would talk a lot of theory about transaction management. The thing about transaction management is the annotations which Spring provides and which JPA provides makes transaction management very easy. However, understanding transaction management is a very tough thing. We will spend some time explaining you the importance of transaction management and what are the important theoretical things that are important related to transaction management before we add the simple annotations that Spring Transaction Management provides to us. In this step, we will talk about the importance of transaction management. Why is transaction management important? Let's just take a very simple transaction. You have A and you have B. And the transaction we are talking about is we are transferring $50 from A to B. So we want to transfer $50 from A's account to B's bank account. Let's say this specific thing is done in 2 steps, right? So you cannot directly transfer the amount. So when you're writing program for that, when you write the code for that, there are 2 steps typically, right? So you have to deduct A's account by $50 and then deposit the $50 into B's account. Let's consider a simple successful scenario. What would happen? At the end of step 1, this is 150 and no change in B's account. It will remain 300. And step 2, A's account will be 150 and B's account, what would be the value in it? 350. That's cool. A and B are happy. B might be happy, but A might not be happy because $50 is less in his account. But the transaction has successfully completed. The original intent is achieved. Let's assume a scenario where step 1 succeeded, but step 2 failed. So while I'm trying to deposit $50 into B's account, my program threw an exception. Let's say I lost a connection to the database or something went wrong. The state in which the system is at this point is A's account has been deducted $50, but B's account, the amount has not been put into it. This state is called an inconsistent state because we failed in between the transaction. So only partial updates related to that transaction have happened. In this kind of situation, what we would want to do is we would want to roll back all the changes. So you'd want to roll back the changes and you would want to set the system in the state where it was before this transaction. We would want to set the system back to the starting state. And this is what is called transaction management. If you looked at the previous steps, we use at transactional annotation a lot. This is one of the things a transactional would do. If any of the steps of the transaction fail, it would roll back all the changes which were done by the previous steps. In the next few steps, we will talk about the different important concepts related to transaction management. Until the next step, bye-bye. Welcome back. In this small video, we will talk about a few important properties that are important in a transaction management. They are called acid properties. You would have heard about acid properties a lot when you're talking about transaction management. In this small video, we'll try and understand what are the different things that are in the acid properties and get a high level understanding of them. A in acid properties stands for atomicity, C for concurrency, I for isolation, and D for durability. So these are really what each of the letters in acid ACID stand for: atomicity, concurrency, isolation, and durability. So let's take each one of them one by one. Let's start with atomicity. Atomicity is the basic thing that any transaction management wants to achieve. Either the transaction should be completely successful, or all the changes that are done by the transaction should be reverted back. That's what atomicity wants to achieve. If there are 10 steps in the transaction, either all of them should be successful or none of them should be successful. That is atomicity. Next, what is concurrency? The thing is, this specific transaction is one example. But when you take a bank, there would be thousands of such kind of transfers which would be happening in parallel. So this is one transaction. There might be 1,000 other transactions which might be happening in parallel. The thing is, concurrency says it should not matter how many other transactions are running in parallel. It should give you the same result as executing this transaction on its own. So you should be able to execute multiple transactions concurrently, but the end state should be the same as executing each transaction one after the other. So let's say there are 3 transactions: transaction 1, transaction 2, transaction 3. Whether you execute them in parallel or whether you execute them one after the other, the result should be the same. That is what is concurrency. A is atomicity, C is concurrency. Atomicity is that either a transaction should be completely successful or none of the steps should succeed. Concurrency is how many ever transactions you run in parallel, the result should be the same as if you are running them in a sequential order. Next, we would talk about isolation. I stands for isolation. Actually, isolation is not a one definite thing. You would see that there are really multiple levels of isolation that are present. How does one transaction which is happening affect another transaction which is running in parallel? If a transaction 1 is updating its account value and it's in between a transaction, will another transaction be able to see the updated ACE value? That's what isolation will determine. In the next video, we will talk about different isolation levels in detail. Let's stay away from isolation until then, because it's a very important and also a very tricky topic. Durability, D. D stands for durability, and durability means that once a transaction is successful, once the transaction has completed execution, then even if the system crashes or something wrong happens, the data should be persisted. Whatever change we have made during the transaction, the end state of this transaction should be persisted even if there are other failures, other system failures. So the fact that the transaction of transferring money from A to B's account is successful. So the end state of this transaction is 150 to 350. So A's account has a balance of 150 and B's account has a balance of 350. This state has to be persisted even if this system fails. So if a transaction is successful, then its end result should be permanent. That's durability. Any change that you make is durable. In this quick video, we looked at the 4 important properties of a transaction. Acid properties. A is atomicity, C is concurrency, I is isolation. We did not discuss isolation in a lot of detail. We'll do that in the next step. And D is durability. Atomicity, Either a transaction is completely successful or none of the steps are successful. Concurrency, it should not matter how many steps are running in parallel. It should be the same as running each of those in sequence. Any change that is done by the transaction should persist, should be durable. That's durability. And isolation is how changes within a transaction are visible to the other transactions. How much do you want to allow that? That's isolation. Let's talk about isolation in the next step. Until then, bye-bye. Welcome back. Before we dig deep into the isolation levels, there are three small concepts you need to understand. These are called dirty read, non-repeatable read, and phantom reads. When you talk about transactions running in parallel, a transaction 1 might be updating some data, and a transaction 2, which is running in parallel, might want to read the same data. These concepts come into picture in these kind of scenarios. So the same data is being updated by one transaction and it's being read by another transaction. So let's look at each one of these concepts in depth. Let's start with the concept of dirty read. Let's say two transactions are running in parallel, transaction 1 and transaction 2. Transaction 1 involves transferring $50 from A's account to B's account, and transaction 2 involves sending $100 from A's account to C's account. Let's assume that these are running in parallel as well. So transaction 1 has two steps, right? 1 and 2. Deduct A's account by $50. After that, deposit those $50 into B's account. And transaction 2 has two steps. Transaction 2, step 1 is to deduct A's account by $100 and next deposit $100 into C's account. If the order in which the transaction runs are the transaction 1 is first completed fully and after that transaction 2 is fully completed, it's not a problem at all. But in real world, these transactions can run in parallel. Let's assume the order in which these are running are transaction 1 step 1, transaction 2 step 1, transaction 1 step 2 and transaction 2 step 2. So what will happen? Deduct A's account by $50. So it will be $150. A's account will be $150. Deduct A's account by $100. $50 will be the balance. Deposit $50 into B's account. $350. That's perfect. And deposit $100 into C's account. This is when everything happens perfectly, right? By the end, A's account will have 50, B's account 350 and C's account has $600. But let's assume a scenario that the step 2 of transaction 1 failed. So if step 2 of transaction 1 failed, what would happen? This update will not happen. And what was the balance in A's account before transaction 1 started? It was 200. So what could happen is you would set, because the transaction 1 failed, you might be setting the balance of A's account to 200. And let's say transaction 2 succeeded. What would happen? By the end of the thing, A's balance will be 200, B's balance will not change, but C's account will have more money. So C's $100 are transferred to C, and because transaction 1 failed and we set the balance of A's account to what it was at the start of the transaction 1, A has $200. So there is $100 extra which C has got, but A is very happy. His balance has not been deducted. So why is this problem coming in? The most important reason why this problem is coming in is something called dirty read. Let's go back to the successful transaction scenario. So let's say the transaction is successful. This is fine, 50, 350, 600. This is successful scenario, but the problem comes in because here transaction 1 is changing the value of the A's account. Transaction 1 has deducted it by 50. But even before transaction 1 has completed execution, transaction 1 will complete execution in here, so in row 6. But even before transaction 1 completes execution, transaction 2 is trying to read the value which is updated by transaction 1. And that's called a dirty read. Dirty read is another transaction reading the modified value before a given transaction is committed. So even before transaction 1 is committed, transaction 2 is reading the modification that is made by transaction 1. That's called a dirty read. What are the other two things? Non-repeatable read and phantom read. Let's start with non-repeatable read. Let's consider a very simple table, a person table. It has 3 rows: ID, name and age, Ranga, Adam, Eve, and their age 25, 29 and 32. Let's say the first step of the transaction is select star from person where ID is equal to 10. So the transaction 1 has started with reading this row. So it is started with reading this row. What transaction 2 does is it updates the age of this to 30. So this row age is being updated to 30 by transaction 2. And transaction 1 in the step 2 is executing the query select star from person again. And it would then get the new updated values. So transaction 1, when it first reads this row, gets a value of 25, but when it reads the row again, it gets a value of 30. This is called non-repeatable read. When I'm reading the same value twice during the transaction, I get different values because some other transaction has updated that value. This problem is called a non-repeatable read. When I'm trying to read the same thing twice, I'm getting two different values. It's not repeatable. This is a non-repeatable read. The last thing is called a phantom read. Let's say transaction 1, the first step is to get all rows where age is between 5 and 55. So all these 3 rows are returned because all these 3 rows have ages between 5 and 55. Another transaction is inserting a new value in. Insert into person values 13, Ravi 25. So a new person is being inserted, 13, Ravi, and his age is 25, very young guy. Now, when the transaction 1 reads the values again, let's say the transaction 1 executes the query again, then what it would get back is 4 rows. Earlier, when it executed the query, it used to get only 3 rows. But now, when it executes the query again as part of its second step, it is getting 4 rows back. This is called a phantom read. At different times, I am getting different number of rows in the same transaction. In transaction 1, at one point I'm getting 4 rows back, at another point I'm getting 3 rows back. This is called a phantom read because I'm getting a phantom row added in. And if, let's say, instead of the insert query, this was a delete query, let's say Eve is deleted, then it's possible that transaction 1 gets only 2 rows back as well. So this problem is called a phantom read. In this step, we looked at 3 important concepts related to isolation levels: dirty read, non-repeatable read, and phantom read. Dirty read is when transaction 2 reads a value which was modified by transaction 1 before the transaction 1 is committed. Non-repeatable read is when a transaction tries to retrieve the same data twice and it gets 2 different values during the same transaction. Phantom read is when I get different number of rows as a result of a query at 2 different points of the same transaction. In the next step, we would talk about different database isolation levels and which of those isolation levels solve which of these problems. Until then, bye-bye. Welcome back. In this step, we will be talking about the 4 different kinds of isolation levels and what are the problems they solve. 4 different kinds of isolation levels are read uncommitted, read committed, repeatable read, and serializable. So let's start with read uncommitted. So read uncommitted is no restrictions. So you would allow any transaction to read any data, whether it's uncommitted or committed. That's basically read uncommitted. Thing is, if a transaction makes a change in the data, as soon as transaction makes the change in the data, another transaction can read that data. So dirty read is possible, and it does not worry about non-repeatable read or phantom read. So that's read uncommitted. You don't have any locks at all. You allow transactions to read anything as they wish. And in read uncommitted, all 3 problems are possible. If transactions run in parallel, then all these 3 problems are really possible. The next isolation level is called read committed. What this does is it will only allow a transaction to read the data if it is committed by another transaction. What do I mean? Let's say a transaction 2 is updating this value to 20, and as long as this transaction 2 is not committed, no other transaction will be able to read this 20 back. What happens is there will be a lock on this specific value. So this value 20 is locked until the transaction 1 commits. When the transaction 1 commits, other transactions will be able to read this data. So any data that is changed during a transaction will be available only when the transaction is committed. So there will not be any dirty reads when you use isolation level read committed. Next, repeatable read. What repeatable read isolation level does is it will lock not just the modified values during the transaction, but also whatever values were read during that transaction. So if this row was read during the transaction, that specific row will be locked and will not be available to other transactions. Only when this transaction completes execution, the lock on this row will be removed and other transactions can modify this value. So in repeatable read, both dirty reads and non-repeatable reads are solved. So if I'm using a transaction level of repeatable read, what would happen? As soon as I do a select star from person where ID is equal to 10, this row is locked down. This row is locked down. So if any transaction is trying to update that row, update person set age is equal to 30 where ID is equal to 10, that will not be allowed to execute the update. Because this row is locked down, it has to wait until the transaction completes, until transaction 1 completes. So transaction 1, when it reads step 2 again, this row would have been logged, so it will get the same data back. So it will get 10, Ranga 30 back. Serializable is the last level of isolation where all the 3 problems are solved. How does serializable work? Let's say you are trying to do this query. Select start from person where age between 5 and 15. What would happen is a lock would be created for any row which matches this constraint. So whether another transaction is trying to insert a data which satisfies this constraint, or it is trying to modify a data which is trying to satisfy this constraint, it will not be allowed to do that. This is called a table lock. So a table lock is placed on this specific constraint. So with age between 5 and 55, you will not be able to insert, select or update any of the rows. Once a transaction starts using a query, with those constraints, with the query things which are in place for that specific query, no other transaction will be able to read, update, or delete data until the transaction completes execution. So until transaction 1 completes execution. Consider the worst case scenario where you are doing a select star from person. So in a transaction you are doing a select star from person. That would mean that the entire table is logged for you until that transaction completes successfully. So until transaction 1 completes successfully, no other table will not be able to do anything with the person table. In this step, we quickly looked at all the 4 different isolation levels. In the next step, we will discuss about the consequences of using these isolation levels in detail. Until then, bye-bye. Welcome back. In the last few steps, we understood a few important concepts related to database isolation. We talked about things like dirty read, non-repeatable read, and phantom reads, and also understood the 4 different isolation levels: read uncommitted, read committed, repeatable read, and serializable. Dirty read is data which is modified by one transaction. It should not be read or it should not be available for other transactions until that transaction is committed. If there's a violation of this rule, it's called a dirty read. Non-repeatable read is 2 times in a transaction. When I'm reading the same data, I get different values. Phantom read is getting different number of rows when I execute the same query on the database. We saw that read uncommitted does not solve any of these problems. When I do read committed, we have a lock on all the values that we have changed during that transaction. Until the transaction ends, all that data is logged. So we provide a solution for dirty read. However, they can still be non-repeatable reads and phantom reads. When it comes to the isolation level of repeatable reads, what would happen is we would have a lock on all the rows which we read. So if I read this row during that transaction, I'll have a lock on this row. That means dirty read and non-repeatable read are solved. However, phantom reads are still possible. When it comes to serializable, we would lock everything that is matched by this specific query condition on the table. Thereby, we solve all the 3 problems. Now, the important question that you would need to be able to answer is, what is the right isolation level for your application? If you use serializable as the isolation level for your application, then what would happen is you will not have dirty reads, you will not have non-repeatable reads, you will not have phantom reads, but you will have very poor performance. Imagine that if you are reading a specific table, if you are doing a select star on a specific table in a transaction, and let's say 10,000 such transactions are running in parallel. Each transaction will be waiting. So one transaction executes, all the other 9,999 transactions are waiting for this transaction to complete. And that would create a really big performance problem. So you should take into consideration the factors related to your application. You should think about your application first before you are deciding which transaction isolation level to use. Typically, the transaction isolation level which is used by most of the applications is read committed. It gives you enough guarantees about the quality of data and also ensures that the performance of the system is good. That would ensure that you're not really locking a lot of stuff, and also the system remains in a decently consistent way. The thing about this is there is no one silver bullet. You have to really analyze your application, look at it, and then decide which isolation level to use. And it's also possible that even in the same application, you can have different isolation levels for different kinds of transactions. Let's end all the theory about transaction management with this, and in the next step, we would start discussing a little bit about Spring Transaction Management and JPA Transaction Management. Until then, bye-bye. Welcome back. Until now, in all our examples where we use a transactional, we had been using Spring Framework transactional annotation. The thing is, there is another transactional annotation which is present also in JPA. So if I search for transactional here and remove this, and now I can do a control 1 here, you'd see that there are two options which are shown. One is Java X transaction and the other one is Spring Framework transaction. So what is the difference between these two stuff? Let's say in an application, you're talking to two databases, database 1, database 2, and also you're talking to, let's say, an MQ. So you're talking to an external interface over MQ. So in a single transaction, I'm making a change to the database 1, database 2, and also making a change over MQ. I'm sending a message over the MQ. In that kind of a scenario, you need complicated transaction management. JPA will be able to manage transactions over a single database. So if I'm using JavaX transactional, then it would work as far as I'm working with a single database. Even if I'm making multiple updates, so let's say I'm making two updates on the same database, update 1 and update 2. If update 2 fails on that database, it would make sure that the data change which was done by update 1 will be rolled back. In that kind of a scenario, if I'm only talking to database 1, the JPA transactional is good. It's sufficient for us. I can use JavaX transactional annotation. However, if you would want to manage transactions across multiple things, across multiple databases and queues, then the recommended one to use is the Spring transactional annotation. That's the reason why we use a transactional provided by Spring, so that it would be consistent across the application and you'd be able to manage transactions across multiple databases, queues, JMS messages, whichever ones you'd want to manage transactions across. That's number one. So that's Spring versus JPA. Whether you should use Spring Transaction Management or JPA Transaction Management. The second important thing that you would need to decide when I put add transactional with Spring is I can decide the, let's add Spring in here. I can decide the isolation level. So to this, I can set isolation. We talked about isolation in detail. So we can say this isolation level. So isolation level I want to use is what? I can say whether it's default, read committed, read uncommitted, repeatable read, or serializable. I can specify any of these four isolation levels at the level of a transaction. So we looked at, when you use Spring transactions, we looked at how you can configure an isolation level for your specific transaction. You can also set the default isolation level across all transactions for a specific Hibernate connection. You can do that by using a Hibernate specific property. It's called hibernate.connection.isolation, and you can set the value to whatever isolation level you'd want to use. So if you open up Java SQL connection, then you would see the different constant values. So if you want to use read uncommitted, the value is 1, and if you want to use read committed, the value is 2. For repeatable read, the value is 4, and if you want to use serializable, the value is 8. So you can specify a property like this, and that would act as the default isolation level across all transactions for this Hibernate connection. In this quick step, we looked at all the important things that you had to decide for your transaction management, whether you want to use JPA transaction management or Spring transaction management. What is the isolation level that you would want to use, and what is the default isolation level that you would want to use. Until the next step, bye-bye. Welcome back. From this step, we would start looking at Spring Data JPA. We had created two repositories earlier, course repository and student repository. Course repository to manage the course entity and student repository to manage the student entity. And if you look at the methods to find by ID, save, and delete by ID in these two repositories, you'd find that they are exactly the same except for the student. So this is managing students, so this uses student.class. Other than that, these two repositories are almost the same line by line. That's problem number one. So there is a lot of duplication among the repositories. How you would call the entity manager method for managing one entity is exactly the same as how you would want to call it for other entities as well. The other problem is the proliferation of data stores. Earlier, there was only one kind of data store, relational databases. But now, there are multiple kinds of data stores, relational databases, a variety of big data databases which are coming in. Spring Data aims to provide simple abstraction to be able to access any kind of data. And Spring Data JPA is the JPA specific implementation of Spring Data. In our pom.xml, when we chose JPA in the Spring initializer. If you remember, this was one of the first steps which we done during this particular course. We added in JPA, and that added in Spring Boot starter data JPA. This is the starter which brings in JPA, Hibernate, as well as Spring Data JPA. If I open the pom.xml for this, you'd see the basic Spring Boot starter. You would see Hibernate, which is present in here. And also, you would see transaction API to be able to manage the transactions. And here is Spring Data JPA. This is the Spring Data JPA that we would be talking about in this and the subsequent steps. What does Spring Data JPA provide? Let's now say I would want to create a repository to manage courses using Spring Data JPA. How do I do that? It's very simple. All that I need to do is create a new class. I would want to call this course Spring Data repository. Right now I have a normal course repository using JPA. I'll use Spring Data in here. So I'll call this Spring Data repository, course Spring Data repository. One of the important things is when you create a Spring Data repository, it should not be a class. It should be an interface. This is very important. It should be an interface. So you're not really defining a class, but you are defining a interface. Now, this repository interface, we would want to extend another interface, which is called JPA repository. So we extend JPA repository. The thing is, JPA repository is also a interface. That's the reason why in this interface we are extending the JPA repository. And the entity we would want to manage is course. That's the first one. And the ID of course, as we already know, is of type long. All you have to do is organize the imports. You can see that this is the exact course that we created instances of and played with while we were talking about JPA. Now let's see how to play around with it using Spring Data JPA. And in the course, the ID field has a type long, and that's the long which we passed in here. We have a simple course Spring Data repository ready. In the next step, we would write a unit test to be able to insert and get the data using this repository. Until then, bye-bye. Welcome back. In this step, let's look at what all things you can do using the course Spring Data repository by writing a quick unit test. I'll go to the repository package in source test Java, and I would copy the course repository test. Control C, Control V. I'd want to call this course Spring Data repository. Spring Data repository test. And in the course Spring Data repository test, we don't want to use the course repository. What we want to use is course Spring Data repository. And I would remove all the other tests which are already present in there. Let's write a new test, add test and public void Let's start with testing find by ID. Let's say find by ID. What we want to do here is call repository dot find by ID and pass in 10001L. If you open up the data.sql, you can see that course 10001 is JPA in 50 steps. That's cool. So now I'm trying to get the course. One of the important things with a Spring data repository is that it would return a optional back. So let's take the optional. I'll assign it to a new local variable. So this is course optional. This is one of the important changes in the latest version of Spring Data JPA. That's basically that find by ID will not return a course object back. It will return a optional. This is very good because optional provides a way to check if the course exists or not. So what we'll do is do a logger dot info course optional dot is present. The thing with the optional is it eliminates the need for a null value. Let's say we are passing in 20,001. There is no course with that ID. Then what would happen is course optional would be a proper object, but it would not contain a course. So is present will return false. So find by ID course present, and we can create another one. For example, find by ID course not present. Let's say 20,001. For 20,001, there is no course which is present. So let's run these two tests and see what would happen. Right click, run as JUnit test. You can see a green bar. We don't really have any asserts, so we would expect a green bar there. You can see that the first test prints true and the second test would print false because the course does not exist. And the best way to do unit testing of this kind is actually to add an assert. So I can say assert true. So in this specific example, the course should be present. And over here in the other thing, it's assert false. I would want to check that the course does not exist. Control 1 and add a static import. And you can run the test and you would see that both of these tests would succeed. You see a green bar there. That's cool. So in this quick step, what we did is we quickly used the find by ID method. So the find by ID method is present by default inside the Spring data repository. So we created a course Spring data repository. We did not need to implement anything. We didn't write a single line of code in here, and we got all the functionality to retrieve the ID for free. Actually, we got a lot more functionality for free. We will review all that in the next step. In the last step, we wrote a couple of unit tests using find by ID. In this step, we would look at all the other different options which are provided by this Spring data repository. So let's take this repository. I'll just call this playing around with Spring data repository. Repository dot, you can see that there are a lot of methods that are coming up for free. So what I'll do is instead of looking at the methods right here, I can go to the repository class and the JPA repository. This kinds of gives you a high level picture of what are all the methods which are present in here. If you take a quick look at the type hierarchy of JPA repository, you can see that JPA repository extends paging and sorting repository, and paging and sorting repository in turn extends the CRUD repository. So the CRUD repository is one of the fundamental Spring data repositories. It provides all the basic operations that you would need to do on an entity, the basic CRUD operation. So if I do the outline for this, you'd see these methods. You can find by ID. You can find if a ID exists. You can find if a course with this specific ID exists. You can find all courses, and you can find all the courses with a specific set of IDs. You can find out how many courses are present, and you can delete courses by saying delete by ID, and you can also do a delete all. So there are a wide variety of methods which are provided by the CRUD repository. These are all typical create, read, update, and delete methods. You can also use this save to either do the update or the create. So if you want to do the update or the create, what would you use? You use this save method. So the CRUD repository provides all the basic methods that you would need to play with an entity. Paging and sorting repository adds the methods which would be needed to sort based on a specific field, to add pagination to the results which are delivered by the CRUD repository. We will look at some of the methods related to paging and sorting repository a little later. The JPA repository adds the JPA specific methods. Some of the important ones are flush, for example, save and flush is another good example, and also to be able to do things in a batch. Let's now do some of the basic operations in our unit test. So let's say I want to create a course. So how do I do that? Repository.save new course of microservices in 100 steps. The same method can also be used to update the thing. So let's say I'm creating a course. And let's say after that I'm saying course dot set name microservices in 100 steps updated. I can use the same method to update as well. So the same method can be used to create a new course as well as update it as well. Let's see what would happen now. Run as JUnit test. You can see that first a course is inserted in. And after that there is an update course as well. So the save method can be used to do both updates and inserts. And other than that, you can also do a find all. Let's comment this stuff which is present in here. Let's say you want to find out all the courses. So I can say logger.info and let's put all the information about the courses. So first I'll say courses. I want to retrieve all the courses. Earlier we had to write a big named query for that. But with repository, with Spring Data JPA repository, it's very easy. All that you need to do is repository.find all. Repository also offers other methods. For example, if I want to put in the count, repository.count. So in the next one, let's use the count method. So I'll create another logger.info saying count, repository.count. You can run this as well and see what happens. You can see that all the courses are being retrieved. Select start from course, and over here all the courses are being printed. So this is the complete set of courses that are being printed. And next you can see that there is a count star also being performed. You can see the count of number of courses present in here, 3. In this step we completed the list of CRUD operations that are typically performed using a Spring Data repository. We performed an update on a course, we created a new course, we did a few queries on them, find all, count, and things like that. Until the next step, bye-bye. Welcome back. In the previous step, we looked at the CRUD methods. In this step, we would look at how to add sorting to your queries. So we did a find all, and to the find all, if I want to add a specific sort, how do I do that? Let's see that in this specific short video. I'm going to copy this test out. What do we want to do? We want to sort. So I'll say sort. So I would want to sort these list of courses. So we saw that when we ran the test, the output which was printed was this. Now I would want to sort by name in the descending order. What I mean by descending order is starting from Z to A. Let's see how to do that quickly. So the first thing you need to do is to define a sort criteria. How do I want to sort? I would want to sort in the descending direction. So sort dot direction dot descending, in the descending direction based on the field name. Sort is one of the classes which is present in the Spring Data framework. So Spring Data has this sort class which I'm using to set the sort direction, and you can pass the sort as an input to the find all method. So now we'll print sorted courses. So this was what, when we printed courses, this was the output. What would be the output when I run sorted courses? Let's see it right now. The test is running. I ran the wrong test. I should have run the sort. So let's do this. Right click, run as JUnit test. I can remove the comments here. Okay, here are the sorted courses which are printed. You can see that they are printed in the descending order of name. So here it's I and here it's B. So I is first and B is next. So Spring in 50 steps, Spring Boot in 100 steps, and Spring JPA in 50 steps. If you want the default sorting order, I can also say dot ascending. Now you can add additional criteria onto it as well. So if you want to sort by any other thing which is present in course, let's say last update date or create date, you can add a criteria on it as well. All that you need to do is to say dot end and or add another sort criteria in here. So these two criteria would be used. So this would be the primary sorting criteria, and if they have the same name, then the secondary sorting criteria would be used. In this quick step, we looked at how to sort your results using Spring Data JPA repository. Until next step, bye-bye. In the last step, we looked at how to sort data using Spring Data JPA repository. In this step, let's look at how to paginate something using Spring Data JPA repository. If you understand pagination, pagination is when you have a set of results. Let's say 100 results are being returned back. You'd want to divide them into pages. You would want to divide them into pages of 10 results each. When you do a Google search, the first page would contain, let's say, 10 or 20 results. That's pagination, right? So when you do a Google search, it will not return 100,000 results back. All that it would return back is a page of results. It would return 10 or 20 results back. So we'll apply this same concept to the Spring Data JPA repository. In our data SQL, we have very few courses which are inserted in. So what I'll do is I'll insert a few more dummy courses quickly. So I'll say insert 10,004 and I'll say dummy 1. I'll insert a few more so that we have something to play with when we are talking about pagination. 2, 3, 4, and 5. And now I can update the IDs 5, 6, 7, and 8. So now we have 8 courses, 10,001 to 10,008, and we would want to divide them into pages of 3. So when I say first page, I would want these 3. When I say second page, I would want these 3. After that, the last page would contain these 2 things. So let's see how to do that. I'm going to the Spring Data JPA repository test, and I'd want to divide it into pages. So to divide it into pages, we need to use a class called page request. So page request is equal to new page request. To the page request, you can pass in 2 parameters. One is the page and the other one is the size. So which page? Page number starts with 0. So I would want the first page, and the size of each page is 3. One of the things that you can already note is the page request method is deprecated. A better way of creating a page request is, instead of saying new page request, I can say page request dot off. So I would want to create a page of size 3, and I would want to get the first page back. Now let's say first page and print the repository in here. So find all, and I would need to say page request. What I'll do is I'll not do it here. I'll actually extract a local variable and call this first page. I get the first page back and I'm printing it to the console. Let's see what would happen. You can see that the JUnit succeeds. Obviously, we don't really have any asserts right now. And if I search for first page, you'd see page 1 of 3 containing course instances. So let's see what are the details which are present in this page. How do we do that? First page dot get content. So this would get the content of the page. So let's run this. You can see that the first 3 courses are being printed. Even though there are 8 courses, only the first 3 pages are being printed. First page also has a norm cut. First page also has a number of utility methods. So the page class has a number of utility methods. You can get the number of the current slice. The number of the current slice is 0. You can get how many elements are present in here. In this specific instance, it's 3 elements. You can get the pageable element. So we use a pageable element to get this as a result. So you can get the pageable element also, and also you can get the next pageable. So you can get the next pageable and execute the search for the next page as well. So for example, if I want to say I would want the next page, I can say pageable next page or second page, right? Second page would be next page, and I can execute that using this again. So I got the pageable, the page request. So I can say second page. I would want all the details which are present in the second page. So I can say second page. Let's rename this to first pageable so that we don't have a naming conflict. Second pageable. Now you can print the second page as well. So this would be second page dot get content. And similar to this, you can get the third page content as well and see what's in there. So let's run this and see what happens. You can see that first the content of the page, first page is printed, and after that the content of the second page is also printed. You can see that 3 courses are being printed: dummy 1, dummy 2, dummy 3. You'd see that if you get the pageable out of the second page or the next pageable out of second page, and you would execute the same find all method with that as the parameter, you would get the results of the third page. So the way we would use this in a web application, for example, is first we would get the results of the first page and return it back. And if user clicks next button, we would execute this. So we'll execute this code and we would return the second page content back. So in this way, we are actually paginating the whole thing. In this quick step, we looked at how to paginate using Spring Data JPA repository. Until the next step, bye-bye. In the previous few steps, we looked at all the different methods which are provided by JPA repository. All that we had to create was a simple interface, and then we were able to do a lot of stuff with it in the unit test. We checked all the CRUD methods. After that, we looked at how to paginate stuff, how to sort stuff, and all the other stuff. In this step, we will focus on creating custom queries. Some of the times, the default methods which are provided by JPA repository are not sufficient. In those kind of situations, you can create custom query methods using Spring Data JPA. Let's look at some of the examples in here. Let's start with a simple one. So let's say I would want to be able to search by name. So I would want to find all the courses with this specific name. How do I do that? I can do that by just defining a simple method. I'll say find by name, and I can pass in name as the input parameter. So here we are not really creating a method. All that we are doing is the method declaration. So we are defining a method in the interface. I would want to find all courses which have this name. Now all that I need to do is define the interface, and if I go to the unit test, I'll copy one of the things which is present is here already, and this is to find using name, and I'll have log.info find by name, and I would want to find repository dot find by name. That's the method that we created. I'll copy the name from data.sql JPA in 50 steps. Be careful to remove the quotes out and add the closing bracket in. Let's run this and see what would happen. You can see that a Hibernate query is being fired. Course name is equal to JPA in 50 steps. That's cool. And after that, you can see that find by name course is being retrieved back. So a course with that specific name is being retrieved back. You can call it find by name, or you can say query by name. Whichever way you'd like it, you can define it. So find or query, both of them are good names. You can also do other things. So you can say, I would want to find the count by this name. So I would want to find how many courses have this specific name. The other thing you can also do is add more criteria. You can say find by name and ID. It does not really make sense because when I do ID, it would return only one row back. Find by name and ID does not really make sense, but the idea is that you can use two parameters. In the course right now, we don't really have two things which I can use to search. So that's the reason why I'm saying find by name and ID, and then I can pass in comma long ID. You can also add sort criteria to your name. So I would want to find by name, and I would want to be able to sort this by order by ID. So I would want to find by ID, find by name and order by ID. And if you'd want descending, then you can say ID descending. You can also create delete methods in the same way. So just like I create the find methods, instead of find, if you see delete, then these methods will be, these rows will be deleted. The matching rows for this criteria will be deleted. It would match by name. So as soon as we define a method, what would happen? The name will be matched against the name in the course. And here we said ID, so the ID would be matched against the ID in the course. If the different query options which are presented by Spring Data JPA are not really sufficient for you, you can also define a query. So you can say add query and define the query in here and define what would be the results which it would return. So I can say add query and define the exact query. Let's say I take the course. Let's just take the example of a query which is present in here. So this is a named query. So I'll just copy this for now. I can say this is a query and this would return a list of courses, and I can give it a name as well. So I can say courses with 100 steps in name. You can also use a native query if you pass in additional parameters. So you can say add query, you can say this is the value. I'll copy this. Instead of a JPQL query, if I'm wanting to use a normal query, so let's select start from course where name, like this is a normal native query, right? So if I'm using a native query, then I can do value is equal to this and say pass in another parameter. It says native query is equal to true. This would use a native query to execute the query. So count with 100 steps in name using native query. So instead of using JPQL, we are directly writing our own native query. And if you want to use a named query, there is an option as well. So all that you need to do is say query name is equal to name of that query. So the name of this query in course is query get 100 step courses in name using named query. In this step, we looked at how to define additional query methods using a Spring Data JPA repository. We created a few simple methods using find by, count by, and also we saw that we can use delete by. So find, retrieve, query, delete, these are the keywords. So if you start a method with find or query or retrieve, all of them would do the same thing. They would do a select from the table. If you do a delete, the data would be deleted from the table. The other options we have is either use a named query, which we are doing in here, or we can write a JPQL and execute it as a query, or we can write a native query and execute it. In the last few steps, we looked at how Spring Data JPA makes it very easy to write queries. Whether you want to do CRUD operations or you want to do your own specific queries, Spring Data JPA makes it very easy. In the next step, we would move on to something called Spring Data JPA REST. I'll see you in the next step. In this quick step, we would look at something called Spring Data JPA REST. In the earlier step, we created a simple repository using Spring Data JPA. We created a core Spring Data JPA. All that we had to do was to define a simple interface extending the JPA repository. Now, I would want to expose RESTful services around this. I'd want to expose services to be able to operate on the course. How do I do that? That's what Spring Data JPA REST provides. Either you can typically use Spring MVC to create your RESTful web services, or you can use Spring Data JPA REST. To use Spring Data REST in your project, all that we need to do is go to our pom.xml and add in another dependency. This dependency is called Spring Boot Starter Data REST. This is called Spring Boot Data REST. This might take a little while. It has to download a few dependencies in, and it would add them to your class path. Once the application is built and ready for you, you can run the demo application. I'll do a right click, run as Java application in here. When the application starts up, you would see a lot more repository REST handler mappings which are present in here. So mapped / repository / ID / search and a lot of other stuff which are present in here. Now let's see how to make use of this repositories that we have added in right now, the dependency which we have added in right now. All that we need to do is to make this a Spring Data REST repository. How do I do that? Repository REST resource. So once you import it in, this is now a REST resource. So this repository is exposed using Spring Data REST. To this thing, I can set a path as well. I'll set a path for this. I'll say the path for this specific thing is /courses. When I say path is equal to courses, what would happen is this URI would be /courses. This resource would be exposed at /courses. Let's see what would happen. Let's restart the application. When you launch up courses using localhost 8080/courses, you'd see that there is a response which is coming back. However, you'd see that there is an infinite loop which is being kicked in. What is happening is when we try to retrieve the details of the courses contains reviews and students contains passports. Passport again contains students. So the students contain passport contains students. So this cycle is repeating recursively, and this is causing an infinite loop. So let's kill the application and fix this first. The way we can ignore a specific field from being returned back in the JSON response, it's actually at JSON ignore. So let's add in at JSON ignore and organize the inputs. I'd want to use the Jackson annotation JSON ignore. You can restart the application now. When I do localhost 8080/courses, now you would see some good data returned back. You can see all the list of courses which are present in here, JPA in 50 steps, the reviews for it. If you'd want to exclude the reviews, you can add JSON ignore on that as well. And you can see the first course, second course Spring in 50 steps, and then we have Spring Boot in 100 steps, and after that we have dummy and all that kind of stuff. One of the things I'll do right away is remove all the dummy data from data.sql. I don't really want it there. Be added in just for the sake of pagination. So let's get rid of that. That's cool. So we only have 3 courses right now. That's cool. But getting back to our browsing of the REST repositories, if you want to get the details of a specific course, so let's say I wanted to get the details of the course which is present in here, name, JPA in 50 steps. What is the ID for that particular course? 10,001. So if I say courses slash 10,001, you would get the details of that specific course. It's JPA in 50 steps. You get the reviews for it and the links as well. What we are looking at right now is tip of the iceberg of the features of Spring Data JPA REST. We are retrieving the resources using a get method. Actually, all different kinds of methods are exposed on the courses right now. So you can create new courses, you can update courses and everything using REST. If you want to quickly expose RESTful resources out of your repositories, then Spring Data REST provides a great alternative. However, this is not really recommended for production and things like that. But if you really want to quickly prototype something, then Spring Data JPA REST provides you with a great alternative. Until the next step, bye bye. Welcome back. In this introduction video to caching, what we'll do is we'll get an overview of what is caching and what are the different options that JPA provides for caching. Let's get started now. Why do we really need a cache? When we talk about typical web applications, we would be talking about multiple layers, right? So you have a web application, having a web layer, talking to a business layer, talking to a data layer. And the data layer talks to the database. It's basically you have a UI or a web layer talking to a service or the business layer, talking to the data layer. The data layer is the one which talks to the database. Where does Hibernate come into picture? Where does JPA come into picture? Hibernate and JPA come into picture in the data layers. The data layer is where we are spending most of our time during this course. The data layer needs to retrieve the data from the database. Let's say I'm developing a to-do management application and I show the user details, let's say a username on all the pages of the application. What I would need to do is I would need to get that data from the database every time. If I don't have any caching mechanism, then each time I would need to go to the database and get the data. Typically, the database is installed on a separate system compared to your application. So there is a network round trip. So over the network, a query is fired to get the user details and the data for the user is returned back and we display it on the screen. However, the thing is, this user data is not going to change very often. The name of the user is not something which would change frequently and therefore it can be cached. Hibernate provides multiple options where you can cache this user information in the data layer. What would happen is the first time user logs in, we would pull the data from the database and put it into the cache. And for all the subsequent requests for that specific user details, we can return the data from the cache. So we would avoid the network round trip. We don't really need to call the database, get the data, and then return it back. We can directly cache it here and return that data back. That is basically the concept of caching. When it comes to Hibernate, there are two different levels of caching. The first one is called a first level cache and the next one is called a second level cache. So what is the difference between the first level cache and the second level cache? Let's get a quick overview. In any typical application, there are multiple transactions going on in parallel. Over here, we have 4 transactions which are running in parallel, and each of these transactions is associated with the persistence context of its own. So each of these transactions have a persistence context where all the entities that are being modified during that transaction are tracked. So transaction 1 has its own persistence context. Transaction 2 has its own persistence context. Transaction 3 also has its own persistence context. So let's say during transaction 1, I'm retrieving the details of the same course again and again. Let's say I'm retrieving the details of course with ID 10001 3 times. What would happen is Hibernate will not go to the database all the 3 times. The first time it would go to the database, retrieve the details, and it will have it inside the persistence context. The next time you ask for the same course details, Hibernate would actually return it back from the persistence context. It will not really talk to the database. It will directly pull it from the cache and return it back. This is where the first level cache comes into picture. The first level cache is within the boundary of a single transaction. Within the boundary of the single transaction, if you are trying to retrieve the same data again, the first level cache comes into the picture. The second level cache comes into picture across multiple transactions. Let's say you have one instance of an application deployed on a application server or a web server, and there are multiple users using this application. Irrespective of the users, the list of states or the list of countries are the same. The list of countries, list of states, all this kind of stuff does not change with the user. What we can do is we can store such information in the second level cache. Second level cache will typically store the common information for all the users of an application. So let's say the application has just launched up and there's a request for a list of countries. What would happen? The transaction 1 goes to the persistence context and we would go to the second level cache. The details are not in the second level cache. So what would happen is we would go to the database, get the details, put it in the second level cache. And from then on, any of the requests in any of the transactions thereafter, the data would be retrieved from the second level cache. We don't really need to go to the database. In this quick video, we looked at what is caching, what is first level cache, and what is second level cache. The concept of caching is really simple, right? So instead of going to the database, instead of making the round trip to the database for every query, for the data which we know will not change, we would cache it and use it from the cache. The first level cache is data that is specific to a single transaction. So within a single transaction, if you are requesting for the same data again, the first level cache comes into picture. And the second level cache comes into picture for data which is common across multiple users. In the next step, we would talk about first level cache and also implement a sample example with first level cache. Until then, bye-bye. Welcome back. In this step, we would talk a lot more about the first level cache. Let's take a very simple example. Let's say I'm taking the course repository test. I'm copying the find by ID basic test. I'll call it find by ID first level cache demo. Let's also add in an add transactional to make sure this runs within the boundary of a transaction. So I'm saying add transactional. I'll use Spring Framework transactional. Now, when I run this, you know what would happen, right? So we are just find by ID 10001 and checking those details. So you know that a query gets fired down to the database. Let's see what happens. What is happening here is a query gets fired to the database. Select start from course, where course ID is the ID which we are passing in, which is 10001. Nothing earth shattering in there. It's what we have been doing throughout this course. Now, what I'll do is I will try to retrieve the same details again. So what I'm doing is I'm saying course 1 is repository.findID 10001, and Again, I'll add the same assert in. Between this, what we'll do is we'll log something as well. So I'll say logger dot info first course retrieved. After that, I'll put first course retrieved again. We can add in the course details as well. So course and course 1. We are actually trying to retrieve the same details. So the same course, we are trying to retrieve it twice. Let's see what would happen. The test would obviously succeed. We are not doing anything specific, but what we are interested in is what's happening in the background. You can see that a select query is getting fired on the course 10,001, and you can see that the first course retrieved is printed JPA in 50 steps, and immediately the first course retrieved again is being printed. After the first course retrieved, what we have is a query. So after the first course retrieved, we are actually trying to do a find by ID again. But what you would see in the log is there is no query that is being fired to the database. So between first course retrieved and first course retrieved again, you don't see any query being fired to the database. This is because within the scope of a transaction, within a persistence context, the data for the entities is cached. So the data with the course entity 10,001 is cached, and when you are asking it for the second time, the data is retrieved from the cache. This cache which comes into picture over here with this specific statement is called a first level cache. The first level cache is within the boundary of a single transaction. If I don't have a transactional in here and I run this, what would happen? You can see that first a query is being fired with 10,001, and I go further down, you would see that the session metrics are printed and first course retrieved is printed. And after that, you'd see that the select query is being fired again. And you'd see that after a little while, after the session metrics is when the first course retrieved again is being printed. This is because these two calls are using two different transactions. I am not providing a transaction in here. So I'm saying, not saying a transactional. So the transaction here, now the boundary of the transaction is provided by what? It's provided by the course repository. So we have a transactional in here, and each method call runs within its own transaction. So this method call uses its own transaction, and the second time I call it, a new transaction is created again. That's why we see that the course details that are retrieved by the first call are not being cached, are not being used by the second call. This is because these are running within two different transactions, because we have not specified the transaction boundary in here. The transaction boundary is whatever is specified by the repository. In this step, until now, we looked at two very important things. One is first level cache comes into picture within the boundary of a transaction. If you are retrieving the same data again within the same transaction, you would not go to the database, you would directly retrieve it from the first level cache. The most important concept when you want to make use of the first level cache is the boundary of the transaction. If you want to make the best use of a first level cache, then the boundary of the transaction should start with the service method. So starting with your service method, all the calls to the data layer should be within the scope of the single transaction. Then the first level cache will be really efficient. In this step, we looked at the first level cache. We saw that the first level cache acts within the scope of a transaction. If the same data is retrieved twice, then we would retrieve the data from the first level cache. We would not really go to the database. And the most important thing with respect to first level cache is the boundary of the transaction. The ideal place to start and end the transaction is your service methods. That's basically your business service methods or the business layer. In the next step, we will talk more about the second level cache. Welcome back. In the previous step, we talked about the first level cache. We saw that the first level cache was active by default. We did not really need to configure anything at all. In this step, we would talk about the second level cache. The thing about the second level cache is second level cache needs configuration. You cannot cache all the data at the second level cache because Hibernate does not know what data is not going to change. You would need to tell Hibernate what is the data which is not going to be changing between multiple transactions. What is the data that is common to multiple users? Once you specify that, we can use a second level caching framework, for example EHCache, to cache all the common data. In this step, we would implement a simple second level cache using EHCache. Let's get started now. The first thing that we would need to do to make use of a second level cache is add a dependency. So I would need to add a dependency to the pond.xml. The dependency I will add in is EHCache. Dependency, I'll add in a group ID and an artifact ID. The group ID we would want to use is org.hibernate. And the artifact ID is hibernate-eh cache. You can save the pond.xml and you would see that this might take a little while for building it, because this might download the dependency and set it into your class path. Once you have configured the dependency, the next step is to configure the cache. So I would want to use a second level cache, and I would need to tell Hibernate to enable second level cache. So second level cache, Hibernate, sorry, EHCache. So I'll try and configure the second level cache in here. So what are the important properties that are related to the second level cache? The first thing I have to do is to enable second level cache. I need to tell Hibernate to use the second level cache. That's number one. The second thing I would want to do is to specify the caching framework to use. So I would want to tell Hibernate use EHCache implementation. The third thing I would want to do is to tell Hibernate that don't cache everything, only cache what I tell you to cache. All the data might not be cacheable. If a data is going to change between multiple transactions, then I don't really want to cache that. I would want to only cache the data that will not change between multiple transactions. So I would need to tell Hibernate only cache what I tell you to cache. And the last thing I would need to tell is what data to cache. So these are the four things that I would need to do. Let's make them in a comment so that this would not affect us. Okay, so these are all in a comment right now. So the first thing I want to do is enable second level cache, and enabling a second level cache is a Hibernate property. So I would copy Spring JPA properties.hibernate. So I'm copying that in here, and property to enable second level cache is hibernate.cache.use second level underscore cache is equal to true. It's very simple, right? So hibernate.cache dot use underscore second underscore level underscore cache is equal to true. Enable second level cache. Very simple. The second thing I would need to specify is how to do the caching. So I'll copy up to the cache from here, and cache dot region dot what is the factory class to use. You can type in so Control Shift R, EHCache, or Control Shift T actually. Control Shift T to open up and search for a type. EHCache region factory. I would want to use the one from org.hibernate. So let's open that up. My Eclipse is configured to download the sources. So what I can actually do is, instead of trying to type it in, I'll say right click and say copy qualified name. So what I'm trying to do here is instead of typing it out, I'm trying to copy it in. So I'm saying, okay, use cache, use this factory class. So it's org hibernate cache, cache region factory. So that's the second thing. We are specifying the caching framework. I need to tell the caching framework, don't cache everything. I'll tell you what to cache. How do I do that? For a change, this is a JPA property. So what I would need to do is spring.jpa properties dot javax dot persistence dot shared cache dot mode is equal to enable selective. If you go to the javax.persistence.shared cache mode, there are a lot of different options that are present. So you can see that the options which are present is all. So I want to cache all entities, or I can say none. I don't want to cache any of the entities, or I can say enable selective. So enable selective will be enabled for those entities for which cacheable is true. So for those entities where caching is enabled using cacheable annotation, we would want to enable caching. That's enable selective. Disable selective is the opposite. It will enable caching for everything, and you have to specifically disable whatever you would not want to cache by specifying a cacheable false. These are the options that we have. The best way to enable a second level cache is by using enable selective, because that gives you the option to say what I would want to cache. You don't want to enable caching on everything, because if you talk about any typical application, most of the data would keep changing. So you don't want to cache that kind of data. You only want to cache the data which does not change. So it's easy to specify what's not going to change. In this step, until now, what we did is we added in a dependency on Hibernate cache, and we configured a few properties to the second level cache. We enabled second level cache, we specified which framework to use, and we told the caching framework to only cache what I tell you to cache. In the next step, what we'll do is we'll tell the caching framework what data to cache by specifying the cacheable on the entity, and we will see what would happen in the background. Until then, bye bye. Welcome back. In the previous step, we added in the dependency for cache. We configured Hibernate to use the cache. And in this step, we will enable the caching for a specific entity and see what happens in the background. So until now, we have configured these three things: enable second level cache, specifying the caching framework, and we said the caching framework only to cache what we tell it to cache. One of the things I would want to enable is I would want to enable a logging level. So logging dot level dot, I want to enable the logging for cache. So I'll say logging dot level dot net dot sf dot cache is equal to debug. So we are setting the logging level for this particular package, whatever is inside this specific package, to debug. This would enable us to see a lot more information in the log about what's happening in the background. And now we would want to enable what data to cache. In our example, we have a lot of entities which are present in here. Let's just assume that the course details are not going to be changing very frequently, and I would want to enable caching on the course details. So I would want to be able to cache the course details across multiple transactions. What I'll do is, before I enable caching on course, let's run the application once and see what would happen. So I'm starting up the demo application. In the browser, I would type in the URL localhost 8080 slash courses slash 10,001. So I'm trying to retrieve the details of this course. What you would see is there would be a total of two JDBC statements which are being fired. One to retrieve the details of the course, and the other one to retrieve the details of the reviews for the course. You can see that the details of the course are present in here and the reviews are present in here. Now what I'll do is I'll clear the console out and refresh. So I'm sending the same request again. So this would create a new transaction. So this is the second transaction which we are creating. I refreshed it and you would see that the queries get fired again. So the select from course is fired again. And next the select from reviews is fired, and you would see that there are two JDBC statements that are being executed. You can try refreshing this 100 times and you would see that all the 100 times the queries would be fired to the database. Both the queries would be fired to the database. So let's now assume that the course details will not change. The reviews might change. So the details of the reviews for the course might be changing. But the course details, let's say, will not change as frequently. And I would want to cache the course details. I don't want the course details to be retrieved from the database each time. I would want to get them from the second level cache. How do I enable this? The way we can enable this is by just adding an annotation at cacheable. So at cacheable, we would use the JavaX persistence. And if I open up the at cacheable, you would see that the default is true. So we are saying at cacheable true. So that's cool. And now I would stop and start the application. The application has started up. I'll clear the console and I'm going to refresh this thing. So I'm going to localhost 8080 courses 10001. I'm going to refresh that again. So I've refreshed the browser. So you'd see that a query is fired to get the course details. Next, a query is fired to get the reviews of that specific course. And you'd see in the statistics that it says I have executed two JDBC statements. That's cool. And also you would see that there is an L2C puts and there is a L2C misses. We will talk about those things. So it's actually telling L2C stands for level 2 cache. So L2C puts means it has put one value inside the level 2 cache. And L2C miss and L2C hits, we'll talk about it a little later. For now, what I'll do is I'll clear this console and I'll fire the request again. Refresh. You'd see that there is only one JDBC statement that is being fired. And it says there is one L2C hit. And when I look at the queries, you would see that only the review query is being fired. So what is happening here is between the two different transactions, the course details are being cached. When I request the same course details again, the details are retrieved from the cache. So the order of things would be something like this. So when I ask for a course details of 10,001, when Hibernate is trying to look for the course details for 10,001, it would look at the second level cache. So it will look at the second level cache and see if it will be able to find the data because we have enabled caching for course. What would it see? That for that specific course, the data is available with this second level cache, and that's called a hit. A hit is when I am looking at the cache and I get the data. So what is happening here is we are finding the course data in the second level cache, and this is called a second level cache hit. Let's say now instead of retrieving the details of 10,001, I would want to retrieve the details of 10,002. Before hitting refresh, I'll clear the console out. Let's 10,002. You'd see that the details are being shown on the screen. One thing you need to remember is we have not executed a query against 10,002 course yet. So what would happen is the query is fired with 10,002 as the parameter, and also the reviews query would be fired as well. So two queries are being fired, and you would see that there is a L2C miss. What happens? Because we told it to cache courses, first thing what Hibernate does is it sees, okay, is there a course with 10,002 which is cached in the second level cache? It gets the answer that nope, 10,002 is not present in the second level cache. That's called a L2C miss. So that's a L2C miss, and that's the detail you would see. So it says one L2C misses. When there is a miss, what does EH cache do? What it does is it takes that data and puts it into the cache, and this is called a put. You can see here an L2C put. So basically what is happening is whenever you are requesting for some course, Hibernate checks with EH cache. Do you have this with you? EH cache looks at it. If it does not have the course with it, what it does is this is called a miss, and EH cache would update the cache with that specific data. And next time there is request for that specific data, Hibernate again asks EH cache, do you have this data with you? And in that second instance, because the EH cache already has the data with it, this would register a hit, and this is called a L2C hit. In this step, we enabled second level cache with EH cache, and we saw that we were able to cache data across multiple transactions. The most important thing about a second level cache is deciding what kind of data to cache. Once you have decided what kind of data to cache in the second level cache, everything else is very easy. In the last few steps related to caching, we started with understanding what is caching. We looked at what is first level cache. We saw that first level cache is specific to the data which is retrieved in a specific transaction. The boundary of a first level cache ends with the transaction. We also saw that first level cache is enabled by default. You don't really need to configure anything. After that, we moved to the second level cache, where we enabled second level cache by adding a dependency and setting a few properties into application.properties. And after that, we enabled second level cache on the course entity and tried to play around with it and understood what's happening in the background with second level cache. Until the next step, bye bye. Welcome back. Starting this video, we will look at a number of tips related to Hibernate. The first tip we would be starting with is something called a soft delete. Before we try to understand what a soft delete is, let's try to understand what is a hard delete. So this is the unit test which we wrote earlier, delete by ID basic. This is inside the course repository test. This calls delete by ID 10,002. So this is just a simple method which just says em.remove course. So this is through the entity manager we are trying to delete the course. What would happen in this kind of situation? You would see that delete from course where ID is equal to question mark 10,002. So this specific row is completely deleted from the database. What would happen? The 10,002 row would be disappearing from the database. You would not have any history of it. In some of the circumstances, you would want to keep the history of the rows. You can do that by implementing something called soft delete. Soft delete is done by adding a column to the database to track whether it's active or not, whether it's deleted or not. Let's do that in this specific step. I'll go to the course entity that we created earlier. So inside the course, we will add another attribute. So the attribute which we would want to add in is called private, and it is deleted. The type of this, I would make it Boolean. So it would have a value either true or false. It is deleted or not deleted. And if a row is deleted, what I would want to do is I would want to update this indicator to true. So whenever I would create a new data in the course table, this indicator would be false. But whenever a row is deleted, I would want to make this indicator as false. One of the first things that you would need to do is to go to data SQL and add the is deleted column in. So before that, let's start the application up. You'd see that this would fail. I'm going to run the delete by ID basic again, unit test. You can go to delete by ID basic and do a run as JUnit test. You'd see that this would fail. It says unable to load context because it says null is not allowed for column is underscore deleted. So for the column is underscore deleted, we would need to insert a value. In the data.sql, we did not put a value for is underscore deleted. So let's do that, is underscore deleted. I'll copy this, and the last value is initially all the rows are active. So I'll say is underscore deleted is false. And let's add in is underscore deleted. So be very careful with what we are doing in here. So comma is underscore deleted, comma false, comma is underscore deleted, comma false, comma is underscore deleted, comma false. That's cool. And now I can try and run that unit test again. We have not really added any logic to it yet. All that we are trying to do is make sure that the application is starting up fine at screen bar. So the application is starting up fine. That's cool. So we now have a new column called is underscore deleted in the table, and over here we have a new field is deleted. That's cool. Now what we would want to do is when we do a delete, so when a course is deleted, we would want to set the is deleted indicator to true. How do we do that? Let's see that right now. A word of caution again, we are going to use a Hibernate annotation. This is not a JPA annotation. This is definitely a Hibernate specific implementation. So the way you can do that is by adding a annotation at SQL delete. I'm saying import SQL delete, and I can specify a query. So you can say I would want on delete of row, I would want this SQL to be called. What is the SQL that we would want to call? We would want to say update course set is underscore deleted is equal to true. So we would want to set is deleted to true where ID is equal to question mark. So for that specific ID, I would want to set is underscore deleted to true. This is very simple JPQL, right? So I'm updating the course table, set is deleted is equal to true where ID is equal to question mark. Let's now try to run the delete again. So I'm doing delete by ID basic. You can also go to the course repository test and say right click, run as JUnit test. All that we are trying to do is delete a course. Let's see what would happen now. You would see that the test fails. That's very cool because it's expecting null, but it is getting a course back. But let's see what's happening in the background. In the background, you would see that instead of sending a delete query, now we are sending an update query. We are saying update course set is deleted is equal to true where ID is equal to question mark. So what is happening? 10,002, the column is deleted is being updated to true. That's cool. So just by adding a simple annotation, we got it working. So when a row is deleted, this query is getting fired. So we are updating the course and setting the is deleted to true. That is very cool. But what is happening is when we are retrieving the data back, we are still getting this back. So I'm deleting this course with ID 10,002. But when I do a find by ID, the row is coming back because the row is still in the database. What would I need to do to fix that? If I look at the query which is being fired, the query which is being fired to the database is select start from course where course ID is equal to question mark. This is not using the fact that there is now a is deleted column, and if the is deleted column has a value true, then I would not need to fetch that row because that is not an active row. How do I tell that? So how do I tell this entity to add a specific condition to all the select queries? The way I can tell that is by adding in an at where. So this where, whichever we are putting in here, I can add in a clause to this where. So I would say is deleted is equal to false. I would only want to retrieve those rows for which is deleted is false. Let's see if the unit test succeeds now. Let's run this again. Cool. The unit test succeeds. You see the green bar. And when I look at the queries, you can see that the update course set is deleted is equal to true is executed. So that is when we are trying to delete the course. So when you delete the course, the is deleted indicator is updated to true. That's cool. And next, you'd see that in the query, we are now using the is deleted indicator. So in addition to checking for the ID of the course, we are also checking for the is deleted indicator. 0 here represents false. 1 is true and 0 is false. So that's why 0 is going into the query. So now you can see that we are also checking for course dot is deleted indicator in the queries. So now what we have done until now is very simple things, right? So we wanted to do a soft delete. When we are trying to delete the course, we are not actually deleting the entire row. What we are doing is we are saying is deleted is equal to true. That's the only column that we are updating in this specific row. How did we do that? We achieved that by putting an annotation at SQL delete. Whenever a delete is done on a specific course, what happens? This SQL is being fired and the is deleted indicator is set to true. And after that, we added in a where clause to all the retrievals of a course because we don't want to retrieve the inactive courses. So we only want to retrieve the active courses. So we are adding an additional where clause. We are saying retrieve only those rows which have is deleted is equal to false. And we saw that both of these are working fine. In the next step, we would talk about a few more tricky things about the soft deletes. Until then, bye-bye. Welcome back. In this step, we would talk about two caveats which are associated with using the soft delete. We implemented soft delete by using at SQL delete and at where in the previous step. I want to open up the native query SQL stuff that we did earlier. So I'm opening up the native queries test. And one of the things which we did as part of the native queries is write a lot of tests in here. So I'll use the basic one. So native queries basic. Right click, run as JUnit test. The test succeeds. If you see the query which is being fired, it's select star from course. You see that the at where annotation that we have added in does not apply to native queries. That's one thing you would need to always remember. If you're using a native query, it's on you to add the is deleted. So you need to say where is underscore deleted is equal to 0. 0 represents false, right, in the query. So now it's on you to make sure that the is deleted condition is added in to all the native queries. That's number one. Native queries don't use the at where annotation. So if you are using native queries, then you have to add the deleted condition by yourself. The second important thing that you need to understand is the fact that Hibernate does not know what's happening inside here. So when you are deleting a course entity, we provided a where clause, and this where clause is just appended to the query. That's it. Hibernate does not know that actually that the is deleted column is being set to false. Let's take a quick step back and look at what's happening. So I'm calling the delete by ID method here, and the delete by ID executes a find by ID first. You get the course and you are removing the course in here. What is happening when I try to remove the course is because there is a at SQL delete annotation, this SQL is getting fired. So what happens is deleted is being set to true. If you look at the attribute is deleted in this specific course, the value would still be false because Hibernate has no idea about the fact that you are actually setting is deleted because that's done in a query. The solution to that would be to set the is deleted attribute on the course to true whenever we call the em.remove method. But that's a little bit of a risky thing to do, because that would mean whenever we try to delete a course using the entity manager, you need to remember that course.isDeleted has to be set to true. Otherwise, if any other thing is trying to retrieve the course in that specific transaction, it would get the non-updated course entity. Or the other option is to use one of the entity lifecycle methods. Whenever a row of a specific entity is deleted, there is a method that gets fired. That's called at pre-remove. So this pre-remove annotation, whichever method is on it, would be called whenever a row of this specific entity is deleted. So let's say private void, you can call this anything. I'll just say pre-remove, and I would say this dot is deleted is equal to true. So what we are doing is whenever this row is deleted, we are directly setting the value of is deleted to true. So that inside the same transaction, if some other query is retrieving this entity, it would have the updated value of is deleted. We can copy the logger in from course repository just into course, and I would say logger.info in here. So pre-remove, what I want to do, logger.info setting is deleted to true. Let's now go to the test and fire up the delete by ID basic. Aha, Hibernate is trying to map my logger as well, and that's not really cool. I don't want the logger to be mapped. Let's make it static to keep things simple. So I'll say private static logger. This is the logger, and I cannot do this .get class anymore because this is not there. We don't have this because this is a static nav, and I can say this .get logger codes.class. And if I made it static, I have to also rename. So I'll say logger. Okay, please. Now, so we are now setting this to true, so that's cool. Let's save this and let's get this thing kicking. That's cool, a green bar, but what we are really interested in is what's happening in the background. Let's see if the pre-remove hook we have created is fired. I'll search for this in the log. You can see that this method is being called. In this step, we looked at two important things. One of the things is whatever we specify in @where does not apply to native queries. So whenever you're doing native queries, it's on you to add the constraint is deleted is equal to false. The second thing which we saw was the fact that when we try and execute a delete, this query gets fired and the column gets updated in the database. However, the entity in the cache does not get updated because Hibernate does not know at all about what's happening in this query. So what we did was to create a pre-remove hook so that we update the entity to have is deleted attribute set to true. In the next step, we would look at a few more tips related to Hibernate. Until then, bye-bye. Welcome back. In the previous step, we saw that the entity in the cache was outdated when we performed the delete operation. And we used a pre-remove hook to update the entity to have the correct is deleted attribute value. The thing is, pre-remove is not the only hook which is present. You can track other entity events as well using other hooks or other annotations. In this step, let's take a quick look at them. The important annotations related to lifecycle methods in an entity are highlighted on your screen right now. So post load, post persist, post remove, post update, pre persist, pre remove, and pre update. The first one is post load. If you mark a method in an entity with the annotation at post load, it would be called as soon as the entity is retrieved and loaded. So if there is a select query fired and that specific entity is being loaded, this specific method on the entity would be called. The post persist is when you call the persist method. So when you say entity manager.persist this specific entity, the post persist method would be called. It would be called after the entity is persisted to the database. The post remove would be called when you would delete an entity, when we would remove an entity. So you would say em.remove a specific entity. The post remove would be called after the entity is removed from the database, after the delete query is fired. The post update is after an update to an entity is fired to the database. The other attributes which are present in here are pre-persist, pre-remove and pre-update. These are all called before persisting. So before you persist the data, you would call pre-persist. Just before you remove an entity, you would call pre-remove. And just before you would update an entity, you would have pre-update method call. So these are the different annotations which are present. So you can put these annotations on different methods in the entities and try and play around with them. Until the next step, bye bye. Welcome back. Until now, we had looked at a lot of relationships, so one to one, many to many, and things like that. Let's say I have an address for a student, so private address, and let's say there is only one address per student, and this address table has a certain number of attributes. So let's create a new class. I'd want to create a class called address. I'll use the same thing, and let's say this address has a few attributes: private, string, line 1, and let's say it has line 2 and city. I mean, you can have many more attributes in here, but for now let's say it has a line 1, line 2 and city, and the student has a address, and the student has one address. What I want to do in this specific example is look at scenarios where I would want the address fields to be directly present in the student. So I don't want to really create a relationship like this. So here the passport is a separate table and student is a separate table, and we are creating a one-to-one relationship between them. For address, I don't want to do that. I would want to actually directly store the address fields inside the student table. I would want to have a separate class called address because I can reuse the address class in other places. But the address fields, I would want them to be present in the student table itself. How do we do that? That's basically what we would be looking at in this specific step. If I want an object to be embedded in another entity, I would need to add an annotation called add embeddable, and I'm using the Java x.persistence embeddable. So now this address becomes embeddable in other entities. I'll also create a constructor quickly, so Alt Shift S, generate constructor using fields. I'll generate a quick constructor. We have a constructor for the address now, and I'm going to the student, and over here I would need to say this is embedded. Let's also add a getter and setter for the address. Generate getters and setters for address and say OK. So now we have get address and set address. How do I set the address for a specific student? I can go to the student repository test, pick up one of the existing students and try to add an address to it. So I'll copy this test, and what we want to do is set address details for a student. The same things that we would do now would also apply to inserting a student as well. So let's take the example of an update. So I'd want to student dot set address. I want to say new address of line 1, line 2 and city. Let's say city is Hyderabad, number 101, some street. Now I've updated the address. Now I can use em.flush to ensure that at this point this update would be pushed to the database. So let's see what would happen. Right click, run as JUnit test. Aha, I get an error saying no default constructor is present. The important thing is not just for your entity, but even for the embedded stuff, you need to have a default no argument constructor. So let's provide that protected address. Okay, let's make JPA happy by providing the no argument constructor and kick this test off again. Okay, the unit test succeeds and I'm searching for number 101 and you can see that a update was fired to the database. You can see that an update student set city is equal to something, line is 1 is equal to something, line 2 is something is fired to the database. The other thing you can also see is the create table script. So if you search for create table, you'd see that the student table is created with all the necessary columns. So you can see that the create table is created with the columns belonging to address. So city, line 1, line 2 are present directly in here. If you would want to pre-populate the data for address for a student, you can go to the insert into student and you can directly set the address columns values also in here. So one of the exercises you can try and play around is populate the address value, pre-populate the address value and see if you can retrieve the details of the address for the specific student by using the find method. If you execute a find, you would see that you would also get the address details back because the address details are part of the same row in the table. The other exercise you can try and do is to create a new student, set the address and try to save the student down to the database. So try to insert the student into the database. You would see that you'd be able to easily do those two things. In this step, we looked at using embedded to take the values from another object and directly store them as part of the current entity. So over here, all the attributes of address are directly stored into the student entity. We saw how to use the @embedded annotation and the @embeddable annotation. We also saw that we would definitely need to provide a no argument constructor, even though this is not really an entity. After that, we wrote a simple unit test to get a student from the database and update it with a new address. Until the next step, bye bye. Welcome back. When we created the review entity earlier, we created the rating as a string. But this is not really a good practice because there are 5 ratings that are possible for the review, 1, 2, 3, 4, 5, and I'm using a string. So there is a chance that the data can get corrupted. There can be a chance that there is some bad data that can get stored to the entity. I would really want to make this specific. So what I can do is I can create a enum for review rating. So instead of string, I'm saying review rating and I'm saying control 1. So I'll say create enum review rating. So I'll create an enum for review rating. I think this is good. Let's go ahead and create an enum now. And you can specify the values for it in here. So 1, 2, 3, 4, and 5. So let's say these are the 5 values I would want to store in a review rating, 1, 2, 3, 4, 5. And now you can see that the review rating, we are using a enum. The other thing I would want to do is to refactor this method. So right click, refactor, and I would say change method signature. And instead of string, I would want to use a review rating. And over here, I can specify a default value for review rating as well. I would say preview and I would say OK. You'd see that there would be a few compilation errors at this point. In the course repository, we are trying to make use of this review. So now this is no longer just 5. So this is now review rating dot 5. The same is the case in here. I've updated both these to use review rating dot 5 as the constructor. So this would fix all the uses of the constructor. So I would make sure that there are no compilation errors elsewhere. So this is cool. And now I would come here and update the getters and setters. So this is not going to be a normal thing right now. So this would be a review rating, and even this would be returning back a review rating. So what we are doing is we are upgrading the review rating from a string to a enum. So now we are making use of a enum. How do I say that this specific thing is a enum? The way you can say that is by saying at enumerated. This is a JPA annotation, and once I say this is an enumerated thing, you would see that the values for that would be properly stored. One of the other things that you would need to make sure is the data.sql. Right now, we are storing rating as a string 5, 4, and 5. By default, the value that gets stored to the database is the ordinal. What is the ordinal? For example, if I take this review rating, the ordinal for 1 is numeric 1, 2 is numeric 2, 3 is numeric 3, and 4 is numeric 4. This would be getting stored as a number. So if that's good for us, if we want to store it as a number, then all that I need to do is update this stuff in here. So instead of using a string, I'm using a number 5, 4, and 5. So what I can do is leave it at the default at enumerated, and now I would kick off the application up. So in this step, until now, what we are doing is we are updating the review rating to a enum. All that we had to do was create a enum and put at enumerated on top of it. By default, the column would be using the ordinal. So a numeric column will be created for rating, where you can store a set of numeric values. So let's see what would be there in the H2 console. Login, and we would want to look at the review table. You can see that the rating is a numeric column. You can see that rating is declared as integer 10. However, sometimes it might not be good to use the ordinal. Let's say this would have an ordinal of 1, this has an ordinal of 2, and this has an ordinal of 3. As soon as you add in another value, let's say I added in another value at the start called type B. What would happen? This now has the ordinal of 1. The ordinals are changing. So if you keep adding new things to the enum between or before, the ordinals keep changing, and that's not really a good database design. Rather than using ordinals, a better way to store the values for enums is by using enum type dot string. So it's better to store the string value. So I would rather store 1, 2, 3, 4, 5 as a string, because what would happen is later another value gets added in here. Let's say 0 is one of the review ratings that I would want added in later. The earlier rows which are entered will not get affected, because the ordinals, if you depend on ordinals, you are depending on the position, and that's not good. It's better to depend on the string. So now I'm making it a string, and now I have to use the specific string value. So I have to say 5. So this is exactly matching what's present in here. So I'm updating the data.sql, and this is 4, and this should be 5. And let's stop and start the application. You'd see that the application would start fine. And when I go to the H2 console, now the rating column is a varchar. So we are using a string to represent the enum, and you can see the values which are being stored are 5, 4, and 5. I would leave it as an exercise for you to try and insert a value for this rating and also update the value for this rating. Until the next step, bye-bye. Welcome back. In this small step, we would look at another important tip regarding Hibernate. Be very careful about what you are putting in your toString. In this course, until now, you would see that typically you would only put the name in the toString. So almost every entity that we created, we only put the name. This is specifically for a reason. For example, in here, in the course, if in addition to the name, let's say I'm trying to log the reviews for a course. So let's say I'm saying percentages name and reviews. So when I do a toString of the course, I am putting the name and the reviews as well. And let's say the developer of this specific find by ID, what he does, I'm actually creating a local variable for course. Inside the course repository, what he does is he logs this in. So he says, okay, I would want to see what the course details are, and he starts logging this information in here. So let's take this method find by ID basic and try and run this. Run as JUnit test. You can see that first the course details are being retrieved. The course details are being retrieved, and then review details are also being retrieved. Over here, we are printing the course and the review details. Now, you might wonder, why are the review details being retrieved where I am just asking for the course details? When I look at this piece of code, it's just saying repository.find by ID, and this specific thing is just logging the value which was returned back, the details of the course. So why are we retrieving the reviews? The reason why we are retrieving the reviews is because of our toString. In our toString, we are also printing the reviews of the course. So whenever the course is logged, the reviews also will be retrieved. So be very careful about it. Be very conscious about what you put in your toString method. If you're not very cautious about what you put in the toString method, you might end up with performance issues. Until the next step, bye-bye. Welcome back. The last tip we want to leave you with is, when do you use JPA? I would want to re-emphasize the fact that JPA is not a silver bullet. If you have a batch oriented application, for example, then do not go for JPA. JPA is really good when you are doing simple CRUD operations, simple mappings, simple queries, where 80 to 90% of the stuff is really straightforward CRUD kind of operations, and you have a few joins and things like that. I would definitely not recommend to use JPA when you have a performance intensive application, especially talking with thousands and thousands of rows in the database. While you can tune JPA with some of the techniques you would learn in the next section, it would definitely not give you a performance similar to, let's say, a store procedure or something on your database. So what is the right situation to use JPA? Number one, you should be talking to an SQL database. You should be talking to a relational database. Number two, you should have a static domain model. So you should have a domain model which is static, which is not created, which is not automatically generated. And you should be doing mostly CRUD operations: create, read, update, and delete. There might be business logic, there might be a few queries which are present around it, and there might be relationship between all these stuff. But essentially, JPA is for your transactional front end web application or your web service. If you have batch programs which are trying to retrieve millions of rows from the database and updating them, then JPA might not be the right choice. Always have this in mind when you are choosing JPA as the persistence mechanism for your application. I'll see you in the next step. Welcome back. Performance tuning is one of the most important things you need to understand with Hibernate. In the last few steps, Here and there we talked about a lot of things related to performance. In this and the next set of videos, we would be looking at performance tuning in depth. Let's get started with the first tip. Zero performance tuning without measuring. What do I mean? My favorite quote related to performance tuning comes from Donald Knuth. He's the author of the most famous book on computer algorithms, and he says we should forget about small efficiencies. Say about 97% of the time. Premature optimization is the root of all evil. Always, when you are doing performance tuning, do it only after you measure the performance. So measure the performance and then try to tune it. And for Hibernate, we have really great options to measure the performance. All that you need to do is enable the stats in at least one of the environments. Select an environment which has good amount of load and enable statistics and monitor the statistics in that specific environment. In this course, we have been running the entire course with our statistics on. So we were looking at statistics, we were generating the debug level stats and looking at the statistics in depth. So before you do any performance tuning, make sure that you are benchmarking and then do the tuning. So that's performance tip number 1 and the most important one. Measure and tune. Welcome back. In this quick video, let's discuss about another important performance tip. Actually, this is not really related to Hibernate as such. Any relational database needs to have good indexes. You need to understand how the details in a specific table will be retrieved, and you need to create the right indexes on that table. One of the ways to identify the right index is to look at the execution plans of your queries. Different databases have different ways of generating the execution plan, but once you have a query, you can find out the steps database is taking to execute that query. Look at them and identify the right indexes for your tables. For example, if you are looking at this course entity, the automatically index will be created on the primary key, which is the ID. But let's say there are a lot of queries on the course table using a name. Then it might make sense to create an index on the name. For example, if let's say students are often searched by using their address city. So if students are often searched by the city, then create an index on this city. This is the second tip on Hibernate tuning, which is not really related to Hibernate at all, but it's very, very important. So make sure that you identify the columns and which queries on your tables will be generated and create the right indexes on them. Welcome to the next tip on performance tuning with Hibernate. Use appropriate caching. Make sure that you understand first level caching and second level caching. There is another option called distributed cache. The first level caching is within a single transaction and it's automatically enabled. So make sure that you understand that, and also make sure that you are aware that you don't want to make the first level cache too big. If you are storing thousands of entities in your first level cache, regularly clear using the entity manager. If the size of your first level cache grows, then searching through it will also become inefficient. So if there are a lot of entities which are stored in your first level cache, be aware of that. The second important thing about caching is to make sure that you enable second level caching. Use a framework like EHCache to set up second level caching. The second level caching is useful to make sure that different transactions on the same server or the same instance of the application can share the common data. For example, things like countries, states, there would typically be a lot of drop down values which would be common for almost all the users. All that kind of stuff can be cached using second level cache, like a EH cache. Make sure that you go through your list of entities and identify which are the entities which are good candidates for second level caching and enable caching for them. The last option is also something called distributed cache. The second level caching is specific to an instance of the application. But if you are running a lot of applications in parallel, so let's say you are expecting a huge amount of load and one application is not sufficient to handle that. In that case, you'd be distributing your load among multiple application instances. And the distributed cache is useful to cache things across all the multiple instances. A good example of distributed cache is something like Hazelcast. I think implementing a distributed cache is much more than the scope I have set for this course. But if performance is really a concern, then you should definitely look at distributed cache as an option. In this quick step, we looked at the various caching options and the different things that you would need to be careful about. Welcome back. In this video, we would look at another important tip regarding Hibernate performance, which is eager versus lazy fetch. The thing about eager versus lazy fetch is there is no one good thing. Depending on the situation, a eager fetch might be good or a lazy fetch might be good. You have to evaluate it by your use cases. So if let's say entity 1 is having a one-to-one relationship with entity 2, the most important question you would need to ask is, do I need the details of entity 2 every time I retrieve entity 1? If the answer to your question is yes, then you can go with eager fetch. If the answer to your question is sometimes, then I would really recommend you to go with a lazy fetch. In the next video, we would look at how you can configure lazy fetch and do a eager fetch on certain limited occasions. So by default, we will use lazy fetch. But when the use case arrives for that specific situation, I can enable a eager fetch. We'll discuss that a little more when we talk about the n+1 problem. One of the most important things that you need to remember with eager versus lazy fetch is all the mappings ending with 2, 1. So it's many to one or 1 to 1 are eager by default. So the things which are ending with 2, 1 are eager by default, and the things which are not ending with 2, 1, that's basically the ones which are ending with too many, are lazy by default. In this step, we talked a little bit about eager and lazy fetching. In the next step, we would talk about an important problem, n+1. Welcome back. In this step, we would talk about one of the most important problems regarding Hibernate. It's called the n+1 problem. We would look at n+1 problem, try and understand it with an example, and we would look at how you can solve the n+1 problem. Let's get started now. Let's now try and understand what a n+1 problem is. What I'll do is I'll copy the course repository test and call this performance tuning test. Let's remove all the other stuff inside the test except for the first one, and I will start with putting a at transaction on this. I'd want the transaction to extend to the entire length of this specific method, so I'll say transactional. What I would want to do in this specific method is I would want to retrieve all the courses and their students. So what I'll do is I'll use the entity manager directly. So let's do entity manager dot create named query. I'll use the named query which we already defined on the course, right? So we have a named query which is defined in here, query get all courses, and I can say this would be returning a course. So we are creating a named query and what I would want to do is execute it, get the results list. So get the result list, what it would do, it would return a list of courses. So control 1, and I actually directly do that, list of courses. If you're sure that there is only one course that is returned by this, there is also a get single result back. That would return a single course back, but we expect multiple courses, so we use the get result list, and I'll remove the assert which is present in here. Once I have the list of courses, I would want to print the students for them. So what I'll do is I'll loop around the courses, course from courses. What we want to do is logger.info. What do we want to do? For this course, these are all the students. And how do I get that printed? So I need to just, it's comma, course. How do I get the course students? Course.get students. Because I kept the transaction alive, I can get the students in here as well. So we have that transactional in here. So now let's see what would happen when I run this. What you see in here are 4 JDBC statements are executed to select these values out. If you look in depth, you'd see that there are 4 basic queries which are being fired. The first query is to get the list of all courses. In this specific example, we returned 3 courses back. So now that we have the 3 courses, what would happen is an individual query gets fired for each of these courses to get its student. So this is the first query, this is the second query, and this is the third query. So 3 individual queries are fired on each of the courses to get these students. Imagine if there are not 3 courses, but there are like 1,000 courses. How many times the queries would be executed? The first query would return 1,000 courses back, and the subsequent queries would be executed for each of the 1,000 courses. There would be 1,001 queries being executed. That is what is called the n+1 problem. One of the easiest ways to fix the n+1 problem is go to the relationship. So go to students and make it a eager fetch. So right now this is a lazy fetch because this is many to many, and many to many, anything ending with too many is by default lazy fetch. So this is using a lazy fetch now. You can try to make it eager, but what would be the consequence of trying to make it eager? What would happen is anytime you retrieve a course, all the students for the course would be retrieved. And that's not really good because most of the times you might need just the course details. It would be only in specific circumstances you would need both the course and the students. The second option is something called entity graphs. In this option, we will not change the course entity. So by default, we will leave it at lazy fetch. But what we would do is when we are retrieving the courses and the students together. So I'll call this solving n+1 problem, and I'll call this the entity graph solution. So when we want to get the courses and the students in this specific method where we want to get both courses and students, what we can do is we can add a hint. We will say set hint. What's the hint? The hint is javax dot persistence dot load graph. What should be the value? The value to this is something called a graph. Let's create that load graph right now. So I'll create a local variable graph. It says object graph. The way we can create an entity graph is very simple as usual. Entity manager dot create entity graph, and we would want to create an entity graph starting with the course. So course dot class assign statement to a new local variable. I'll say this is entity graph, and in the entity graph I can define a subgraph. I can say add subgraph. What is the subgraph I would want to load along with course? What is the thing I would want to load along with the course? In this example, I would want to load the students. So I can say add subgraph students. I can take this into a variable. I'll call this subgraph. Actually, I don't need this variable at all. All that I would now need is the entity graph, and I can pass the entity graph as a hint to the query. So in addition to the query, we are adding in a hint and then we are executing it. What are we saying? We would want to use this load graph. We are saying I want to load course and the students as well. Now let's see what would happen when I run this. You can see that just one JDBC statement is being fired, and you can see that the joins are performed on course, student course and the student tables to retrieve all the details at once. So we are getting this course and the student details at once, and the whole thing runs very quickly. In addition to the entity graph, there is one more approach to solving the n+1 problem. Thing is called a join fetch. So solving n+1 problem, join fetch. So what I'll do is I'll create another named query in the course. So instead of query get all courses, I would want to create another one. I'll call this query get all courses with join fetch. What I would want to do is I would want to create a specific named query in here, and I will say join fetch. Who do I want to join it with? C dot students. So I would want to join with the students inside the course. I'll just give alias s. So I'm creating a query with a simple keyword called join fetch. What this does is it would retrieve the course and also it would retrieve the students for the course. What I can say here is use the named query. Now let's run this. You can see that there is just one statement that is being fired, and also you can see that there is an inner join that is being performed to fetch all the details of the course. In this step, we looked at n+1 problem and we looked at two solutions for it, entity graph and join fetch. The simplest solution for the n+1 problem is a eager fetch, but that's not really good. So we explored the other two options in detail. We created a query with join fetch as well as we created an entity graph and used it to load the specific things at once. So we loaded both the courses and the students at once. Until the next step, bye-bye. Welcome back. In this step, we would be talking about how to connect to other databases like MySQL or MySQL as we call it, or Oracle when we are using Spring Boot to do JPA. Actually, Spring Boot makes it a cakewalk to switch databases. All that you need to do with Spring Boot to connect to a different database is number one, add the dependency related to your database to the pom.xml. If you look at our pom.xml now, you'd see h2 in there. So this is the dependency that is used to connect to the h2 database. And because Spring Boot sees this in the class path, it would directly initialize a connection to the h2 in-memory database. But if you would want to connect to a different database, then you would need to add the dependency for that database in. So instead of h2, you would put in, for example, if you are connecting to MySQL, then you would put this dependency in. So it's MySQL, MySQL connector Java. That's number one. The second important part is to configure application.properties. In your application.properties, you would need to define how to connect to your database. So you need to define the URL, the data source URL to connect to, and you have to define the username and password to use. That's it. That's all you would need to connect to a MySQL or an Oracle database from your Spring Boot JPA application. All these notes is present on the home page of our GitHub repository, JPA with Hibernate. There's a separate section called Connecting to MySQL and Other Databases. However, one important thing that you would need to remember is that you are now responsible for creating a database and setting up the tables in the schema.
In all the examples we have used until now, the schema was being automatically created because Spring Boot knows that we are using H2 in memory database. But if you'd want to connect to MySQL or Oracle, Spring Boot will not create the schema for you in the database. It will not create the tables for you in the database. You would need to create them. One of the things that you can do is you can connect to H2 and you can generate the entire schema. The entire schema is generated in the log. So once you do this, you can take the schema, you can take the queries which are generated and run them on your database so that all the tables are created in your database. The detailed steps to install and set up the MySQL schema are present on the GitHub repository. I have also taken the schemas for the table and the data and made it available on the GitHub repository. This includes the details for our section on JDBC to JPA as well as JPA with Hibernate in depth. In summary, there are three steps in connecting to a different database. One is install the database and set up the schema, set up the tables. The second step is to replace the H2 dependency with the dependency for your specific database. The third one is to configure application.properties to connect to your database. That's it. You're all set to connect to any database with Spring Boot. Until the next step, bye bye. Welcome back. In this video, we will talk about how to design great applications with JPA. In this course, until now, what we have been doing is we added annotations on our entities. We defined relationships on our entities, and we looked at what kind of tables are created in the database. That's a really good approach when you are learning. When you're learning about JPA, you want to understand the different options that are provided in JPA, and you'd want to see the consequence of them. You want to see how the tables are created, how the data is inserted, and all that kind of stuff. However, once you become an expert at JPA, once you understand what are the consequences of different annotations, different mappings, different relationships, the best way to start building applications with JPA is to start with the tables first. The first thing you have to think about is your data. How do you want to store the data in your database? What are the different tables? What are the relationships? How do I prevent bad data to come into my database? What are the different constraints I would need to define? So start thinking from the perspective of your database. Once you think about your data, make sure that all the data is good. Then you can think about how to build the Java application to store that data into this database. You can start thinking about your entities, and then you can define the mapping between the entities and the tables, and also define the relationships between your entities. So the approach to build great applications is to start thinking from your relationships. Start thinking from your tables, and then get down to your entities, and then map your entities with relationships. I hope this you when you try developing applications in future. Until the next video, bye bye. Welcome back. In this video, we will talk about a few good practices in developing JPA and actually in general any kind of applications. One of the important thing is private. So all your fields in your entities, it's best to have them private. The other things you would want to have private is the member variables in your components. So course repository is using the entity manager. Actually, this entity manager also can be private. So try and make all the internal variables, internal member variables of all the objects in your classes as private. When you're using at auto wiring, actually I'm not using course repository.em at any place. I would depend on Spring to auto wire this in. It's always better to be safe than sorry. So always make sure that all the member variables in any of your components are private. As an exercise, I would want you to identify all the member variables which we have not made private during this specific course and make them private. The second best practice is to use an in-memory database for your unit tests. So in this course, what we have been doing is we were using in-memory database to create our application. In this course, we have been using an in-memory database for both the real-time application as well as our unit tests. But in real world, the real world code would be talking to a real database. But your test code can still talk to H2 and make use of H2 to do the unit tests. The advantage of using H2 is that your tests will be repeatable and they will not depend on the data in your database. Imagine if you are writing a unit test which expects 2 rows to be present in the database and some other developer deleting a couple of rows. So what would your unit test get back? It would get 0 rows back and your test would start failing. Why is your test failing? Is there a bug in your code? Nope, there is no bug in your code. There's a problem with the data in the database. An in-memory database helps you prevent all that. Because the data is stored along with your tests, the test would never fail because of a change somebody does to your data. The other best practice is because in your unit test you would want to have your own data. In the source test resources, have your data.sql. Here we were using data.sql in source main resources to initialize our data. That in real world applications, this data would already have been initialized. So you'd already have data. So your real world application, your deployed application does not need a data.sql. You don't want to initialize data or you don't want to change data there. You would need data for your tests. So that's where you would move your data.sql to source test resources. The last important best practice is to use assert in your tests. In some of the tests which we wrote during the course, we did not use assert equals or any of the asserts to check the result of the operation that we are performing. But as a good practice, try and make sure that you not only execute the operation, so this is called executing the operation, but also make sure that you're checking some values, some important values in whatever is returned back. So here we are checking assert equals the name of the course. Even here we are checking the assert equals name of the course. One of the exercises that I would recommend you to do is to find out the tests without asserts and try and add good asserts to them. You write unit tests to catch bugs and the asserts play a great role in making sure that your unit tests are checking for all these specific things. These are some of the good practices that we would recommend you to follow. Until the next step, bye-bye. Welcome back. In this JPA and Hibernate masterclass with Spring Boot, we covered a wide range of topics. We started with Spring JDBC and we talked about a lot of different concepts related to JPA. We talked about entities, annotations, relationships, inheritance hierarchies, entity manager, persistence context. And also, we talked about transaction management and performance tuning. We talked about different things related to caching with first level and second level caches. We also discussed various tips and tricks related to JPA. During the course of this journey, we also introduced you to the basics of Spring, Spring Boot, and JUnit. Our aim with this course was to introduce JPA and Hibernate to you with a lot of code examples. We hope we are successful in our endeavor. Good luck, and until we see you in another In 28 Minutes course, here's bye from the team here at In 28 Minutes. Welcome to this appendix section on Spring Framework in 10 steps. In this section, we introduce you to the world of Spring. We will help you to learn Spring by setting up a simple project and helping you understand the concepts of tight coupling, loose coupling, and also get you to use Spring Framework to make your application loosely coupled. We will understand the basics of auto wiring and also get the big picture of Spring modules and Spring projects. If you're already familiar with Spring, then you can safely skip this section. However, if you want to review your Spring concepts, then this would be a great section to do. The home folder for this specific section is 00 Framework Tools and Introductions, 01 Spring Introduction in 10 Steps. Once you go in here, you would see the details of the 10 steps and the complete code example. I'll see you in the first step. We would start setting up a simple Spring project.
Welcome back. One of the most important features of Spring Framework is dependency injection. Spring Framework helps in creating loosely coupled applications. To be able to appreciate dependency injection, you should understand tight coupling and how to create loosely coupled applications. What we'll start with is setting up a simple example to be able to understand tight coupling and also dependency injection. We will use a shortcut to create a Spring project. What we'll do is we'll go to start.spring.io. It's called Spring Initializer. If you do a Google search for Spring Initializer, so if you do a Google search for this Spring Initializer, you should be able to come here directly, or you just type in start.spring.io. Let's create a Spring project using Spring Boot. What we need to do is let's use Maven here. Java is our language, not Kotlin. Let's move to Java. We would want to use Spring Boot. I will use one of the latest versions of Spring Boot. If by the time you're watching the video, there is a released version of 2. something, you can use 2. something as well. So I'm using the snapshot version. You can actually use any version which is greater than Spring Boot 2. So M2 should also be fine. One of the things that you need to do when you create a project is to give it a name. Just like when you create a class, you give it a package name and a class name. When you create a project, you need to give it a group ID and then artifact ID. Let's give a group ID and artifact ID. So I'll call this com.in28minutes.spring.basics, and I'll call this as Spring in 5 steps. We might have a few more steps than 5, but let's just call it Spring in 5 steps. I don't really need to add any dependencies. When I create a project with Spring Boot, it would by default create Spring as one of the dependencies for the project. So I don't really need to worry about adding any other dependencies. I can go ahead and click generate project. What would happen when you generate project is a zip is created and it would be downloaded to your downloads folder. What I would want you to do is to unzip the zip. So unzip the archive, put it on some folder on your hard disk. Let's say c:/spring. Generate project, downloads a zip. If you have extracted the zip file to a specific folder, then you are ready to go into Eclipse and start importing that project in. So how do I import the project? It's very simple. All that you need to do is file, import existing Maven projects. So you can type in Maven here. You'd come on existing Maven projects, select existing Maven projects, click next, and then you would need to select the folder where you have copied the zip file to. So you have extracted the zip file to a specific folder, right? So you can either browse through that or copy the path to it and paste it in here. So I've actually put the whole thing in this folder, Spring in 5 steps. So I'm opening that folder up, and now you can see Spring in 5 steps, pom.xml in here. Just select that project, finish. If this is the first time you are working with a Spring Boot project, the import might take a little while. There are a lot of dependencies that it needs to download to set up this project. If everything works fine, at the end of a few minutes, you should be able to see a project like this. So what I see is source main Java. This is where the Java code will be written. Source main resources. This is where all your application properties will be residing. So test Java, this is where your tests will be written. And you can also see all the different Maven dependencies which are present in here. The great thing about creating a Spring Boot project is Spring is directly added in as a dependency. So you can see there's Spring context here, Spring Beans. So all these are already added in as your Maven dependencies. So you don't really need to set up a new project where I would add Spring as a dependency. All this kind of stuff are already made available to you, and that's the reason why we are using Spring Boot. So you can see here, you can see Spring Core, Spring Context, Spring Beans. All of these are already available to you to make use of. What we did until now is we used Spring Boot to set up a simple Spring example. There is not a lot of things that are there right now. So if you go ahead and run this, actually, if you say Spring in 5 steps application, go here and say right click, run as Java application. What this will do is this will launch up a simple Spring context. You don't really need to worry about it right now. We'll understand what a Spring context is and all that a little later. But you can see that this program successfully runs and prints something on the console. That's sufficient for this step. So in this step, what we wanted to do was to set up a simple example for Spring. If you are familiar with programming, you know what a search is, right? So you're given a number, you're given an array, you try to find the number in an array. For example, here, I would want to search this array for this number. A binary search is a specific search algorithm which expects the array to be sorted. For binary search, it's not okay if I send an array like this. What I would need to do is to sort the array, and then I would be able to search through that. In this step, we'll set up a simple example using Spring Boot to be able to do a binary search. The objective is to understand the concepts of tight coupling and dependency injection. In the previous step, we used Spring Boot to create a simple application, Spring in 5 steps application, and we were able to run it as a Java application. Now we would want to add the logic of binary search to this example. So I'll create a new class, Control N or Command N, and I would want to say new class, and next I would want to call this class as binary search IMPL. I will not use an interface for now, but I'll continue using binary search IMPL, and let's go and say finish. The first step of binary search is sorting an array. Binary search expects a sorted array. When I want to use binary search on an array, first thing is I would need to sort the array, and next I would want to search the array, and after that I would need to return the result. The result is typically the index. So if the element is present in, let's say, position 3, then I return 3 back. How do I design a method like that? One of the things that you need to remember is we are not really going to implement the entire logic for binary search. I would just implement high-level algorithm, if you can call it that way, just to get you understanding about tight coupling and loose coupling. Let's get started with a simple method. So now I would want to create a method to do a binary search. How would the definition for that would be looking like? Public int. So I would want to return the index back. So it's an int. I would want to call this method as binary search. The inputs for a binary search, as we discussed earlier, are an array. So I'll pass in an integer array. I'll call this numbers and the number to search for. So the first step of binary search would be to do sorting, right? So first you'd implement all the sorting logic here, implement sorting logic here, and then you would actually implement the search logic here. And after searching the array using binary search, you'd return the index of the result back. So let's say the index where it is found is 3. I would return 3 back. I'm just returning 3 to make the compiler happy. This is how your binary search algorithm would look like, right? So you just need to implement your sorting logic here, you would implement the search logic here, and then you would return a 3 back. Now I would want to use this binary search algorithm. One thing to remember is this is just a dummy algorithm. It's not really a real thing. So all that I would need to do to be able to use that here. So I'm opening up the Spring in 5 steps application class, which is in directly here. So I'm going here. I would want to use the binary search IMPL. So I would need to create an instance of it. So binary search IMPL, binary search is equal to new binary search IMPL. And I would want to do a binary search. So I can say binary search dot binary search of, I would need to pass in an array. So I'll create an array directly here. So new int with, let's say, a few numbers, 12, 4. I'm having a little bit of trouble with the auto thing. So let's type in 3 for now. Let's just have 2 numbers in the array and say save. And now I can go ahead and make it 12 and 4. So what we have created in here is we are sending in array, and this is the number we would want to search for in the array. And let's do a sys out of this, or what we can do is we'll take it to a variable. So int result is equal to this, and we print the result. Actually, the result is not really important. What we want to try to understand here is the concept of loose coupling. So let's run the JUnit test. Oh, actually it's a Java application. So right click, run as Java application. You would see that at the start 3 is printed because that's the result of this specific thing, because that's what is written back from here. That's cool. Now we have implemented a simple dummy method for doing a binary search. Let's say this is using the sorting logic is implemented by using bubble sort algorithm. You don't need to really worry about what the bubble sort algorithm is. It's one of the algorithms. So let's call it algorithm 1 or bubble sort algorithm. So let's say I have bubble sort algorithm which is used in here. This logic of binary search is tightly coupled to the bubble sort algorithm. What I mean by that is that if I want to change the algorithm, then I would need to change the code of the binary search. That's what tight coupling means. This binary search IMPL is tightly coupled to the bubble sort algorithm which is present in here. And that's not really good. Let's say over a period of time, things evolved and there's a new sorting algorithm. Let's just take quicksort for an example. I'd want to switch this to quicksort. Then I would need to change this piece of code to be able to use quicksort. Think of another scenario. So sometimes I want to use bubble sort, sometimes I would want to use quicksort. How do I separate them out? How do I make them loosely coupled? One of the things that we can do is we can actually start implementing a algorithm for bubble sort outside. So let's start with a simple thing. So let's start with taking bubble sort outside this search. So how do I do that? What I would do is actually start with creating a new class. So I'll start with creating a new class. I'll call this bubble sort algorithm. Bubble sort algorithm. Let's say this is the one which can do the sorting. So now I would say public. A sort algorithm takes an array of numbers and returns an array of numbers. So I'll say int and sort int numbers. This is what a sort algorithm does. You would put all the logic in here. So logic for bubble sort, and then you can return the sorted numbers back. One thing which is important for you to understand here is that we are not really implementing the logic. Let's assume that the logic for bubble sort is implemented in here and we are returning numbers back. So now this particular program has the capability to sort. So what I can do now is I can use bubble sort algorithm here. So bubble sort algorithm, so I'll call this bubble sort algorithm is equal to new bubble sort algorithm. Instead of, and to do the sorting, what I can do is say bubble sort algorithm dot sort numbers, and I would actually receive the result. So I would call it int sorted numbers is equal to bubble sort algorithm dot sort. So now this sorting logic is moved out. I can just implement the binary search logic here and return the index back. So the sorting algorithm of bubble sort is moved out. That's cool. Bubble sort is outside the ambit of binary search. So if anytime there is a change in logic of bubble sort, all that I will need to do is change the logic here. Nothing else needs to change. I have not solved the problem of being able to change the sort algorithm dynamically. So I would want to be able to run this binary search different sorting algorithm. In a way, this is better because this is now the sorting algorithm is now moved out. But still, I have the problem of not being able to change the algorithm. So let's say I quickly create a quick sort algorithm. So I'll just Control C, Control V, and I have a quick sort algorithm. Quick sort. So I'm not going to change anything in here. I'll just leave the logic as it is, and just let's say the logic for quicksort is what is being implemented in here. So now I would want to be able to switch between quicksort and the bubble sort algorithms dynamically. I would want the search algorithm, the binary search algorithm, to be more loosely coupled. I would want to be able to pass in the sort algorithm in. How do I do that? Think about it. This is more of a Java problem. Just think about it, and we will find the solution for it in the next step. In the previous step, we created two simple algorithms, bubble sort algorithm and quick sort algorithm. And in the binary search, we are currently using the bubble sort algorithm, and we are now searching for a way where I would be able to make the binary search use the algorithm I would want to configure. So right now it's hard coded to use the bubble sort algorithm. How do I make the binary search IMPL use a different algorithm? Like one way I can do that is just change quicksort here, but that would not serve the purpose because I would not be able to dynamically determine which algorithm to use. I hope you had time to think about the solution for this and you had the solution built in. Okay, let's now go ahead and implement a simple solution for this. The solution obviously is interface. I'll go to bubble sort algorithm and say implements sort algorithm. So right now there is no interface called sort algorithm. We'll create it right now. So I'll say create interface sort algorithm. All that I need to do is control 1 or command 1 if you're on Mac and say create interface sort algorithm, and that's cool. I would want to add a interface. I don't want to extend anything. I think that's cool. Now let's go ahead and finish. The sort algorithm is implemented. I would want to add one method to it. That's this. Now I have the bubble sort algorithm implementing the sort method. Now I can also make the quick sort algorithm implement this interface. So I can say quick sort algorithm implements. Cool, isn't it? Now you have quick sort algorithm and the bubble sort algorithm, both of them implementing the sort algorithm interface. I would want to be able to make the binary search use the algorithm dynamically. So I would want to be able to switch between the algorithms. How do I do that? The way I can do that is by making the binary search IMPL use the interface instead of the implementation. So I'm creating an instance of the sort algorithm in here. Obviously, since it's an instance, I have to make it private. And I'll also create a constructor. So all that you need to do is do a right click source. You can say generate constructor here, or you can say Alt Shift S or Command Option S, and you can say generate constructor using fields, and you can select the sort algorithm. And now I have a binary search constructor taking the sort algorithm as the input. What I would now need to do is to switch the program to use this sort algorithm instead of the bubble sort algorithm. So now the program uses sort algorithm. So what I'll do also in here is do a sysout of the algorithm which is being made use of. So I'm doing a sysout here saying sort algorithm. We have changed the binary search IMPL to use the interface. What we are doing in here is we have now separated the binary search IMPL from the sort algorithm it's making use of. You can dynamically decide which algorithm you'd want the binary search IMPL to use. This is basically how you make your code loosely coupled. When you hear people talking about interfaces making the applications loosely coupled, this is what they are talking about. So now I can dynamically supply what I would want to use. So say I would want to use it with bubble sort algorithm. Now I've created a binary search using the bubble sort algorithm. And you would see that when I execute this, I'll just comment this line for now. We'll use this when we actually run Spring context. For now, we are not running anything related to Spring. So let's right click run as Java application. You'd see that it's printing this in the console. What is it printing? Let's take this. The binary search is using what algorithm? It's using the bubble sort algorithm. If I actually want to change, let's say I want to change quicksort, all that I need to do is change it here. So I'm not changing anything in the implementation of binary search quicksort algorithm we want to use. So now if I run this right now, what would be the output? Awesome. Quicksort algorithm. What we have done is we have made binary search IMPL independent of the sort algorithm being used. You can create a new algorithm and you can start using binary search IMPL with this. Sort algorithm is a dependency of the binary search. So binary search depends on the sort algorithm. We are making the sort algorithm as a separate dependency and we are passing it in to the binary search IMPL. I have to still create the instance of binary search IMPL, create an instance of the quicksort algorithm and pass it in. Is there a way I can avoid doing that? And that's what we would discuss in the next step, where we would start bringing Spring into the equation. I'm sure this might be a little slow introduction to Spring because we would really want you to understand the concepts behind Spring. The most important concepts behind Spring are dependency injection and loose coupling. And if you understand these two concepts very well, you can make the best use of the Spring framework. And that's the reason why we are giving you an introduction, starting with a simple example. Now we have made it more loosely coupled. We understood what a dependency is. We understood what loose coupling means. We are ready to start using Spring to make this example even better. Until the next step where we will do that, bye-bye. Welcome back. This is how our code looks right now. One of the important things that you would already observe is the fact that we are creating objects. So we are creating an object of the algorithm, we are creating an object of the binary search, and we are actually wiring them together. And then we are invoking the binary search. We made the binary search loosely coupled by passing the sort algorithm to use as one of the constructor arguments. It would be great actually if some framework can take control of creation of the beans and the dependencies. What we are looking at on the screen right now is a very simple example, right? So we have one bean and one dependency. But if you look at a typical application, there might be 1,000 beans and 3,000 dependencies. You would want some framework to manage the beans and the dependencies. What we are calling as a bean is an instance of this object. So this is a bean. So I'm creating a new quicksort algorithm. That's a bean. So we would want to be able to create beans, and we would want to be able to wire in the dependencies. So we would want to be able to create new quicksort algorithm and wire it into the binary search IMPL. That's called wiring. So we would want to be able to create beans. We would want to be able to manage and populate the dependencies. We would want a framework to be able to do that. The Spring framework helps us to manage beans, wire in the dependencies, and do a lot of magic. One of the things we already know is the fact that Spring framework is already in our Maven dependencies. So we already know that the base framework of Spring. So Spring Core is already here, Spring Beans is already here, Spring Context is also here. We are getting these dependencies through something called Spring Boot Starter. Let's not worry about it right now. The most important thing is the fact that Spring is already available for us to use. To be able to make best use of Spring, we would need to tell it three different things. One is, what are the beans? So what are the different beans that Spring has to manage? The second thing that you need to tell it is, what are the dependencies for a bean? Binary search IMPL, if you look at it, the dependency for it is the sort algorithm. So we need to be able to tell Spring that, okay, sort algorithm is a dependency of binary search IMPL. So that's number two. The third thing we would need to be able to tell Spring is where to search for beans. Where to search for beans. If let's say you tell Spring that there are certain beans present. So I've told Spring about the beans and the dependencies. It needs to know where to search for them. So should I search in this package, or should I search it in another package? Where should I really search for the beans? These are the three questions we would need to tell Spring about. We need to answer them for Spring so that Spring would be able to help us to wire beans together. So the first thing we need to tell Spring Framework is, what are the different beans? To start off, what we'll do is we'll use bubble sort and the binary search IMPL. So I would want to tell binary search IMPL is a bean. How do I tell that? The way you tell that to Spring is by adding an annotation called @component. @component, control 1 or command 1, and you would be able to import the @component. I'm telling Spring what are the different components to manage. The other thing I would also want Spring to manage, for nav, like I would want to use bubble sort algorithm, so I'll make it a component. Bubble sort algorithm is nav managed by Spring as well. The second thing I have to do is, what are the dependencies of the bean? So we created two beans, right? So we said these are the two beans by using the @component. So in @component, I would need to tell Spring that this is a dependency. How do I tell Spring that this is a dependency? The way I would do that is by adding something called @autowired. So this is another annotation which is present in Spring, @autowired. So you can see it in here. So I'm adding an @autowired annotation on the sort algorithm. Now I'm telling that binary search IMPL depends on sort algorithm. Sort algorithm is a dependency for binary search. Bubble sort algorithm does not really have any dependencies. So I don't really need to add auto-wired in here. So the last thing that I need to tell Spring usually is where to search for beans. So if you look at all our classes are in the same package. Com in 28 minutes, Spring Basics, Spring in 5 steps. So that's where all our beans are. So the two beans that we have defined are basically the bubble sort algorithm and the binary search IMPL. So we would want Spring to search in this package. So we call that something called component scan. So we would want Spring to do a component scan in this particular package. We are using Spring Boot. Spring Boot would automatically scan the package where the main application class is present. So here, if you look at this Spring Boot application, so this is using an @Spring Boot application annotation. What the @Spring Boot application annotation does is it automatically scans the package and the sub packages of the package where this is in. So Spring in 5 steps application, which package is it in? It's in this specific package. Com in 28 minutes, Spring Basic, Spring in 5 steps. So automatically Spring Boot would scan this package and its sub packages for the beans. So there is no need to do this because we are in the same package. First two steps we have completed. What are the beans and what are the dependencies of a bean? That's pretty cool. So now we are saying Spring is going to manage these beans. I don't need to create this. The binary search, we said Spring would create it for us. So we said instead of we doing this creation of code, Spring would do that for us. I would want to be able to get the binary search from Spring. So I would want to get the binary search bean from Spring. How do I do that? The way you can do that is by using the Spring context. This is a line which we already commented. As we said, we are going to create a lot of beans. So Spring Framework is going to create a lot of beans for us. Where are all these beans going to be present? We would create a bean for binary search, we would create a bean for quicksort algorithm, but where would all these be managed? These would all be managed by something called application context. Spring application context is the one which would maintain all the beans. So what we would need to do is we would need to get the bean from the application context. So over here, if you look at it, Spring application.run. So we are running a Spring application in here. I'm importing Spring application. I'm again pressing Control+1. I would want to actually assign this statement to a local variable. The run method actually returns the application context back. So I would want to take the application context and do things with it. So what I'm doing is I'm taking the Spring application.run. It's returning me the application context. And from the application context, I would now want to get the bean. So application context dot get bean. What kind of bean do we want? We would want the bean of the binary search class. So binary search IMPL dot class. I would want to take this and assign it to a local variable called binary search. Take a step back and think about what are all the things that we have done in this step. First, we told Spring what are the beans. How did we do that? At component. Then we told Spring what are the dependencies of the bean. So how did we do that? At auto-wired. These beans are managed by the Spring application context. So we got an application context by running the Spring Boot application class using the Spring application class. This is by default. I mean, if you create a Spring Boot project using start.spring.io, this line is by default present. So what I'm doing is I'm taking that value and assigning it to the application context. So now I have an application context. From the application context, I'm getting the binary search bean. So I'm getting the binary search bean from the application context and executing it. For this specific example, all these things might look complex, but think about an application which has thousands of beans. The fact that you don't need to do this always, and you can directly get the beans from the application context, you can let Spring take care of the dependencies and their wiring. That makes it very easy to manage your applications. We will learn about all that kind of stuff in later steps, but for now, let's focus on getting this thing up and running. We'll add a small sysout at the end. So sysout control space system.out.println result. And if we remember things fine, actually we are already printing something in the binary search IMPL, right? So we are actually printing the sort algorithm. So we are printing the sort algorithm out, and also we are actually printing the result out. So what we have done is, instead of creating the instances of binary search and the quicksort algorithm ourselves and wiring them together, we made Spring to wire them together. And we are getting the binary search IMPL bean from Spring, and we are printing the result. Let's see what the result would be. Run as Java application. Okay, console. So if I see this, this is the output which is being printed. So let's copy this output out and see what's being printed. So we see that the component being used is bubble sort. That's cool because that's the one which we said Spring to manage. So we said Spring manage this component, and Spring is able to find that component and wire it in. And we see that the result is being printed 3. What we have done in this step is we made Spring manage our beans. So instead of we creating the bean for binary search, instead of we creating the bean for bubble sort, instead of quicksort, we used bubble sort. And we made Spring to do all the magic and create the beans for us. Spring is managing the beans for us. Spring is managing dependencies. So Spring manages the dependencies, injects the dependencies wherever they are needed, and it manages the entire life cycle of these beans. That's what is called dependency management as far as the beans are concerned. So Spring does dependency management as far as your Java classes, individual beans are concerned. In this step, we learned how to get Spring to manage the dependencies for us. There might be a lot of questions in your mind. Algorithm which is being used is bubble sort. How do I change it to use quicksort? And how can I do that dynamically? And there might be other questions as well. We'll answer those questions in the subsequent steps. Until the next step, bye-bye. Welcome back. In this step, we'll understand what's happening in the background. In the previous step, we added in add component, we added in add autowired, and then we added the code to pick up the bean from the application context and use that to execute the binary search. But what's happening in the background? Let's try and understand it using debug mode. We are using a Spring Boot application. The easiest way to put the application in debug mode, I don't want the entire application to be in debug mode. I just want to put Spring Framework in debug mode. The way you can do that is by using logging.level. You know that the Spring Framework starts with org. So I would want to start with org.spring frame. Okay, Spring Framework. That's cool. So that alone, I would want to use the debug level. So I'm logging all the log from Spring Framework at debug level. And now I can go ahead and run the application again. Cool. The application has completed running, and you'd see that there is a lot more log than usual. It's a lot of log for you to filter through. So the easiest way to find out what's happening in the background is just take binary search IMPL and keep following the progress of it. So you can start searching Control F and start searching binary search IMPL and keep following the path through it. So what I've done is I've actually done the search, and I've taken important snippets from the log and I have put them in this specific class. The first thing, as we talked about, is component scan. When we talked about creating the beans, we defined the beans, we defined the dependencies, and then we said we have to define where to search for the beans. And because this is a Spring Boot application, we said that this would automatically search in this package. That's called a component scan. So the first thing you'd see is a component scan being run. So it's saying searching this directory. So what I'm doing is searching this directory, which is the directory Spring in 28 minutes, targets, classes, com in 28 minutes, Spring basics, Spring in 5 steps. So that's basically this package. So I'm searching this package for any classes. What Spring does is it starts with a component scan. That's the first thing that Spring runs. Spring needs to know where the beans are. So it goes and searches this package. So it says, I'm searching this package. So I'm trying to find anything which is defined with an add component. One thing you need to remember is add component is not the only annotation that Spring searches for. There are other annotations we'll talk about in future steps. But for now, add component is the thing Spring is looking for. because that's the only thing which we have used until now. It's searching for classes with add component. So now it says I have found two classes. Which ones? I found binary search impl.class and bubble sort algorithm.class. These are the two classes which have a component in there. So it's saying identified component class. So Spring is searching. So Spring, what it does, it goes to this package, it searches through all the classes and finds the components. The only two components that we have defined in here are binary search impl that has a add component, bubble sort algorithm that has a add component. The remaining classes we have not put add component on, so they will not be found. So this is an interface, no add component on it. The remaining classes does not have add component on them. That's why they are not found by Spring. Spring only looks for those things which are identified by add component and a couple of other annotations which we'll discuss later. So the two components which are found are binary search impl and bubble sort algorithm. Once Spring has figured out what components it needs to manage, then it would start creating the beans and trying to identify the dependencies. It would start actually, if you look through the log, you can search for binary search impl, you would see something like creating instance of bean binary search impl. So it starts trying to create the binary search impl bean, but it sees, when I try to create the binary search impl bean, it would see that it has a dependency. Okay, to be able to create the binary search impl bean, I would need to actually create the sort algorithm as well. So it goes ahead and sees what else is there. So it goes next, it sees bubble sort algorithm. Bubble sort algorithm, it sees that it does not have any dependencies. So it actually then goes and says, okay, I'll create the instance of it. So it starts creating an instance of the bean bubble sort algorithm. It completes creating it. So bubble sort algorithm bean is ready. Then it sees that binary search impl actually needs bubble sort algorithm. So it says, I would want to wire them together. How does the auto wiring happen? If I open the binary search, I'm opening up the binary search impl class, the auto wiring would take place through the constructor. We have provided a constructor, so Spring would use this constructor to do the auto wiring. So the sort algorithm would be auto wired to binary search impl. That's what you would see in the log as well. It says auto wiring by type via constructor. So this is called constructor injection. In a later step, we'll try and differentiate between constructor injection and setter injection. And once the thing is auto wired, that's it. So the bubble sort algorithm bean is ready, so it can be finished. So the bean is created. So this is how Spring goes and creates all the beans. So whatever you put as add component, whatever you put as add auto wire, it would try to create the components. It would see if there are any dependencies. If there are no dependencies, it goes ahead and creates the bean. If there are dependencies, then it would start searching for those dependencies and try to auto wire them in. Spring does a lot of magic in the background. I would really recommend you to spend some time with the log trying to understand what are all the different things that are happening. In this step, we put application into debug mode and we looked at all the different things which are happening in the background. We got an in-depth understanding into how the beans are managed by Spring, how Spring Framework searches for beans, how it creates the beans, and how it auto wires them. Until next step, bye. Welcome back. In the last step, we tried to understand what's happening in the background. What's happening in the background when we are running a Spring application, how Spring creates beans, how it manages dependencies, and all that kind of fun stuff. We saw that we created an instance of the bubble sort bean. Now, what would happen if I put add component on the quick sort algorithm as well? So now there are two things that are matching. So now there are two components, right? So quick sort algorithm also is a sort algorithm, and also bubble sort algorithm is a sort algorithm. In the previous example, we saw that auto wiring was taking place by type. Sort algorithm. So this was also a sort algorithm. Quick sort also was a sort algorithm, and bubble sort also is a sort algorithm. In the earlier example, only bubble sort was having a component. So Spring picks up bubble sort, and it says there is only one component of that type, so it auto wires it in here. What we did now is we added a component on quicksort also, so there are two components on the class path. What does Spring do to resolve that? Let's try that and figure out a lot of variations of this concept. Let's run this application. Failed to start. Binary search IMPL requires a single bean, but actually two were found. So it's saying I need one sort algorithm, but you are giving me two. I can go ahead and remove the add component from the bubble sort algorithm. So I can say, okay, I don't want to use you. I removed that component from it. So what would happen now? Okay, it's using the quicksort algorithm. So that went through fine. Other way you can have done that is by using something called add primary. So now you have two components on the class path. So if you have two components on the class path of the same type, then I can make one of them primary, add primary, and press command 1. You can see that I have bubble sort add component, quicksort add component, and I have added in add primary. Let's see which one is used. Okay, it's using quicksort because quicksort has add primary. If you have more than one component matching a specific type, you can use add primary to give more importance to one of those components. A lot of students getting started with Spring find it difficult to understand what's happening in the background. Since you have a good understanding of it, you would be in good shape to solve any problems that would come up. So let's say what I'll do is I'll remove add component from the bubble sort algorithm. So now both the algorithms, both quicksort and bubble sort, they don't have component on them. So quicksort also we remove the component from. And now let's run the application. The log says application failed to start. So it says binary search IMPL requires a bean of type sort algorithm, but nothing was found for that. So neither the quicksort algorithm nor the bubble sort algorithm had a component on them. So they will not be found by the Spring framework when it searches for components. Or if you are actually, let's say I removed the add component on this as well. So let's go to binary search IMPL and remove add component from here. What would happen? Spring will not find any beans, so it will not create any beans at all. I've removed add component from everywhere. What would happen? It says in main, no such bean exception. So where is the error coming up? You know it. Here we are doing a get bean. We are trying to, from the application context, we are trying to get the bean of class binary search IMPL. But what we did here is we removed the add component for it. Spring will not know about binary search IMPL at all. So Spring is complaining, I have no idea what you are searching for. Go and tell me what you want me to do. So by the errors which it throws, you'd be able to understand what's happening in the background. If I add component, now it says I'm searching for sort algorithm, but I'm unable to find it. You have to make sure that you define an add component in here. So now I can go here and add component, add primary, whatever I would want to add in. And now I can run the application. You would see that it picks up the right one because I put primary on the bubble sort, it picks that up. Whenever you have any problems of the type a bean is not found or multiple beans are found, see if you have used the right combination of add component, add autowired, and add primary. Those are the important things you would need to know to be able to troubleshoot any problem with Spring Framework. So in this step, we looked at add primary and also we looked at a few troubleshooting tips related to solving Spring context issues. Until the next step, bye-bye. In one of the previous steps, we discussed about constructor injection. What we are doing in here is we provided a constructor for the sort algorithm. So the other way you could have done this is by using something called setter injection. So I'm removing the constructor and I'm actually generating a setter. So Alt Shift S or Command Option S or right click, source, generate getters and setters. I just want to generate the setter. So I would want to generate a setter for this. So now you would see that the setter injection would be used. So let's now run this program. I'll be searching for auto wiring by, so how's the auto wiring done? Auto wiring by type from bean name to bean. So it's now using setter injection. Earlier when we did this using constructor injection, this was the line which was in the log. Auto wiring by type from bean name via constructor. When we are using setter, it just prints auto wiring by type from bean name binary search IMPL to bean name this. Actually, you even don't need to create a setter. So let's actually remove this setter completely. So I'm just leaving at AutoWired. I'm not even creating a setter in here. Let's run this. Okay, please do save. I'll search for AutoWiring by, and you can see that the text does not really change. So we saw that when we use constructor injection, this is what happens, constructor injection. And when we use setter injection, this is what would happen. And we saw that if we just left at auto with no get setter or constructor, this is what is the log that is being printed. So these are the three options for using auto wiring: constructor, setter, and no setter or constructor. One thing you need to remember is the fact that these two are really the same. So whether you're creating a setter or not, the way Spring does the auto wiring is the same. So when people say setter injection, they would be either referring to any of these. You can even call this to be using setter injection. So if I just put auto wired here and remove the setter, this is kind of also termed to be setter injection, even though there is no setter in there. Basically, we have two options, right? Constructor injection and setter injection. So how do you choose between constructor and setter injection? Actually, the choice used to be really clear earlier. In the earlier versions of Spring, what we used to suggest to do is all mandatory dependencies should be auto-wired using constructor. For example, here, this is a mandatory dependency. Without sort algorithm, the binary search cannot work at all. So this is a mandatory dependency. If there is a dependency which it can work without, so if some dependency is not available and still the class can run, those dependencies are optional dependencies. So if you have mandatory dependencies, then the recommendation was to use constructor injection. For all other dependencies, the recommendation was to use setter injection. So if it's optional dependency, go for setter injection. Otherwise, use constructor injection. That was the recommendation with earlier versions of Spring. But with at AutoWired, what happens is, even though you're using setter injection, if a bean of at AutoWired is not found, so let's say you put at AutoWired and you don't have any bean of sort algorithm present in the class path, then what would happen? The context will not launch at all. So now actually there is not a lot of difference in terms of mandatory or optional dependencies. Typically in these days, most of the applications I have worked on use this kind of construction. So what this would do is I have no need to create a constructor. However, one drawback of this approach is that you can add a lot of dependencies. So because it's easy to now add a lot of dependencies, what people tend to do is add 5, 10, 15, 20 dependencies for a specific thing, and it would become very complex to manage. The same thing if there was a constructor injection being used, I would need to keep adding stuff to the constructor, and you'd see that the constructor has 15 arguments, which is really tough to maintain. So constructor injection kinds of makes those kind of problems very, very obvious. The setter injection kind of hides those dependencies, because all that you need to do is very simple, right? Create another dependency and just put at AutoWired on top of it. Other than that, right now, I mean, with the Spring framework as it is, there is not a great deal of difference in using setter and constructor injection. The lines have really, really become thin between constructor and setter injections. Whichever option you pick, I don't think you'd be doing very bad. Until the next video, bye-bye. Welcome back. In this video, we'll discuss about the modularity of the Spring framework. One of the important things about Spring is that it's not one big framework. So what do I mean by that? During the example, when we looked at the modules which were present, so if you look at the Maven dependencies which are present in here, it's not one big Spring jar which is present. There are a lot of small jars which are present. Spring context, Spring AOP, Spring beans. You would see other Spring stuff also right beneath. You can see Spring core in here, Spring JCL, and you also see the Spring test module in here. So Spring is not really one big framework. It's not like you have to use the entire Spring framework or you don't use it at all. Spring is built in a very modular way, and this enables you to use specific modules without using the other modules of Spring. Until now, whatever we have been using is the core container of the Spring framework. We were using Spring Beans, core, and context. So we were creating an application context, We were using Spring to manage our dependencies, that's beans. These were the core container modules that we were using until now. So until now, whatever we have seen, the examples which we have seen until now are using the core container module. Spring also has very good integration with data and integration layers. What do you mean by a data layer? Data layer is something which talks to a database, right? So I would want to talk to a database and get the data from there. Or I would want to store some data to the database. Or I would want to talk to other systems. So for example, I would want to connect to a web service. Those kind of things are called integration. I would want to probably send a message on a queue. Spring also has good support for those stuff. One of the important data access modules is Spring JDBC, which makes JDBC much more easier. Spring JDBC makes it easier. Something which would take 25 lines of code in JDBC would typically take 5 to 10 lines of code in Spring JDBC. The other thing Spring has is good integration with all ORM frameworks, object relational mapping frameworks. Some of the important object relational mapping frameworks are Hibernate and MyBatis. MyBatis is not really a true ORM framework, but it kinds of has some of the ORM features. Spring has good integration with them through the ORM module, and Spring has good integration with JMS. So you want to talk to some other application over the queue, then through Spring JMS you'd be able to talk to the other application. You can put messages on the queue, and wherever object to XML transformation is needed in those kind of scenarios, Spring OXM provides a lot of useful features. One of the important things with the data access or integration is the transaction management, right? So you would want all the steps in a transaction to be successful, or you would want all of them to be rolled back. So let's say if the transaction involves 4 steps and the third step failed, you'll want to roll back the first 2 steps also. So Spring has great support for transaction management. The other important Spring modules are inside the web space. So Spring has really good connections with web frameworks like Struts. Spring also offers a web framework of its own. It's called Spring MVC. And portlets are kind of outdated. I wouldn't really worry about portlets if I'm developing something right now. Spring has good support for WebSockets also. So we covered the data access layer, we covered the web layer. The focus shifts to cross-cutting stuff. What do you mean by cross-cutting? Typically, when you talk about applications, they have multiple layers. So we looked at things in the web layer, we looked at things in the data layer. There are things which are applicable to more than one layer. Those are called cross-cutting concerns. One of the cross-cutting concerns is unit testing. You would want to be able to unit test things in the web layer, in the business layer, and the data layer as well. Those kind of things are called cross-cutting concerns. So as far as the test framework is concerned, Spring has good support for unit testing through the Spring Test framework. Spring also enables implementation of things like security, logging through aspect-oriented programming. So Spring has a module of its own called Spring AOP to do basic aspect-oriented programming. If you want to do advanced aspect-oriented programming with a framework like AspectJ, Spring provides really good integration with it as well. In this short video, we were looking at the different modules which are offered by the Spring framework. It has solutions for the web layer, it has solutions for business layer, data access layer, and it has solutions for cross-cutting concerns. Until the next step, bye-bye. In the last step, we looked at different Spring modules. All the Spring modules have the same release version as the Spring framework. So they are almost like they are part of the Spring framework. There are other things Spring does other than the Spring framework and its modules. These are called Spring projects. These Spring projects provide solutions for different problems faced by enterprise applications. In this video, let's look at a few of them. Let's start with Spring Boot. Spring Boot is one of the most popular frameworks to develop microservices today. Within a few years, Spring Boot has become the most popular framework used for developing microservices. Spring Boot makes it very easy to develop applications quickly. With features like startup projects, auto configuration, actuator, Spring Boot makes developing applications, especially microservices, a cakewalk. The other important Spring project is Spring Cloud. We know that the world is moving towards the cloud, right? Everybody wants to deploy their applications in the cloud. And therefore, it's not sufficient if we develop good applications. We have to develop cloud native applications. We would want to be able to dynamically configure applications. We would be able to dynamically connect them. We would want to be able to dynamically deploy applications. Cloud native applications need a lot of different features. So if you have a microservice which is developed using Spring Boot, you can use Spring Cloud to cloud enable the microservice. Spring Data provides a consistent data access. If I go a few years back, there was only one kind of databases that we typically connect to. We would connect to a proper SQL database. Today, there are abundant of NoSQL databases. We have a mix of data sources. So we have we have a wide variety of NoSQL databases. We have SQL databases as well. How do you ensure that the way I'm accessing data from all this stuff is remaining consistent? That's what the Spring Data aims to solve. Spring integration, on the other hand, addresses problems with application integration. There is something called Enterprise Application Integration Patterns. It's a very famous book. Spring integration implements the patterns which are recommended in there. Spring integration helps us in connecting enterprise applications very, very easily. Not all processing is done online. Some of the processing is also done in batch applications. Batch applications have their own requirements. Like for example, I would want to be able to restart a bad job from where it failed. Or I would want to be able to track down exactly what's happening in a batch in much, much more minute detail. Spring Batch provides those kinds of features. It enables developing batch applications very easily. Security is one of the important parts of developing applications. You'd want your applications to be secure, whether you are developing a web application, whether you are developing a REST service, or anything that you develop, you'd want to protect it. So Spring Security provides solutions for securing your applications, whether it's a web application, whether it's a REST service. Spring has support for multiple security, or Spring Security has support for multiple security options like basic authentication, OAuth authentication, OAuth 2 for example. Spring HateOS enables you to develop HateOS compatible services. In REST, it's not sufficient if you just return the data. You'd also want to return the related links that would help the consumer to understand where to go from here. Spring HateOS would help you to do that very easily. What we are looking at are 7 of the Spring projects. They are just touching the tip of the iceberg. There are a lot of other Spring projects like Spring Web Services, Spring Session, Spring Social, Spring Mobile, and Spring Android, which are solving problems in various different spaces. The idea behind this video was just to introduce you to the wide variety of projects in which Spring is involved with. Spring has not really restricted itself to just the Spring framework and got involved in a lot of wide variety of projects. All the stuff you are learning as part of this Spring course would also be useful when you are developing on any of these Spring projects. If any of the projects seem interesting to you, I would really love if you can go ahead and explore it and find things about it. Until the next step, bye-bye. In the last few steps, we discussed about the most important features of Spring Framework. One of the important things about Spring is that it's one of the very few frameworks that remains as popular today as it was 15 years back. 15 years back, I was starting my career as a web developer, and I remember most of the frameworks from those days have lost their context. But Spring is one of the very few frameworks which retains its importance even today. So, what's the reason for this? How did Spring maintain its popularity through these 1.5 decades? That's the subject of this specific video. The most important reason Spring is so popular is because it enables writing testable code. The core feature of Spring is dependency injection, and if we use dependency injection properly, then we would be able to write unit tests for our code very easily. Spring has really good integration with frameworks like JUnit and Mockito, and it enables us to write good unit tests very quickly. The second reason why Spring is so popular, there is no plumbing code at all. What do you mean by plumbing code? I'll take an example. Look at this example which was done using JDBC. You can see that this is about 20 lines of code. I had to write a lot of code to get simple functionality working. If you look at code, most of it is involved in try-catch, in exception handling. Execute method throws a checked exception. So you have to really handle it. And once you have to handle it, then you need to make sure that everything is closed properly. And that's where Spring comes in. With Spring, the amount of code that you need to write becomes almost next to nothing. So if you look at the corresponding method in Spring framework, almost zero exception handling code, because Spring makes all its exceptions unchecked. So you don't really need to do all the exception handling and stuff. This code which you see in here is the plumbing code. So with Spring, you don't have any need to write plumbing code. There is no plumbing code at all. So if I'm writing 100 lines of code, it's most probably some business logic. It's not unnecessary code which is not needed by the application. The other reason why Spring is very popular is the architecture flexibility it brings in. As we looked at in the previous steps, Spring is very modular. There are Spring modules and Spring projects for very specific purposes. And I can use a specific Spring module without using all others. So even though Spring has a really good MVC framework, Spring MVC, it still offers good support to all the other MVC frameworks like struts. Even though Spring has its own REST support through Spring MVC, it does offer good support with Jersey as well. I mean JAX errors as well. If I use Spring in my project, my options are not really restricted. So if I choose to use Spring in my project, I still have the flexibility to choose other frameworks, and that's very important. And the last reason why Spring is very popular is it is able to stay with the trend. For example, in the last few years, there is a lot of evolution with microservices and cloud. And Spring is able to come up with projects which helps it stay relevant. Spring has introduced the new project called Spring Cloud. There is Spring Boot as well, which help you to develop microservices very quickly. So all these things help Spring stay current, and that helps Spring Framework retain its popularity. In this video, we looked at the 4 reasons why Spring remains popular. Because it enables testable code, because it does not have any plumbing code, because of its flexible architecture, and because it stays up with the trends. The idea behind these 10 steps was to give you a big picture overview of the Spring framework. We hope we were successful in doing that. Until the next step, bye-bye.